yeah, it was the right idea.
It was the right idea. It's just whatever. Risk 5 is the option.
Yeah, risk 5 is.
Well, okay.
Yeah, that's
So maybe I'm gonna change.
what time are we eating for now?
I need to change. Oh, that doesn't work. Is fine. It's all right. I'll shift it around. I'm gonna do. And then we'll cycle through.
It's fine.
Like trying to.
Okay.
On the top slides.
That's all. Well, what we can do is just open the schedule up and sort of have just a really quick 2-minute, hey guys, what do you think?
Well, I have
about
to
this?
do this.
Okay.
Do you want to try to redirect it? Do you want to?
Then in that case, let me just sort of stand out the other room, so I can sort of read
Yeah,
out.
you can hear it.
Yeah, that would be great. Aren't we supposed to be put on that E?
And we are supposed to, but there's no projector there, so we're gonna have this room for a while.
Oh, okay.
Oh, really? I have these stickers. Oh, yeah.
Alrighty. Hey, everybody. Thanks so much for coming. This is the Android BoF. We're sure to be stealing this room until 10:15. Scheduling snap. We got the projector here in the other room we built. More of this is kind of.
I put a sign on the window there.
So here's kind of a quick outline of what I've got as the schedule. John, I want to double check. Do you want to do it without slides or without the laptop?
Yeah, that's fine.
Okay, I just wanted to make sure moving that around is okay.
Yeah.
So let's see here. Yeah, thanks a bunch again. I really want to say thanks to everybody who put all the slides together at the Android conference. A lot of effort into the shorter lines together. So thanks so much. I guess with that, this is kind of the agenda that we've got. We will try to get through this kind of So as much of the slide stuff done, we have before we have to back into 10:15.
Sorry, can I ask a quick question?
Yeah, sure.
What's the scheduling time?
So basically the Android Mac conference is over in Key, but that is also the hack room, and it also has no projectors. And so we had a couple slides, and since this room is empty until 10:15, we're borrowing it, and then we're gonna migrate out right before that.
I thought there was supposed to be a hardware meeting.
Before that. This was one thing I canceled.
You're welcome to stay. Thank you very much.
Yeah, so basically the slide, which is in case, it's like we have several issues, and one of the main issues that we have right now is like, we have a problem with with one UFS host controller that is used by Pixel 6. And basically it's like, what it happens is like, when we try to enable 16K base access in Pixel 6, we were booting and then we were getting this error like, hey, the partitions were not found. And then after doing some digging, it turns out like the host controller that we were using, it didn't allow. It basically like didn't support to do transfers greater, so it was the page sizes. So in this case, it's like the page size was 16K. So basically, it's like we need to modify the driver to support segment transfers less than 16K. But when the patches were submitted, basically it's like they were rejected because literally it's like the patches were to fix a hardware, basically a hardware that didn't implement the host controller interface, right? So basically it's like as a backup we can support these patches as out of patches, records. But it's like I wonder if there's a way that we can submit these patches, because it's like there are around like more than 1 million devices, digital devices using this hardware that basically is not compatible with the host controlling interface. So I would think somebody has an idea about.
I guess, so one of the things I would kind of put as maybe kind of the community point of view is that, if there is hardware that is, broken, it kind of has there's this mix of pragmatism with, supporting stuff that's going to be out there for a long time upstream. And also like, how much of the core do we rework for broken hardware? And it kind of depends on the maintainer how they're going to land on that, because, reworking part of the subsystem to be able to support that adds a lot of logic that they have to maintain indefinitely. And if it's just for one controller, sometimes it's hard to kind of, reasonably keep that. But at the same time, there are a lot of quirks for a lot of, classic Intel laptops sort of things that are out there that's supported. And so to some extent, I think would be discussing with the maintainer probably is the best, like that's the person you're going to have to convince on this. I don't know, unless we've got one in the room, if there's going to be too much on that.
Yeah, I would think to look for
Yeah.
the maintainer.
Is there any other like ways of isolating the changes to the driver so that you didn't have any kind of more core logic changes to support it?
I think that right now is like, we talked with Bar, and then he already tried to minimize the amount of changes. And the changes are like, if you count the number of lines, probably it's 10, 20, and divided in 8 patches.
Mhm.
So basically it's like, the changes are not very intrusive.
Yeah.
I think it sort of depends if you can sort of find a way to find a higher purpose for the additions that are sort of general, then may have some other uses. Then in that case, sort of like, then you can sort of plug yourself into that general use, but you're one of the users of. and then this can be reused in other cases. That sort of is one way to deal with these sort of quirks, if that makes any sense.
That makes sense.
What were the actual concerns brought up by the maintainers? You said that like it didn't seem like this was going to get merged, but I'm just looking at the mailing list thread, and it doesn't look like they said there's no knack I can see for the patches. So
Well, basically, it's like the main issue is like controller that is used by Gixel didn't follow the standard, the host controller interface. Basically, it's like they mentioned that okay, the patch that you're sending is just fix this hacky hardware, and then we don't want to add these hacks to make this like this hardware to work. So basically, like they were mentioning that we should push our hardware manufacturers to follow the HCIA specification. But here's the problem: is like we already have these devices out there, and then it's like we cannot. I mean, with that software update, we cannot update the hardware. So basically, it's like that's the main concern. And then we gather some numbers, and it's not just like the Pixel phones, many Samsung devices, they already are using this host controller. So basically, it's like we put like the numbers, and yeah, there is like from 1 to 20 million devices out there using this host controller. But they don't have the problem right now because they are running with 4K. But if they want at some point to take to 16K, it's like it's not going to work. Basically, it's like that's one of the main things that we wanted to discuss. And then let me see. And let me also. Yeah, and another thing is like that. I mean, we welcome ideas. It's like basically it's like the compatibility solutions. When we enable 16K page sizes, and then we want to run 4K binaries. Basically, it's like it doesn't work because when the binaries are loaded, they are loaded. Basically, every segment in the binary is loading page size, and then it's like because when in the 4K binaries, the segments. Let me see. Basically, it's like in the 4K binaries, the segments are aligned at 4K boundaries. Literally, it's like when the loader tries to load this, it's like basically it's like it fails because in one page size you cannot put 3 types of permission. Like you cannot put read only, read write, and read executable. So basically, it's like one solution that we were discussing. It was like when we load the binary, basically it's like we set all the permissions for all the segments to read write executable, right? But because it has like security implications, it's like we are not going to move forward with this solution. And the other solution that we try to do is like basically is like use binary analysis to convert one 4K binary to a 16K binary. And basically it's like the main thing that we were going to do is like read all the L segment headers, update the alignment from 4K to 16K, do the same with the program headers. Like basically, like convert the 4K alignment to 16K alignment. But basically, it's like after writing a program that parse all the L files and we can compare field by field what it changed. It turns out that the dynamic section changed, the GOT table changed, the PLT section changed. So basically, it's like many things changed, right? And then it's like we were fixing the offsets for this, but then we're basically it's like the main roadblock came when we try to when we read the section that had code, like for example .text and .init, because these sections are supposed to have only code, but many compilers are embedding data into this code section. So basically, it's like when we were trying to fix the offsets, what it was happening is like we were also trying to change the data instructions. So basically, it's like this solution it was not feasible. So another solution that basically is like probably the last resource is to use PKVM to run the apps, the 4K apps in a virtual machine. But the problem with that is like what is going to happen is like all the performance gains with 16K page sizes are going to be lost, right? If we are using a virtual machine. So I wonder if anybody has any idea about how to run 4K apps in a 16K page size. or if somebody else has fixed this problem.
So I don't work on Android anymore, but if you're going to have the 4K apps running inside of the 16K thing with a KVM, you'll need to run a whole new Zygote, presumably.
And it's going to be like expensive. So that's the reason that's the last resource that we're exploring. We're trying to find it's like solutions kind of realign. I mean, do something with the L5 so we can run the 4K apps in the 16K.
What's ARM's answer to this?
Sorry?
What's ARM's answer to this? They're the one pushing the 16K. So they previously pushed 1K, and we told them to get stuffed. And now they're pushing 16K. Can we tell them to get stuffed again? Because this is the problem. Because what's going to happen to all of the apps that are on the Play Store, and longer term, the goal is to have fewer ABIs on the Play Store.
It's like our plan there. It's like we're going to recompile the apps in the Play Store. I mean, we're going to ask the developers to recompile the apps. And right now it's like we're in talks with the developers. But it's going to take, I mean, this transition is going to take a couple of years to get all these apps compiled, right? But in the interim, we want to have a solution like to run 4K apps.
But there was a similar problem in the past that Android on 32-bit, they were using software floating point, which was stupid. You should have been using hardware floating point. But we never supported hardware floating point because 64-bit happened. But also it would just add in like all of these complexities that you're describing now, and you can't really fix it in a linker and so on. So the telling ARM to get stuffed solution seems like a good one.
Yeah, and it's like right now the memory in the phones is increasing, and also you can see like the foldable phone, right?
Mm-hmm.
That they use. I mean, they use more memory because they need they need more space for the frame buffers to basically to display whatever you see in the screen, right? So I mean, basically these devices are going to be one of the main beneficiaries of this 16K. So that's the reason that for Android is very important to find a solution for this. So yeah, I mean, so basically this is another project that we have. Yeah.
Patching the L files to rewrite all the relocations and rewrite the GOT and the PLT should be possible. It's just should be a matter of implementing because you just need to basically you've pushed the segments further apart from each other. So you just need to find all of the relocations that cross the segment boundary and adjust them by how much you move the segments away from each other.
I mean, basically looks like that. I mean, that should be. I mean, in theory, it's doable. But here's the thing: it's like when you compile, for example, a C file, you get that .object file, right? And then it's like when you have all these .object files, and then you say, okay, link it. During that moment, there are two types of relocation. There is static relocations, and there are dynamic relocations. When you link all these object files, all the static relocations are gone. And then it's like the only thing that is left is the dynamic relocations that are used by the loader. So that's the main challenge with our binary analysis, that we already lost all these static relocation tables. And then the only thing that we get is like dot reloc dot dyne relocation. So basically, it's like that's the reason that when we read the text segment, the text section, the init section, it's like we use C code, and then in order to basically fix the offsets in the code, it's like we basically in ARM64 all the instructions are 32 bits. So basically, it's like we analyze these instructions and then we say, oh, if it's a call, fix the offset. If it's a call instruction, fix the offset. If it's a ADRP instructions, fix the offset. But the problem is like, for example, when you run the command object on, is doing like basically is like a static disassembly. So basically, it's go every 32 bits, transform that into an instruction.
Right.
It does.
You don't know which constants are offsets and which constants are just numbers.
And the problem is like the compilers, because they use optimization, for example, for the switch statements. When you compile a switch statement with the optimization, sometimes they embed a table inside the text code. So basically, it's like that's the reason that you have data in the text section that are supposed to have just code. So basically, it's like that's the problem that sometimes we do it right, sometimes we don't do it, and then it's very. I mean, it's a hard problem to do this. And then in order to circumvent this this problem, we try like recursive disassembly. And basically, recursive disassembly, what it does is like in the L files, you have one place, like for example, all the functions and all the constructors in the C are stored in .init array, .finit array, and basically it's like, and then you have another section called .eh frame, where all the pointers to the functions are stored. So basically, it's like we try to find all the functions in the L file and try to fix the offsets in all these basically opcodes. But it's like the problem with recursive disassembly is that sometimes you miss some functions. So basically, it's like linear disassembly and static disassembly are not that perfect. So basically, that's where we are stuck right now. Yeah. So these are.
Guess another crazy idea, just since we're throwing things out there, is that you could map everything like you normally like read or read executable by default, and then have like user fault FD or a SIG via handler to say if you're trying to write to the data section, and just actually like in the signal handler check the address to see if that should be allowed, and then temporarily map it writable, allow the write, and then map it back non-writable to solve the problem of having to map everything as writable by default. It would be awful for performance, but it would, solve some of your security issues.
Oh yeah. I mean, we can. I mean, we can explore that solution using C. So, that's.
You use the signal handler approach, you'll have to protect the pages as 4K pages, when then you'll split the VMAs and they'll no longer be 16K, and you're kind of like defeating the whole thing anyway.
I guess that it's like what we can do is like, I mean, we map one page size. I don't know, with like the read executable permissions, and then when we try to write, basically in the signal handler, we say, okay, if it's a write offset.
But you'd have to. What do you do about execute, which is like the scary one?
Sorry.
Execute. Yeah.
Oh yeah, I mean the security implications.
Yeah.
Having RO data as readable executable. So yeah, you would still be able to execute RO data, which is not great, but ideally if it's read only, at least you would know what you're executing.
Actually, just to close on like opening up here with a general comment, is there anybody else that we should sort of put them in touch with that maybe not in this room but elsewhere in the conference that might be able to help with that sort of stuff? This is an open question. We can think about it later on. Just sorry. No, I'm not thinking. No, I don't have any in particular in mind. Just sort of thinking aloud, essentially. If there's anybody else that may not be present in this room that may be able to sort of assist.
I could talk with the GDXC guys.
Yeah, sure. Yeah, yeah. I mean, this is a good opportunity because some people may be here. All right.
Morning, everyone. I wanted to discuss some aspects of the memory plan. So, new memory plan algorithm, multi-gen MRU. It's just brief background. So conventionally, the reclaim algorithm use inactive active list. And in MGLIU, the idea is that we have multiple generations, so we can have more great control over the eviction and aging. So, one of the issues that we have seen, or some partners have reported, is that MGLIU can sometimes lead to a situation where you have only one kill. So, ensure all kills, meaning that we still have stages to be playing. This issue really came up because of how the values differ from conventional LIU. We only have inactive, active, and anonymous lists. In MGLIU, we have also we also have a separate LIU for each zone. It's the way it works is there are 2 pointers. We can say one is the max sequence, which points to the youngest generation. This always stays in step. And the reclaim pointers are the main sequence pointers, so they can advance. They can advance separately to allow anonymous power replay. So it's a different pace. One other thing is in order to reclaim generation and move the max sequence forward, we must have all the zones in the oldest generation, and in order to progress forward. This is the point of the BoF.
So what happens that led to this problem is in MGLIU, we could have a case where, for instance, we have some pages in let's say generation 4 is the youngest generation, and generation 1 is the oldest generation. We could have some pages in the and we also have a movable zone configured. So what it led to is, in some cases, we have, let's say, GFP kernel allocation. So we need to allocate a normal zone or lower. Well, how the reclaim works is it looks at the eligible zones to know where we should reclaim from. But because we still have some pages in the movable zone, which is one index larger than the normal zone, when we attempt the reclaim, we only look at the normal DMA and DMA 32 zones, and they don't have any pages. So the algorithm just bails out. There is nothing to do. So it doesn't make any progress, and we cannot increment the older generation forward because there are still pages in the normal zone. So this actually is what leads to the premature kills. So if we look back at the conventional LIU, the way this problem is solved is when we scan pages to reclaim from the tail of the inactive LIU, if we find pages that are not eligible, so they are in a higher zone than the allocation request, we just simply move those to the head of the inactive list. So in MGLIU, we do a similar thing. When we dissect this case, we move the pages from the higher zone to the next zone, from the from the older generation to the next younger generation, not zone. So it's similar. If you think about it, we have 4 generations. So we move it from the oldest generation to the next younger generation is kind of similar in a way to moving from the tail of the inactive to the head of the inactive. So it's similar solution. So that's what we did to solve this premature ohm chaos with MJLIU. Yeah, and this is a link to the patch. Another difference maybe in MJLIU is that when you have access to pages from file descriptors, those pages get added to the oldest generation, whereas the anonymous pages from accesses from page tables get added to the youngest generation. And the idea is that we are able to reclaim these FT reference pages more easily. We don't have to work the page tables. We don't have to update the bits issue. And most of these are clean pages we can just drop. However, this we don't know if this is a source of some issues for some workloads that may need to read a lot of configuration files, or some app launch regressions may be related to this less protection in the FD access pages. So it is the way the way the reclaim works is there's tiering in each generation. There's also tiers, and based on the number of accesses through the file descriptor, we move the pages up in power of 2 in the tiers. And when we do the reclaim, we compare the tier by tier from one type, like say unknown type was selected to be reclaimed. We compare tier by tier until we find a tier in the unknown type that has until we keep finding tiers in the unknown type that has a higher refault rate than the lowest tier in the file type. And then we decide either to promote the pages based on the number of accesses, or if the tier is larger than the tier that we decided to reclaim. And yeah, so this open question is, should we be protecting the file FD accessed pages more? And yeah, if anyone has some comments on this.
More protection, a little loud. More protection is always a trade-off between performance and security. Like, what can we do that would be a good balance? What suggestions would you offer?
Yeah, it's you are right. It's a balancing issue. Like in some cases, it will lead to longer direct or longer reclaim latencies. In some cases, it helps the workload. So yeah, it's in protection in this sense. I mean, like, should we protect it from reclaim? So should we keep it in LI use longer?
Oh,
yeah.
Gotcha.
Yeah, another thing that happens in Android is if you have an Android device and you check how much free swap you have, it will almost always be close to 0. So the workloads are highly using highly used of anonymous page and swap, and we also do app compaction, which swaps out memory to or pages to swap. So in the reclaim paths or in the scanning parts of the reclaim algorithm, what we do is if we detect the swap is full, it simply bails out. It cannot reclaim anonymous pages. So is there something better that we can do here? I don't know. But one idea is to also, when we check if the swap is full and which we are trying to reclaim some anonymous pages, we should also check if this page is also already in the swap cache. So then we would update the PTs for the other entries of that pages, so that we don't need to keep re-scanning those. Yeah. So yeah, if anyone has some idea on how we should handle the swap full case, yeah, so,
Yeah, I have a question in regarding to the early out of memory kills. How is affecting the performance? How bad it is?
is rare, but we don't want to have out of memory kills because it's a last resort for the kernel, and LMKD should handle all the kills in Android. The user space low memory killer.
This is maybe a tangent from the swap full, but kind of related. I was curious how much like discardable memory is used these days, like with unpinned ashmem pages, and like how does that balance with just being able to reclaim that just straight from the shrinker, versus dealing with the.
But the shrinker stuff is always, the shrinker is always run after kswapd try to reclaim. So
okay.
If we have pages to reclaim by shrinking, those are on top of what the kswapd algorithm does. But so yeah, maybe in some cases we reclaim more than we need to from due to the slab shrinking. Okay. 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 Yeah. So another case we want to look at, or another balancing problem actually, is how much do we overshoot the high watermark when we reclaim? Because if we overshoot a lot, we get better latencies. So we don't hit direct reclaims latency a lot. But if we reclaim too little, then we end up going into reclaim and direct reclaim more often. But currently, the approach we take now is when we scan for eviction, for the eligible zones, we check the watermark is. We abort the scan if the watermark in those zones are already above the high watermark. But I think, but yeah, they can still be overshoot from the slab shrinking, like John mentioned. So yeah, that's also open question if. Yeah, if does anyone have any questions or comments? Okay, if no questions, this is all I had for what I wanted to discuss about MGLI.
Thank you so much.
Thank you.
Right. Just as a heads up, at right before 10:15, we're all going to move back over to the E room, Potomac E, to make space for the next sessions.
Swapping.
Yeah. All right. I'm going to talk about the status of an effort to upgrade the MEMCG controller in Android. Maybe about C groups in general and how MGLRU interacts with MEMCGs. If I can, okay. Little side arrow. Yeah, I see it. I just can't click on it. There we go.
Yeah, so what is MemCG? For those of you that don't know, it's a C group controller that accounts system memory use, and it can limit memory on a per C group basis. It also affects how reclaim is done. For example, you can kill or throttle app allocations based on their current memory usage and a threshold that you set. Why do we want to do this? Yeah, a couple reasons. I mean, we've got this desire to upgrade to V2 from V1 to avoid any potential issues with future deprecation of V1. I'm not sure how likely that is, given the amount of difficulty that people are reporting upgrading applications from V1 to V2. Everybody seems to have trouble with this. So I don't think there's a real risk of ripping out V1 anytime soon, but at least I'd like to avoid it, in the future. And also, we want to extend MemCG for additional accounting features. That leads into my second bullet point. And we don't want to extend V1. We want to extend V2 if V1 is on path to deprecation. Yeah, so accounting, DMA buff accounting. So currently, DMA buffs are not accounted as user memory. They're kernel memory. We have a separate way to account those. In Android, it can be several hundred megabytes of memory that's used for these DMA buffers. So we like to know what's using them and when. And yeah, but our current accounting solution is this DMA buff sysfs stats stuff. It has a performance issue where it takes a global kernel lock on every allocation and export, and we really want to get rid of that. So MemCG would do it a little differently. It's a per CPU counter that would eventually get flushed up to a global counter that we can observe. So we expect to see less jank issues related to this DMA buff tracking, the DMA buff accounting, by implementing it in MemCG. There's some patches that do that, but this does not exist anywhere yet. Another feature that MemCG has is proactive reclaim. So since Android 14, we now aggressively background applications and freeze them. So when we background an app, we'll try and shrink its memory footprint by running garbage collection and trimming memory. But there's no, at least not as far as I'm aware, there's no effort to do anything in the kernel to reclaim memory from these backgrounded applications in the kernel. And since we have a per application C group V2 hierarchy, we could manually initiate this kernel reclaim on a specific application that's backgrounded to shrink the memory footprint of these applications even further. Yeah, memory limits. I mean, so there are various thresholds that you can apply to a C group. You can cause an application to throttle when it allocates. You can cause it to when you exceed a limit. You can protect the working set of a minimum working set of an application so that reclaim skips over it. So this might be something you want to do for foreground apps, visible apps, latency sensitive apps. Okay, and yeah, so working set protection might help keep foreground applications fast. And yeah, this last one is so Android relieves memory pressure with LMKD by killing apps. There's this interesting property of reclaim when you have MemCG enabled and MGLRU enabled, where because of the MGLRU LRU ordering, we're likely to reclaim memory from apps that we're going to kill anyways with LMKD under memory pressure. So that leads to lower refaults, and we waste less time doing refaults if we enable MemCG V2 to do this. Okay, so I enabled MemCG. I ran some tests and found lots of problems. So this is really a story of comparing performance with MemCG V2 to either MemCG V1 or no MemCGs. I'll run a test, spot something odd in the results, and investigate, and fix, and repeat. So this is just a list of fixes. I guess this first one is like a broad category of issues related to zombie MemCGs. Zombie MemCGs are MemCGs that have been partially removed from the system, but not completely removed. And since they consume kernel memory and they sit on a list that that's used for reclaim, and that list gets iterated like every reclaim, it slows down reclaim basically. So we'd like to avoid having these. To give you an idea of numbers, we might expect like 400 to 500 active C groups during this test, but you might have like 2,000 zombies just after like an hour or two. So it's pretty big impact. I was initially testing on a 510 pixel. I found pixel driver bugs in 510 that were fixed in later kernel versions, and bugs in 510 that still existed upstream. So these are some of the fixes. Yeah, we got this kswapd issue as well, where basically spending doing nothing. Since I'm kind of short on time, I guess I'll just skip ahead. But basically, I think we're pretty close to a state now where the amount of like odd or unexpected test results are pretty near zero for the MemCG v2 case. The last remaining one is this pretty large slab increase that I can't explain, so I'm investigating that still. And remaining work is rerun these tests on 6.1, which is a kernel that we would actually deploy on instead of 5.10. And yeah, pull in these awesome KMem patches from Roman to get even faster MemCG stuff. So I'll leave it there.
Okay. Should we move back over to E and we can continue the discussion there and then move on to the other talks?
You want me to be taking the laptop?
No, that one's I can do that, but sorry.
For what?
This is bot. Let's make sure everything's set up here.
I'm not the speaker though.
Yeah.
Is one of you the speaker?
No, well, I just watched him in the other room, so.
Oh, okay. I'm sure he's on his way over.
disappeared. And
Yeah.
This is Potomac G.
Yep. If you know something about Syzbot, you're in the right place.
So yeah, in this case, I do not really have much to
That's fine.
tell more. So yeah, but requested this BoF session is to hear some experience, some maybe ideas. Like if have had to deal with Syzbot reports, where you can tell us your pain and what we can do to relieve it. If you have not had to debug Syzbot issues, but you still have experience with kernel, just share what tools, what information, in your opinion, is most helpful in determining the actual cause of a problem. And yeah, and also whatever ideas and opinions you have regarding Syzbot operation, kernel fuzzing, also. Yeah, I think these are supposed to be also recorded, or
yeah, it's being
we are
recorded.
supposed to use this pulse. I think.
Yep. So if there's questions or comments, and
Well, part of the thing, if you're on chat, if you're remote, then just share your video to let us know that you want to say something. I'll send a message.
Just sent a message.
Okay. So, just a general question with the fuzzing. Are there any tests that actually try to, instead of making it fail, try to make it take as long as possible? And actually, like, even if it doesn't actually error out, to try and basically like tank latency as a method of testing. I'm just curious.
During normal fuzzer operations, yeah, we do actually mostly focus on covering as much kernel as possible. So we do not. I think we should not expect the kernel to crash at all, but at least during fuzzing, we do not assume that it crashes at every single syscall. So we generate programs, we see that we have covered new parts of the kernel. We try to actually minimize the generated programs so that we could still cover the same new part of the kernel, and we remember that program. And then it goes on like this. So we get more and more programs that cover more and more of the kernel.
Yep. Okay. So source lines of code is basically your metric in time.
Blocks, I'd say. It's per block, or in Clang, it's per link coverage, or how it's called.
Oh.
But yeah, basically the amount of source code that we could have that we have managed to execute, and
bugs are just a side effect of executing that code.
Yeah. Good. Maybe to break the ice with some thoughts I have on improving the debuggability of some sysbot reports. One topic that I find interesting would be tracing of reproducer. So, okay, two parts. In the case where you have a reproducer, providing a trace, an ftrace trace, or some amount of trace that helps the debugger understand what gets tickled by the reproducer. And then in the case where we do not have a reproducer, doing fuzzing, if we were using some of the Intel PT or some of the hardware-assisted tracing features to log the last n branches in some CPU ring buffer, even if we can't reproduce the bug, we will be able to attach some metadata that say, yeah, this led to the bug, and augment the backtrace and provide maybe some more context to the developers who then look into the bugs. I don't know, just wild ideas. If anyone knows more about these topics, or finds it interesting or not, or
We at least did get requests to add strace output. So we try to do that after we have generated a reproducer. We run it under strace, and we share the results. It should help. But I think here the intention was to better understand what the reproducer is actually doing, because these color programs can be quite convoluted, fortunately. But tracing, yes, I think it can be, but like if you only provide this list of raw PCs, I don't know how much it would be of help. One of the ideas that has been already proposed quite a long time ago, actually, was to collect kernel memory dumps at the moment of the crash, so that you could run JDB against that memory and the VM Linux to get some more insight into what was the state of the kernel at the moment when the problem happened, to see at least all stack traces for all kernel threads, to see the values of global variables, and so on. So what do you think about that? Are you using these kernel dumps in practice? Do you find them helpful? At least from what I tried, it works, I think, most of the time, but at times the kernel has very complicated structures. I don't know, some balanced trees, and good luck with traversing those with JDB.
By kernel dumps, you mean the actual kernel image used in the test?
The RAM content.
RAM content. Okay. Okay. No, I haven't used that. Sometimes I've used the actual kernel image to do post-mortem static analysis of the bug, and that was really helpful for some of them, but no dumps.
So we regularly use K-dumps, like when we are analyzing customer issues, for example. So when something goes wrong, we trigger K-dump and then analyze it post-mortem. And there is like relatively wide infrastructure for actually doing this, even like parsing the complex data structures. Like there are ways how you can now you have like the crash utility, which has some useful tools for actually traversing the data structures. Also, there are various Python bindings for this, so you can actually write a Python program to actually process the K-dump, and do the parsing. So I wouldn't be afraid. What I'm concerned of is that if you capture some kind of like QEMU dump or whatever, it's going to take a lot of space. So it may be like, how I could imagine is that, like, if someone starts to investigating, he could kind of like ask, please reproduce this for me and get me the K-dump. Yeah. And on this like per request basis, I could imagine it would be useful. And so, because otherwise you would be spending like terabytes and terabytes of space on K-dumps nobody is interested in. So like, given the amount of bugs you find.
Yeah, the K-dumps, I think they could be actually, I don't know, could be more helpful probably for bugs for which you do not have a reproducer. because that's what every extra bit of information counts. But I don't know, given the number of bugs with reproducers, probably nobody just cares about those without.
Yeah, so I agree that for those for which you don't have reproducers, they would be kind of interesting. But then, yes, I agree actually. Yeah, so you could maybe, but like if it's one off, yeah, then I guess there is not much change to debug it either. Like you would have to basically generate KDAM for everything, yeah, which I don't think is really feasible. But like, you know, if it is like, if you see you can trigger it, just you cannot get to the reproducers, then I agree that getting KDAMP would be probably useful. But again, I think that it would be like more on a per request basis, like that, you know, I'm hitting this, so I would be, and I'm interested in debugging this, please get me KDAMP of this issue would be really useful, I believe. But because one KDAMP is going to have few gigabytes, you could perhaps compress it, but still, given the rate with which you hit the bugs.
Yeah, I think at least if we keep like 1-2 KDAMPs per every bug, then for a month or something, it should be reasonable.
Yeah, okay.
At least for disk images and VM Linux files, we do store them for
that's
quite a long
true.
time, and they can be compressed pretty well.
Mhm.
Maybe with KDAMP, I think it should be even better. The kernel memory is anyway not that big, and
yeah, okay. Yeah, if it's feasible, then it would be useful in some cases, definitely. Yeah. Another thing, so Duncan Carpenton already mentioned it, and that's also a thing that's kind of, I'm thinking about it on and off, whether how Sysbot could do this. And it's kind of this like root only versus like arbitrary user distinction. Yeah. So the question is basically, it's a question of prioritization of the bugs reported by Sysbot, which is also like kind of a way how we deal with it, because currently there is not enough like maintainer / developer bandwidth to address all of the reported issues. And so it's basically a question of prioritization, but I can like leave there kind of bit rotting, and what should be really addressed soon, because it's a real potentially security issue and stuff like this, because this is actually causing the stress. Sysbot report comes, you don't know whether it's actually CVE worthy issue or whether it's just some like normal bug which is good to fix but not really pressing. Yeah. And if you have to spend a few days, in the worst case, like even longer, in the best case, perhaps less, but if you have to spend simply like a good chunk of time to identify whether this is just something stupid, like bad assertion, or whether it is something fundamental, then yeah, that can kind of contributes to the stress. So if we, for example, immediately know this is only possible to trigger as root, then we can like prioritize this bug. And if we know that it is triggerable as an ordinary user, then yeah, we should be giving it a higher priority, because it's like more likely a security issue. And the question is how to do this in an automated way, because yeah, I understand it's not completely trivial.
Yes.
Because there are setup steps which need to be performed as root in every case. So
there are a lot of such cases actually for file systems. I think we can only mount it with
absolutely. So
mount system and do root and do something from user. Is it a root only bug or is a user only?
Exactly. Yeah, I understand it's not easy. I understand it's not easy from the Sysbot point of view. Like you would have to have basically some, let's say, decently behaved stuff which is done as a setup as root, and then you go wild as an ordinary user. Yeah. But yeah, how to implement this? Yeah, I don't see the details how I would do this. But just there is a feeling that somehow we should be able to get better in this, like being able to discern whether we require root access or not for a particular issue.
But yeah, I fully agree. I think it could be very useful. Triaging signal for people, but yeah, the idea how to exactly implement it think
Yeah.
it's really tricky. I think for at least for networking, where we do set up networking devices before doing the actual fuzzing, it's somewhat more straightforward because we can easily split actually all the execution. The first part that we create devices, set up networks, whatever. Then we drop privileges and do other stuff. But at least for file systems, I think it's not that obvious because mount operations and other operations, they can all be in arbitrary order. It's not that we always have to mount first and then do something else later.
Yeah. Yeah, I'm just thinking, I don't have a good solution either. It's just a kind of a wish.
On that same topic, I think once we discuss this and you say that what we can do is also have two instances of fuzzing, one that fuzzes root, one that fuzzes unprivileged. And if you get a bug from unprivileged and you know for sure, okay, this one can be triggered from non-root, definitely. Do we have such instances running already?
Still, for file systems, I think we would get 0 bugs.
Yeah, you will get 0 bugs, of course, but the bugs you do get, you know 100% they are.
No, so far we're not.
Because it's not a full solution to the problem, but it's a step in the direction.
And it's a solution, I think.
Easy.
What else was proposed? There is also, I think, KGDB in the kernel that lets you dump a lot of the information about the kernel state. At least it's some maybe a better lightweight version of, but instead of dumping the memory and letting developer later run GDB to connect that memory with the VM Linux file. Another way is to use the KGDB tool that starts working after the kernel, after the panic, and provides some command line interface that lets the person or the bot to send some commands and store the output of the kernel global state the moment of the panic. And have you ever used it in practice and seen it? Could it be helpful? At least we saw requests from USB people that, okay, we want to see information about all USB devices at the moment the kernel crashed. And that seemed like the option that could be used, at least by extending KGDB by adding some show USB devices command.
So I think KDAMP would kind of solve this as well. Like if you give them KDAMP, then they could figure out how to get all the USB devices out of the KDAMP. Yeah. And it's like what we deal with when we do customer requests anyway. So I guess it's like people tend to have tools for this, how to extract this from the KDAMP. So I guess KDAMP would solve these kind of special requests.
Yeah, I think KDump is a more general solution. I think the problem goes how to share that with a bunch of people. VM cores can be large, especially from bare metal systems. With KDump VM cores, people can use whatever tools they are use to analyze either crash or a Dragon or whatever. So I think it's a broader solution than KHDB. By the way, I may have understood wrong, but do you guys fuzz only virtual machines or also physical servers as well? Because some sort of weird bugs just arise on physical machines, different architectures, etc.
At least we ourselves only fuzz on virtual machines. We fuzz, as mentioned, on Google Cloud virtual machines and on camel instances. But other people definitely do use T-Scholar to find some hardware problems. But yeah, of course, it's also very promising direction because kernel has a lot of drivers, and even if we have descriptions for their kernel interfaces, there is very little point in fuzzing them without having the actual devices, and therefore we have barely any coverage actually for drivers at Sysbot. But it also comes at their own costs, because like with virtual machine, it's easy. We have created it, we have mangled it, and we just drop it. But with hardware, not that we probably want to reflash this whole image every time it crashed. Get more interesting. So yeah, do you have any other questions, feedback, ideas?
Yeah, go on. So for me, being able to reliably reproduce the issue is critical, because then we can live debug it using QEMU or whatever. So previous issues that we've faced in the past is not being able to reproduce the issue due to the different tooling we use compared with what you use. Do you provide a hermetic way to download the entire build system image, etc.? So like a Docker image that you can download, so we can ensure that all of the tooling versions are the same?
We do share the bootable disk image now. With every report, you can download it and just directly run Camo using it. It will be exactly the same image, exactly the same kernel that Sysbot was using.
So that's the file system and the kernel already pre-built. But what about if you then want to rebuild things?
We want to rebuild here. Then it's a bit more interesting, but our Docker container is public, the one we use for Syscaller, and the tool we share the kernel config that we used to build the kernel, and actually the tool itself that can build the kernel exactly the way Syscaller does and inject it into the disk image exactly like Syscaller does. It's also there, but that one is unfortunately not very well documented at this point.
You used to also produce or distribute the compiler that you used, but you stopped doing that?
Now they're all in the Docker container.
Okay, so the Docker container is the answer to that?
Yes.
Okay, all right, I'll start using that.
It's turned out to be much easier.
Cool.
One idea. So you said also you do like kconfig minimization for the bisection and stuff like this. Do you share anywhere the minimized kconfig, like as part of a reproducer minimization, which you do anyway? Like you could also minimize the kconfig and then share that, because it makes the reproduction and analysis sometimes simpler as well. Yeah. So if you do it anyway for the bisection, then it might be interesting.
Yeah, at least after we have finished bisection, I think we do share the config.
Oh, okay.
Used for that bisection. But, it's I think more of an architectural issue, because reproducers are found by Syscaller, and Syscaller operates with only one specific kernel image. And bisections are done by Sysbot, and Sysbot can afford actually building the kernel each time with different configurations, different revisions, and preparing disk images and running toll. So we had some plans to try to move back reproduction also to Sysbot. If we do that, I think it should become possible. We do not minimize it 100% because it's also tricky business. It's the diff between some baseline config and the config that we use is very big, and if there's just one config to enable, it would already take, I think, maybe 10, 15 steps, but usually there are several configs, and it just explodes the number of iterations we would need to find them exactly those configs. So what we do for bisection, we do it partially. We think on average we do 5 or 6 iterations, and the diff between baseline and the config that we use for building the kernel, it gets smaller. I think 4x or something like that. It noticeably increases build times already.
Yeah.
And lets us trigger fewer side problems as well.
Okay.
That's a very reasonable suggestion.
Yeah, it was just that, for example, when I'm reproducing and so I test the exact config sometimes, and say, okay, it's built. So I basically do the minimization by hand, because then if I don't have immediately the idea what's going wrong, I need to reproduce it, add some debugging outputs, recompile the kernel and so on. So it's easier if I sometimes also minimize the kconfig before it to kind of.
Some configs are very big. I think it's maybe on 64 core machine, it takes maybe 5-10 minutes.
Yeah,
the
yeah.
machine is smaller and proportionally bigger. And regarding reproducibility, yes, I think another part of the problem is that for Linux, mostly we use Google Cloud VMs, and we reproduce also using them. And I think in some cases, reproducer does depend on the specific timings, performance, which is, of course, and you take even the same kernel image and run it using Camel, they will be different. The reproduction just doesn't work. I've seen regularly see such cases. Fortunately, not sure how much can be done for that. Maybe we could explicitly just try to run the reproducer on Camel and to understand if it works there. Still, I think for many issues caused by races, we're missing functionality to reliably produce the same thread interleaving to trigger exactly the same problem. We just have to rely on luck that our reproducer would hit the problem, that somehow it would all come together so that the correct execution path becomes possible. You want to say something?
So question about bisecting. How far back do you go? So if you find a problem, how far back do you go to determine whether or not the problem always existed or whether it started somewhat recently?
When we are bisecting for the bug's origin, we first actually go revision by revision back. And
major or minor, or how?
It depends. If there are a lot of minor revisions, we skip them, of course. So I don't know, for Android or for some that can be based on some LTS, there can be, I think, hundreds of these sub revisions. Of course, it's a waste of time to test them all. So we at least always go back to 2 digits, like 5, 6, 7, 6, 6, 6, 5, and so on. And it works. So at least when we go back and test every, I don't know, would you call it major? Would you call it major release?
Well, I would call that major minor, but so
yeah, we try every major minor release,
right.
Going from now to history, and when we see that it no longer crashes, then we consider we have found the bisection range.
Do you start to accelerate that range if you get to the beginning of a major release and it's still there? Like for example, if you go 6.7 down to 6.0 and then it's still there, then jump to 5.0 and then 4.0 and like maybe
we
eventually
start skipping, then skip 1, then skip 2.
Right. Okay, so you do start accelerating to.
Yes.
So it sounds like this is somewhat of a manual selection process to be able to figure out how to start looking for the original or an earlier known good.
Well, it's course, it's all automated, but the exact parameters that were chosen, they were not very, maybe not very sound ones, just ones that seem to work well. It's the problem, of course, of time.
I guess I should still continue using this. So I'm guessing that there must be some that you found where you never found a known good in the past. So you basically went back to 2.6 or even earlier, and it was always there.
Yes, in that
Right.
case, we just don't do bisection. We say that
Okay,
it happens
okay.
on the oldest tested release, and it's, I think the maximum we can do is 4 dot something.
Oh, okay. Okay,
But-
so I guess that's sort of a reverse of bisection, is to start widening your net to try and get further and further back to find it.
It's not widening. It's anyway, the range it's the same, because we know that the next revision failed.
Right.
And the version and the really major minor release before that worked well. The range is not big, but
Sure.
technically the range is getting a bit bigger. as we
But
go.
yeah, but once you found a known good, then you bisect. But the process of trying to find an original known good is sort of the reverse of bisecting, where you're widening your net.
Kind of. But that works best if we try it, because the smaller the range is,
Yeah. Yeah, obviously,
fewer
yeah.
chances
Okay.
to make a mistake.
But that answers my question, is you basically only go back to 4 dot whatever if that's what you
It
currently
happens on
are
rare
able to
cases,
do.
actually. It's
Right.
the most of the issues are in recent releases, because they get
Sure.
luckily
yeah.
fixed over time.
Because some of the bugs that I've looked at, I've ended up looking back and used some of the rebuilt histories, so that it basically concatenates 3 different Git trees to be able to get a history that goes back to like 0.95 and even, really, really early kernels, and was able to find stuff that's always been there. Like it was the very first check-in of that feature had that bug. Anyway.
That far.
NSA is not happy.
Sorry?
I said the NSA is not happy with you.
That's their prerogative.
Because the sections were, of course, 100% reliable. We could probably just start at the first commit and the last commit, and then do it from that.
That would take a while.
But going through releases also takes a while. You think if there were infinite time, we could have tested more major minors, but we just have to balance the time we're ready to spend doing the section.
So you've never gone back to 0.11 kernel.
I think we won't compile it and won't test it anyway.
All right, who wants the mic? Hmm?
Anyone else wants to add something? It was discussed. In the meanwhile, I've just probably go back to the presentation I was just given. That I personally found it surprising that indeed so many issues that we do find on LTS and all the kernels are actually already fixed. And this is, of course, here I think in this conference probably most people are interested in the mainline, but for all companies who are actually using it in their products, they all use older kernels. And it's surprising how many fixes do not really reach all kernels that were really affected.
There was a comment by Rick Van Riel on the chat during your talk, actually, that there are like sometimes what happens in the stable is that some of the patches are cherry-picked, but some of the prerequisites are omitted, which introduces essentially new bugs into just a stable version. Another variant of this is that, like, there is something after the branching point. You cherry pick some fix, but then there is a follow-up fix up which actually doesn't get properly, which doesn't get backported, or maybe doesn't get backported yet to the stable tree. Yeah, it depends. So so actually the breakage point is behind, like after the merge base. So merge base would be fine, but yeah, this will kind of appear as a stable specific breakage essentially. Yeah. So these are some of the occasions where it can happen. But yeah, I was kind of surprised that they are really upstream fixes that are not getting into stable, but it may be probably one of the per subsystem kind of thing. Yeah? I understand you didn't want to be controversial, but like maybe it would be interesting to see like whether there is any concentration in particular file system, like where this happens, like whether they should be getting better in setting the fixes stacks properly or something like that.
Were more active in demanding that fixed batches have fixed stack.
Yeah. Well, that's sometimes, yeah, exactly. So it's basically up to the maintainer to like enforce that fixes have fixed stack. Yeah. So obviously we have always the case, as you mentioned, that we fix something and we don't realize that. Yeah, that's always the case, and that will always happen. It's simply mistake. So we will never be perfect, but yeah, at least if we commit a known fix, then we should strive for either explicitly CCing stable or in the ideal case, adding a fix stack as well. Yeah. So if there is concentration in a particular file, obviously even in this, like mistakes happen, but yeah, if there is particular subsystem which is bad at this, then yeah, we could maybe talk to those people.
The ones that we found, we will soon try to actually help those commits get into stables.
Yeah, that's, of course, that would be nice. Like as you said, you could do, since you have now the automation, then you could basically automatically, report that we have identified that this fixes this sysbot reproducer, and see this stable kernel should probably pick it up. Yeah.
This still requires manual analysis. When I was analyzing the results that I got, it was actually not so straightforward to understand. Looking at the commit from a subsystem unknown to me, to understand how to classify it. Is it a correct result or?
Yeah, so I absolutely agree, but as a kind of last resort thing, like it shouldn't be like the standard process, I would say, but as last resort thing to catch mistakes, I guess it's still nice automation to have. But yeah, as I said, like ideally reach out to the maintainers if they could improve with the fixes, like that would be also a way to go if there is any concentration in any particular subsystem.
It's worth it. If you're interested, these lists are actually public. Go to the dashboard. There's a special page that lists all commits from Torvalds that need to be backported to what particular LTS branch, LTS tree. The BoF sessions are 45 minutes.
So is this missing backports? Yeah, missing backport.
Backports, yes.
You've got about 5 minutes left, but you don't have to use
Yes, of course. So are there anyone else who wants to add something? What we discussed, what we have not yet discussed. Okay, and thank you very much for coming. Let's have our 5 minutes back.
Take a break. You can get the cookies faster than the other session.
No problem. So just have them back to the LTS function.
Yeah, so I can see, for example, I found here one like ext4 issue, but that was actually CC'd into stable kernel org, just probably it didn't get picked up by the stable tree because of
Yeah, there are maybe different cases for
no, so for example, we have this one, and I'm not sure if the 515 didn't get applied. I see. Yeah, so it was CC to stable apparently.
Often they don't apply though, and Greg just kicks them out. And then unless someone is prepared to do the backport.
Yeah, so probably it didn't just apply because of some context changes.
There's no fixes tag either, so you don't know which kernels that will and will not be applicable.
Oh yeah,
to.
but this is likely basically very old bug. so
But
the
still, it was
fixes-
triggered on that 515. It's sysbot goes from bugs that it found on LTS to mainline. So it's not the other way around.
Yeah, I understand. So in 515 it was still a problem, but likely like the fixes tag here wouldn't really help that much because it would go somewhere to 4.0 or 3.12 or something like this. Because so like yes, we would know that it applies, but basically it didn't apply probably because of some context changes, and then
and it would have stopped there as well. It wouldn't have gone back to 4. So Greg doesn't apply it to 4 unless it's gone into 5.
Yeah.
Otherwise, when people upgrade their kernel, you get regressions.
Yeah, that's true. Yeah, so that's kind of, there was not enough, nobody was interested enough to actually act on the
They still
failed,
need some place to gather all that stuff, I think.
failed application. Yeah, because
the 515, it's not. I think it sounds old, but I think for many companies it would be actually new.
That's one of our newer kernels.
Yeah, well, we maintain 4.4. like and of course also newer ones like 5.13 and 6.4 and so on, but 5.3 as well. Whatever. Yeah, I agree.
And does anybody care about just normal stable trees or?
Well, yes. So we have our private ones, but like for example, like Android basically feeds from standard stable trees.
We would care,
And other vendors, I believe, as well, like handset vendors.
Yeah, I was going to come and say hello after. You all right? It's good talk. Enjoy it.
Yeah. No, this is actually one of my fixes.
When you see a person on VC and on the pictures, it's hard to.
Yeah. I've also grown my hair and grown a beard, so you wouldn't recognise me from my LDAP. But I was going to come and say hello anyway.
Oh yeah, okay. So this is a case of this is actually one of my fixes, and it was just a performance issue. So we didn't actually CC it to stable or anything because it didn't seem very serious enough. But apparently you were able to trigger hung task with it if you stressed enough. Like because apparently the performance was so bad that if you stressed the kernel enough, you were hitting hung task and identified that the performance fix actually fixes the problem. Okay. Yeah. So it's one of the kind of miss.
Where are you looking? I don't recognise that format. Upstream backports. What's that?
Yes, it's on the web dashboard. If you navigate to it, there will be at the top, the header, there's a button missing backports.
Oh, okay.
And if you log in with your Google account, you will see more.
Yeah. Okay, I'll do that. I mean, I can start churning through those. I can start fixing those, going through and doing the backports. That's what I've been doing anyway with Greg. So if I find that, because Greg's got a real low bar, if it doesn't automatically cherry pick, he won't go ahead and fix it. He'll report it to the author, and often they don't care. So then I would then have to go and fix it and backport it and do the.
I don't know how Greg looks like and where it's there. I talked to Sasha even, and he said, just can send me and Greg and this is stable the list of hashes.
Yeah.
The corrected fed backwards, and we'll see what we can do.
Yeah, he can give you then. Yeah, I think Sasha uses ML, doesn't he? He uses machine learning to certainly to do his auto cell stuff. So have you seen at any one time you can have like 30 patches, 300 patch set called auto cell. And I think he uses machine language to go and select those. So it'll be commits without a fixes tag, without CC and stable. Just go and churn through them. So anything that says I fix this, I rectify that, and I presume it's certain keywords that he uses. They will then get backported as part of his auto cells patch set. I'm assuming you could do something similar with this as well.
Yeah, so I was checking a few other ones there. So for example, there is one. So actually, a lot of those are from file systems. So the yes, the UDF one is actually a case where basically we have rewritten directory handling code and that has fixed some of the bugs. So it's kind of expected, but we didn't want to backport it to stable because like that's kind of if you do subsystem rewrite, then it's kind of questionable whether you want that in stable or not. So because sometimes the known bugs are better than the new unknown ones. So that's kind of the trade of the distributors.
I think we should add maybe some form or whatever, where you can just leave some comment like why it should not be backported, just to maybe keep some track.
I think that'd be ideal. If there's some kind of feedback that we can give, like I've talked to the maintainers, they're happy that this is an issue and they're going to stick with the issue rather than try and work through a fix. If we can mark those in Sysbot, that would take a lot of work off my backlog.
Some sys text, whatever.
Yeah, I don't know how you would implement it, but just like I've spoken to the maintainers, they're not going to fix it. Too risky, that sort of thing.
And for example, this ext4 issue that we know actually is mostly like logdep false positive.
Yeah. There are, as I mentioned, there for 5.15, it's around 65%. Seem really correct. I think I have I may have misattributed some because I don't really have expertise in that code. But for 6.1, the quality was pretty good actually, 85%.
Yeah, so this was actually, so this is a correct report from Sysbot, like because we were really getting logdep reports about log inversions, but we did an analysis and concluded that yes, like the logdep complains, but the deadlock is not really possible. Yeah, and so we like didn't CC the stable kernel when we were actually fixing it because it was mostly a debugging annoyance.
I think it would be nice to backport this because people, and we and other people, I think, keep on fuzzing older kernels, and just when you fuzz, you probably don't want to duplicate that work. Because it would still look like a bug to everybody who has taken this LTS branch and has begun fuzzing.
Yeah, so this is kind of questionable. I understand you that for the automation and stuff like this, I guess we can change the. Well, so far we were kind of, conservative in that if we know it's not fixing a real bug, just this.
It's just changing some logdep annotations or some assertions. I think it's better to backport.
Yeah, so this is not actually change. Yeah, but the problem is that we have changed actually how the code works. Yeah. Because it was basically the log it was taking was more or less pointless. So how we fixed this logdep report was that we actually created some special functions, not taking the logs we wanted, and then basically the logdep complaints went away. But it's exactly the question, like, do you want to take the risk this somehow inadvertently break something? But we didn't know that it could have broken anything. But there is always some chance that we have missed something. Yeah. So this is a question. On the one hand, you have mostly a cosmetic problem of false positive logdep report, and on the other hand, you have possible breakage of real logging issue. Yeah, so that's why we kind of opted not to send it to stable. This is one of the forgotten ones. I should have. Yeah, I should have CC'd this to stable. This is actually my bug. This is really.
Okay, no, you have expertise in all those subsystems, and you can immediately understand. You know every commit.
I did one of those commits, so I just am paging in the context, but I know what was
going on. How could we, I don't know, let you maybe add some comment or let these comments not be forgotten, because for everybody else, these look like backports.
Yeah, sure.
And they don't have all the context, like where it should not be backported. So if I send it to Sasha or Greg, they might just, if it applies, they can grab it.
Yeah, if you have some, probably on the web it's bad because target for spam and stuff like this. Yeah, if you can leave there some comments in the dashboards, or then I guess it will. I can classify at least a few one, or 10 of those seem to be that I know enough about the changes because I was either writing them or reviewing them or merging them, so or at least saw them fly by. So I could probably comment on whether it makes sense to backport or not. Oh, okay. Interesting. So this I don't understand. Okay. Yeah. Anyway, interesting work. Interesting work.
Yeah, just the purpose statement should help us with triaging those issues because we do pass them internal little kernels and we see all that.
Yeah. Also, I like the idea of fuzzing the fixes because I think that would help to like similar as 0-day actually does like compile testing of the patch sets on the mailing list. Yes. So basic, I'm not sure if you know, but so 0-day testing done by Intel, they basically pick patches from the mailing lists and do all the build tests on them even before they get matched.
Kernel testing bot or something?
Yeah. 0-day bot is basically kernel testing bot. So what it does is it takes a kernel, and it does compilation testing with all mod config and also like various like predefined configs, and then also randomizes the configs and tries to build with random config and so on. It runs also some basic tests on it, like LTP and similar test suites basically. And they not only do this on Linux Next, but although they monitor like some maintainer branches and do this on maintainer branches in Git, and they also monitor some mailing lists. And when there is like patches submitted to the mailing list, they like try to apply it. If it applies, they run all this basically suite of tests on it as well. And that helps, exactly as you said, that helps with like hashing out these issues before the patches actually get merged. So the original developer actually has to address them. Because I, as a maintainer, if I see the patch set in the mailing list and there is like 0-day reply, this doesn't build, this triggers. Okay, so I will say, okay, so I don't have to care about this patch set. After the guys fix this, I'm going to spend my time reviewing it. Of course, sometimes, usually it's ideal to run in parallel. So I do the review for like the architectural kind of thing and I rely on 0-day for does it actually build. Yeah. So, but definitely it's useful because basically the developer does the work. Yeah. And not the maintainer doesn't have to triage this and then fix up and
not find all errors.
Yeah. So I like the idea if you can do this for Sysbot, as you said, like since you have the corpus of the tests.
At least that could be maybe the first step.
That would be really, I believe, really useful and really like good for reducing the load on the maintainers. Even like if the maintainers can somehow register, their branch, and you would like run the you would run your corpus of the tests on the branch. That would be also great. I'm not sure how much like resource intensive that is, whether it is feasible. But
we just estimate how many actually. There was a plan that, or maybe after the conference, I'll get some time to do it. Actually, we can parse these patch series and to try to understand how many problems we could have caught by actually running this corpus on this patch series. It's just an idea, but we don't know how effective it would be. Not only we justified by the number of resources, but it should also find something.
Oh, of course.
But fuzzing it seems like an even bigger problem, I think. So like just fuzzing a patch seems to be even a more complicated problem. Like how would you differentiate problems that appear because of it from the problems that are on the kernel for the patch series?
But it's all the same issues that 0-day is facing. Yeah. So maybe talk to those guys how they are addressing it.
They only build tests, or they also run some.
So they do
regression tests.
They do build tests, but they do also some regression tests, like functional regression tests. Yeah. So like as I said, they run LTP Linux test project. Yeah. So it's basically they also do run like FS tests, which is basically file system testing infrastructure. and a couple of other tests, even some performance tests, but I don't think they do run it like on batch sets, or maybe they do like some limited set. But
these people were here at conference.
So no, I didn't see anybody.
Philip Lee, I think is Philip Lee. I think I'm so sure Philip Lee is a zero-day bot guy, but he gave a remote talk, and you should talk to him about bisecting. They're very good at bisecting and might have some ideas. Yeah, he was talking about that in his talk, which I only caught the end of it. I wanted to catch it.
So many tracks.
Yeah.
Easy to miss something.
Yeah. Let me see if it's Philip.
Yeah, but anyway, they like have to solve all the same problems as you have to. Yeah, basically, whether does the patch set even apply? Is the problem actually new? How to bisect it in the end and stuff like this. So I believe you could maybe share at least the ideas, if not code.
Yeah, it would be interesting to discuss. Yeah, Philip Lee is the right guy. Philip.lee@intel.com.
And their work is called
Zero-day bot or K-build. I don't know. It's a bad naming scheme. They're not.
Yeah, they are also running all sorts of static analyzers, something called like Smatch and.
Here's another zero-day bot question I was going to since you're. You guys are sending out, how many emails do you send out a year?
We, at least in terms of bugs, we report around 1,000 images.
That's not a high number.
That's not high. Yes, we get a lot more attention, I think, than we do said. But it depends. Some year we 1,500.
It's still not high. It's 3 a day.
Yeah.
Do you look at the emails before you send it out?
We do find much more than we do report. So we have some filtering rules.
Okay.
We would prefer to check
Do
everything.
you manually filter? It's not. It's 3 a day. It's
It's 3 a day after all the filtering. Before filtering,
Yeah.
dozens a day.
Okay. So, but then the 3D, at some point, is there a manual in there?
There is some internal review stage. So people at Google have a chance to keep reports for several days before reporting them, and actually many of them get triaged. That they understand if it's very important or
Okay. I would be tempted to send it immediately. I do, the K-build bot sends Smatch patches, which is my static checker. But when I still look over them, actually. So there's some Smatch stuff where it sends automatically. There's some like false positive stuff, particularly the initialized variables tends to be kind of false positive heavy because Smatch assumes, anyway, it's complicated. Smatch assumes that if it's unknown, then it's really unknown. So you go through a loop, it's like, we might not enter that loop. That's the common cause of false positives. So you could have a negative number, and then the developer says, it's never going to be negative. It's 1 to 13 or whatever. So I just filter those out. It sends me an email, which is I get that, and I write an alias, which I press K, and then I edit out some headers, and I tweak. I normally put a little note in there about here's the bug, and I hit send. It takes me a few minutes to look over one of these every day.
from the bug reports themselves, they are, I think, mostly quite reasonable. Now we report there are a few problems, professional problems that we do have sometimes. But in general, I think these reports that we get after all that automatic filtering are mostly about actual problems.
Okay.
But yeah, I was surprised that I think I also had the impression that we sent more, maybe. But I did try to code to iterate many times on the statistics, so that was what I got.
Okay.
But from when I look at the actual in my inbox, I think I
sometimes I see more. Maybe just it's different because it's sometimes on weekends it accumulates. Sure. Or maybe Sundays more, Sundays fewer.
I'd be tempted to not delay 2 weeks. I'd be tempted to just send it. And then, but I put in a note, like, here's what, this is like, let me see if I can send okay, let me look at your. People will be happier when they get in there. That's my, they're like, oh, wow, what a lovely email. Instead of it like a robot.
Yeah, should really be free for Potato. Just get a lot of emails. People will send a patch testing request. See what send it almost several times. Number produced in the section. It will be free for reports per day on average.
Okay. That's not much.
That's not a lot.
Yes.
Now some splashes when we cover some use of the system. There's a lot of attention.
So here's one. Here's my most recent one I found, where it's like, oh, this is a terrible format. I don't know how to make it any better. If I can flip my screen over. So there's like so okay, this has got so I'm, for me, I got the line number, right? So what happened was,
it's git blame.
Yeah, this is a git blame output. It's slightly edited, I think, because I told him, it's going too far off the edge. So I remember this differently. One guy added locking, and one guy added. Where's the bug? There's the locking. So this guy added a lock, and this guy added an if statement with a return. And they were merged on the same day, and so I was like, oh, actually, guys, you created bugs for each other. So I put in a little note. And then there, people are like, oh, what a lovely little note. Instead of seeing like a faceless little faceless robot, they see a little note from me. Yeah. So otherwise, Sysbot is great. Yeah, and great talk. Yeah, I was working with George Kennedy. Do you know George Kennedy?
I saw the name.
Yeah, he is using Sysbot at Oracle. And he is collecting all the reproducers. The reproducers are very useful as well. Experience. I wish they had were annotated with like a break in the fixes tag. You guys also, there's another thing that you don't do right. You need to do this better, like throughout, which is that you need to use 12 character hashes. Your characters are like 8 character hashes. Let me see if I can find this as well. Maybe it's out of date. But like commit messages should be the same format. Okay, this is that's a commit head. That's it. Okay, that's it.
So do you remember increasing the number of hash distribution maybe 2
Yeah,
years
yeah,
ago?
yeah. Maybe I'm out of date with information since I looked at it last. I haven't been looking at it. I used to track it more closely. Yeah. All right, good.
But that changed 2 years ago, really.
Yeah. Yeah.
One question. Unless we cover this on issues or this is change something that doesn't they mostly find yeah, but yeah, whenever changes are made, health systems being an nature, we made these changes and there was a huge splash of bugs which actually quite old.
Contemporary.
There were a few classes of that programming that you know, consumer boxes. They were very, very loud about it. Yes, that's what they were most loud about. Generally, we're heavy either with mounting process. Maybe we're not supposed to, but it's an interesting position.
Yeah.
Really right to optimize for mounting techniques. Probably difficult to predict, but even in reality, you can basically observe USB flash drive or something like that. Still, and it's broken, and then the whole system is crashed because the command system. Yeah.
Morning. You're just squatting here, or you're here for a session? Ah, wonderful. Ah, okay, okay.
You still need some channel to send signals to the device and get feedback.
No, only with the hotel Wi-Fi.
Oh, yeah, hotel Wi-Fi is tragic.
Yeah.
I was trying to do something last night. Well, probably only competing with one or two.
Yeah, I couldn't access anything, so I just no, but
I finally gave up and did my Wi-Fi hotspot on my phone.
Right.
Pretty
yeah, maybe it's a good thing not to go up to the room and then still work. I mean,
Yes.
Kind of helps my work-life balance, to be honest. But,
like a worldwide no communication.
be like Sunday. No work.
There should be a day, there should be a day set aside every week.
Yes, you should get a cracking for that. Good idea. Morning.
You go to the Riverside yesterday for dinner?
No. Why? You have a headache? You have a headache?
No.
Okay.
I was just asking.
Oh, no.
We ended up on a Mexican side.
Okay. No, I just had some dinner here and then crashed in my room. Then woke up at 8:40, so I'm officially over my jet lag.
Really? I woke up at like 4:30.
Yeah.
Oh God, I'm hungry. Basic problems.
Yeah, no, I've been here since Friday, so I'm past my jet lag now.
Yeah, the last trip in California was interesting because when I got back, 4 nights in a row, the moment I fell asleep, like half an hour later, the kids woke me up. I was like, I've slept, I'm fine. It took me like 15 days to shake off the jet lag.
Yeah.
This is gonna be fun. Once people realize what we've done, this is gonna be very funny.
What
the standalone event magic.
Oh yeah. Yeah, so playing around with that stuff for Risk 5 as well, huh? That want to reuse the same.
Heinrich pinged me and said they want to use standalone event. I did this because it was the easiest thing to do on existing hardware, and we designed it properly. And maybe fix it properly.
Yeah. Oh, I can't believe we're still talking about this thing.
Yeah, but it's not a software problem. It's
yes, yeah,
it's a hardware problem. Yeah. That's it. Yes. Thank you.
So, hello everyone. I'm Elias. I work for Linaro. I'm nowadays primarily involved into firmware, and I want to talk to some work we did about embedded bootloaders, embedded systems, and what's the status of EFI in general, and things that we've solved on the EFI subsystem, or not the EFI implementation on Linux. So the EFI is getting some traction into embedded hardware. There's boards and bootloaders that implement the EFI spec or a subset of the EFI specification. Embedded boards, the embedded industry finally figured out that they don't want to boot a custom image per board, and they don't want to customize every OS they boot. So there's the EBBR, which is a specification that's not platform specific. I think RISC-V also is also trying to do the same thing. It works in U-boot, and it basically relies on a subset of EFI interfaces to provide a common way for various architectures to boot an OS. Which brings us to the next point. So when you boot an EFI system, you rely on some variables. Those variables will do various things, decide what OS you're going to boot, decide some platform-specific things, but they also include your system security. So you have your platform keys and your key exchange keys, the DB, etc. And the interesting part is that the EFI spec says that this needs to be on a tamper-protected, delete-resistant medium. What the EFI doesn't tell you is that in order to have that at runtime, that's basically a hardware requirement that says the flash has to be under the control of the firmware forever, and it has to be delete and tamper resistant. The status on the embedded board is not ideal. We don't have that hardware. I'm aware of some boards that have flashes connected to ARM Secure World, but they're not delete resistant or tamper protected or anything. But many boards have an eMMC, and the eMMC has a replay protected memory partition, which basically adheres to everything the EFI spec says about storing keys and variables. This is not specific to U-boot. I'm just bringing U-boot as an example because it's the only bootloader that is compliant and does that stuff for now. That's completely irrelevant. But it is compliant with EBBR for a couple of years. We can boot embedded, we can boot standard distros, off-the-shelf distros, as long as your board's driver are included. You can run the installer and boot the whole thing. And we have two ways of storing the variables. If your board has an eMMC, we store it on the RPMB. If your board doesn't, we store it on a file on the ESP partition. The way we present the variables to the kernel or the OS that's about to boot, we copy them on a piece of memory. We mark that memory as runtime, exit boot services gets called, etc., remaps that region, and then we can access the variables. We only have get variable and get next variable. Nothing else is supported. Query variable isn't. We broke that. And the set variable is certainly not supported. And those are the challenges, right? Okay. There's not too many cases where you need runtime services or runtime variables anyway. You basically need them to configure your EFI boot manager. When the installer finishes up, you need to configure something. You need to control maybe some boot options, boot a different OS at some point in time. And it's needed if you want to do capsule updates. If you want to update your firmware, you need to set a special variable so you can trigger the capsule update on disk. Yes. Yep.
Also, secure boot variable updates, or
Yes.
is that?
No, it's
that wasn't in your list there.
Okay.
So.
Yes. pStore, maybe, but we don't support that. And due to the implications, it's kind of impossible at the moment. It might be in the future, but no. The interesting part is that if you look 2-3 years ago, the U-boot code wasn't doing something bad, right? It was returning not supported, but the installers were flashing a bit red screen, right? The installation failed. Nothing is going to work. I can't do anything. The funny part is that if you rebooted the board, everything was working fine, because the EFI spec has a way of searching for a default named application and boot that, and the distro installers use that naming. So we could boot perfectly fine. Fortunately, that has changed. So if you install a distro now, you get a message that says, I can't set the variable. This might be a firmware bug. You'll probably be fine. So what we did do, we tried to use the RPMB whenever it was available. Again, we're on ARM platforms. We have some prerequisites for that. The good thing is that the RPMB adheres to all the EFI needs about storing secure variables. What we did do is that there's an application in EDK2 which is called standalone MM. It's basically responsible for all the cryptographic checks and all the variable checks you need for EFI. We didn't want to rewrite that. So we figured out that standalone MM is self-relocatable to begin with, or was almost self-relocatable. And we managed to sandbox that thing and run it into Opti. So we had all of the cryptographic checks, everything we needed. We could support PK, all the authenticated variables. We could support them perfectly fine. The only thing that was missing is a very small layer between standalone MM and Opti. So when standalone MM was done processing, it has an API with Opti that says, I'm done with the buffer processing. Everything is fine. Please go write that on the whatever medium you have. And that's the only piece of code that was missing. There's a problem on that. The eMMC and the RPMB are not in control of the firmware. They're not under the control of Opti. They're under the control of the OS, U-boot or the OS when it boots up. We have this requirement, which we're trying to change, but the requirement basically is that when Opti is done with the buffer processing, it dumps the buffer in user space, and there's a user space application that does an IO control to the eMMC controller and writes that data. This is how it looks like. It's not that scary. You basically enter into Opti, you transfer that buffer into something that standalone MM understands. You go into standalone MM, does all the processing, sends you a buffer back and said, I'm fine, everything is fine, can you go please flush that? So eventually this ends up on your RPMB. And it does adhere to everything that the EFI spec says, because it says you have to return from a set variable when you flushed everything on your final medium. Do you want me to stay on the slide, or shall I skip it? I mean, we can discuss it. There's even a mistake there. The reads are not from the RPMB, but that's basically what happens. Questions or?
You can just go on.
Okay. All right. So this is not perfect. There's a few problems. The first problem is when you try to do set variable at runtime, the kernel is supposed to call into a runtime preserved section from the firmware which is remapped, and it calls into magic code, and then things happen, and your variable is stored. Opti, so we should preserve Opti and standalone from U-boot. That's fine. But there's this supplicant requirement. So when we exit the OS, enter the firmware, the variable gets processed, and when Opti comes out, Opti is now in firmware context, and it's trying to find the supplicant running on the same context, and it's not there because we haven't preserved that. So we can't complete the write. We could preserve a version of the supplicant on U-boot, but even if we did that, you need the drivers as well. You need to preserve the drivers on the firmware as well, and that's where it gets problematic, right? First of all, it's a huge amount of code, and second, the MMC, yeah.
So you're basically saying that the boot stage uses different supplicant than the runtime stage,
yes,
right?
exactly.
So you have to switch from one to
exactly.
the other.
When Opti exits from that RPC call that it does, you're basically in firmware context, and it tries to find the supplicant, and it's not there. And even if you keep it, you need all of the machinery, right? You need the MMC drivers, but the kernel is already in control of the MMC at that point. You can't just go map it and do things.
So is during the boot stage, is the supplicant provided by
Yeah,
U-boot?
by U-boot. So on the there's no problem on boot time. That's dealt with. It works perfectly fine. The U-boot has a version of the supplicant, flushes everything on the RPMB. So what we did, there's a few patches under review. We tweaked Opti a bit, and it has a discoverable bus. Basically, we have devices and services sitting on that bus, which is perfectly discoverable. The Opti module comes up. We already use it, for example, if you have a firmware TPM, that's how the firmware TPM works. It's scannable on a bus, and when Opti comes up, the firmware TPM comes up. So we plugged in standalone MM into that. Basically, there's a functionality in there, says, I can do EFI variables, I can do variables for you. So the Opti module comes up, scans the bus and says, all right, I can handle variables. Do you want me to do that for you? The tweak here is, because we rely on a user space application, the probe function that basically changes the runtime services on the kernel, that's what we do. We change the callbacks of the runtime and direct them directly to Opti. That doesn't happen when you load the module. That happens when you start the user space application that gives you access to the RPMB. And there's a few things happening in there. First of all, we swap the kernel callbacks. And second, we remount the EFI var file system as read-write, because when the file system comes up, the firmware says I don't do set variable, so it's mounted as read-only. So there's a chain notifier in there that once the supplicant comes up, that's the important bit. The probe function only runs when the supplicant comes up. Everything is mounted as read-write, and we now have a complete set variable implementation. Good parts, it's fine. The RPMB is replay protected. You're kind of safe. Standalone MM is self-relocatable, and it's completely hardware independent, so you don't have to even recompile that binary. You can use the same binary across different hardware, and it works perfectly fine. That's because the standalone MM is backed by the PI spec. The RPMB is backed by the MMC spec. So it's literally hardware independent. There's nothing you have to change on that application ever. It solves the problem. You have set variable at runtime. You can enable secure boot at runtime. You can do capsule updates. You can do everything you want, and it solves all the distro problems. It breaks the EFI spec. You don't go to the firmware. Well, technically it's firmware, but it's not the EFI firmware that you go to. The kernel relies on a user space application. That's not ideal, but that's always the case. I mean, we did that for the firmware TPM that was pre-existing because before we did the whole thing. We did figure out we can get rid of it. It's not that simple because there's an ecosystem around the supplicant, but if you only need the RPMB accesses, we can move it into the kernel. We can basically be very careful about subsystem violations, but we can teach Opti to access the MMC subsystem and write that stuff directly, in which case you won't need the supplicant. The kernel will be completely self-sufficient on that. The writes are a bit slow, and it's a bit weird because it depends on how good your eMMC driver is, Opti, how many cores you dedicate to Opti. Opti doesn't have its own scheduler. It gets scheduled by the kernel scheduler, and on top of that, it encrypts all the data it writes on the RPMB. So it might take some time. But arguably, when you're about to do a set variable, you're about to reboot anyway. So, and yeah, the entire solution is complex. You need U-boot, EDK2, and Opti to play along for that thing to work. But because everything is based on a spec, that's probably the reason why it hasn't broken for 3 years. That's the parts that we have on the RPMB. I'm gonna stop now because I have a proposal about, you know, the worst solution of storing variables in the file. But that's the part set on the RPMB. That's how things are working. There's one thing that we could discuss: how do we revert the file system from read-write when we unload the module? Unloading the module doesn't mean the file system is going to go to read-only. You need to unbind the service from the sysfs interfaces. That's a decision to, you know, make the kernel simpler, have a single exit point from the kernel. Because we have a file descriptor of the supplicant. If that dies, we could just revert it on the spot. But that's an implementation detail because.
So with the supplicant case, right? If the kernel calls into a firmware service, like it disables preemption and kind of locks the thread that's calling it, is the call into EFI, into Opti, into standalone MM, back to the supplicant, back to user space, is that like completely synchronous?
Completely
synchronous?
Yes.
So the CPU is blocked on that entire call stack, and then it comes all the way
MM buffer says you need to. The MM buffer specification says you need to keep the interrupt disabled, and we do that in Opti. It's a bit of. We don't have to do it. We've tried it without it. We haven't seen any implications, but the spec says we should do it. But we can look at it closer. Like, I mean, if there's no problem, we can probably do it asynchronously.
Yeah, I would be a lot happier if at least the supplicant runs in the kernel.
Yeah.
I mean, it's still kind of inverted thing, but still.
Yeah, it's a lot easier, right? Because I don't like the fact that if you kill the supplicant, the file system doesn't go to read-only, and you need to echo something on a special device. But we would introduce, you know, dual paths into the kernel about cleaning up stuff, and I don't like that either. So what I came up with is that.
I mean, on another file system, a write can fail if it's mounted read-write. So that I'm not too concerned about.
Yeah, exactly. First of all, it's not a big problem. Second, we're going to teach the supplicant to do that unbind when it dies. So we're going to have a signal handler in the supplicant that when it dies, it's going to echo that thing into the unbind device. So you're going to.
In user space?
Yeah.
Okay.
So the supplicant is going to clean up for himself, and you still have one exit point from the kernel, which is, I think it's better.
Okay. Awesome.
So you've mentioned the two paths of using RPMB through the supplicant and using variables in a file, because you said that generally hardware doesn't have a storage bus that's exclusive to secure world.
Yes.
If you do have that,
you can do everything. Yeah.
So then you would also support that method as well. Just everything happens in Opti, and Opti does the storage. And
we have to change U-boot to move some sections into runtime, but you don't have the hardware problem of I don't have access to the hardware. So U-boot does need a bit more work, but it's not huge.
Okay,
we
so
just
that
have to mark some sections as runtime.
Okay.
So firstly, sorry, I don't know if you have more slides or if just.
I only have a discussion about variables on the file, but that's.
Okay, so I don't know so I'm sure you know this. I don't know if everybody knows this. Would it be worth me just giving a super quick overview of how this works in the x86 world so we can kind of have a comparison? So x86, we typically have a couple of advantages that you don't usually have in the ARM world. The first of those is that firmware typically has its own independent storage hardware. We typically have a piece of SPI flash, which is not used by the operating system in any direct way. And on a typical x86 motherboard, that flash is connected to the motherboard chipset, and the motherboard chipset has functionality built into the SPI controller to allow various regions of that flash to be marked as readable and writable in different contexts. And one of the contexts you can set is that specific regions can only be written in system management mode. And for those of you unfamiliar with this, system management mode is kind of like a version of Trust Zone that sucks even more. So unlike Trust Zone Trust Zone, you've got a basically completely separate world. System management mode is not a separate world. It's basically a separate protection level. Entering system management mode on a core stops all operating system access on that core. Typically, for some of these things, we will synchronize all accesses. So all cores will end up transitioning into system management mode. And then system management mode is able to write to areas of the flash that the normal operating system can't. And there's no synchronization issues there because while the firmware can choose to expose the SPI controller, but then SPI is a sufficiently simple protocol that it can just ensure that it can save any state that's in the controller, do its access, and then restore the state. So this is transparent to the OS. So that simplifies a bunch of this stuff at the cost of we end up having to put signature validation code in system management mode. And then there's no internal protection in system management mode. So any vulnerabilities there would be the entirety of system management mode is now a disaster and we lose badly. So far, nobody's found one of those vulnerabilities. But I think a sort of follow-up to that is obviously the spec somewhat centers around assumptions that were made in the x86 world. Exactly. And so I think we should not go into this model into any of these conversations with a concern that remaining true to the letter of the EFI spec is a hard requirement for anything to be considered acceptable, especially because if you believe that in any other context, people believe that a strict alignment with the EFI spec is a requirement, you're going to be extremely disappointed. I do have one question first up. So firstly, do you know how Windows on ARM handles this?
No, I haven't.
Do you?
They do it on reboot or?
No, they basically have what we have with the EFI vars register thing. They allow like
new. Windows on ARM, not Linux. They merged the similar thing for Qualcomm laptops running Linux.
So Microsoft allowed Qualcomm to provide something that just hooks the higher level variable access code in Windows to use something else than calling the EFI runtime services.
Basically the same thing.
Yeah, that's why they implemented this this way. So it's like some OPT trusted OS interface, and they just swap out these function pointers entirely.
So that's exactly the same thing, right?
Yeah, but I'm assuming in their case they have dedicated storage that they can access directly from the secure world without requiring this supplicant.
I'm not sure.
It's worthwhile to point out that this is on the client parts because the server parts just
yeah.
The Windows on ARM, right? The server version just has normal runtime variable support. It doesn't do the whole PEP thing, calling back into the kernel and letting a random driver run, right?
So yeah, Windows client on ARM. My understanding is that in modern versions of Windows, the typical model here is not that Windows is expected to run on a generic ARM laptop, but that the vendor is required to provide a HAL layer. And whether that then implements stuff in userland or in kernel space, I'm not sufficiently aware of the details, but it does mean that the SoC vendor can just provide a shim that is able to speak to hardware itself without any OS level drivers or userland being involved in the process if it wanted to.
Yeah, I mean, the idea is not
right. So it doesn't sound like if you're concerned about violating the spec, then it sounds like the spec is woo.
That's the least of my concerns. I'm just mentioning it.
Yeah. So and one final question I had, which is I think you just alluded to this. So this is all obviously required if you want synchronous updates of variables. And an alternative is that instead of actually writing stuff to RMBR, you could stage stuff in firmware-owned memory, and then on reboot, that can be applied in the U-boot environment.
Yeah.
So there are some trade-offs there. Obviously, that approach seems simpler, but
that's
so this is
that's the variable.
Okay, so I think when you said file, I was sort of thinking not necessarily in file, but in RAM rather than hitting file system, which then leaves everything entirely up to you and U-boot to negotiate.
Yeah, that's. I mean, I think that the RPMB we should keep the synchronous one. If you're storing variables on a file, which is U-boot specific for now, but we're trying to standardize it, then that's what this slide is supposed to explain.
Mm-hmm.
How do we deal with that? And we're trying to stage it on memory.
Right. So U-boot would then obviously have to itself replay all the authentication stuff and verify that before
if the
applying.
variables are on a file, we say we don't support authentication. That's it.
But you could. U-boot has access to all the information it would need to do
what
that.
we do, what we do to support UEFI secure boot on if you don't have an RPMB is that we have a section on the U-boot executable and we preserve the PK there. So we hope that you do the right thing and you do chain of trust And if you boot that chain of trust, the only place that it can convince itself to load platform keys is the U-boot binary itself. You can't change them. We don't allow you to write them. We don't do anything. You have to update the entire U-boot if you want to update DB, etc. But that's
sure. Yeah, if there's no authenticated storage
exactly
on the platform, that's completely unavoidable.
I'm looking at Jeremy to keep me honest here, but don't we do that on RPI4 with Tiano Core?
What's that?
Like have the writes basically cached in memory somewhere and then write them back when you do reset system?
It's just too hard because KZ and all that other stuff. The only one that persisted.
Right.
But just to add, this whole thing is
Wait.
really frustrating. It's just really frustrating because every time I look at these platforms, this is a board problem. It's not even a hardware problem. There's SPI controllers all over these SoCs that you can take over. You just have to basically attach the 10 cents worth of SPI flash to them.
I agree.
Assuming the board does have a SPI flash, what's the solution there, right? Do we have like
a platform that has a SPI flash connected in the secure world?
So, like, I'm just thinking of some of the boards I'm familiar with. They have a SPI flash that right now is not on the secure world. It's used to store U-boot and possibly a fit image containing Linux and the U-boot environment and that sort of thing.
Yeah, but then you need to convince the board to be able to boot from that flash if you move it on the secure world.
So, well, I mean, they all come up in the secure world to start with. So normally we just say delegate this to the non-secure world. Well, if we just didn't do that, right? How would that solve the problem? Would we be able to use that SPI flash directly? And
yes,
maybe if you wanted to say allow like a portion of that flash to be writable from the non-secure world, use something like, I don't know, VirtIO or something crazy to delegate access to a portion of the flash.
Yes, you could do that.
Yeah, if you have direct access to SPI, then you can modify all of the authenticated variables without any authentication on typical x86 board. And that's, as far as the EFI spec is concerned, that's completely fine. The actual level of security you want is more of a, EFI doesn't care about that. That's a board design. That's a what is your threat model kind of scenario. I know that there are ARM parts that do end up keeping this in basically, I've seen places where there are ARM parts where they set SPI flash and they appear to have been storing stuff there. And then that's encrypted with a key that's trust zone backed. So there's no physical attack is suddenly a much more difficult scenario. But as far as the spec is concerned, yeah, whatever.
So you allow the non-secure world. So you're saying it's fine to give the non-secure world access to the SPI controller as long as there's some sort of like encryption done on the flash itself, that so only the secure world can access that portion of the flash that it cares to be authenticated?
I'd say that as far as the spec's concerned, sure. The effect in that scenario would basically be it's a denial of service kind of thing. You'd still be able to overwrite all the variables, and then the behavior of the platform would be inconsistent. You'd probably want some sort of reasonable fallback then, because if I'm just able to corrupt your variable store as userland, then if the outcome is secure boot gets disabled, then that's a change in the security state. Yeah. So but that's an implementation detail again. You need to think through what your implementation choices actually mean. But the spec itself, yeah.
We could solve all that, right? But it's kind of platform specific because you could have a fallback. You could write stuff in a file and say, I trust it, but I have a fallback. And if the file gets corrupted, I'm going to load what I have on my binary.
Right. Like if you have some sort of authenticated encryption, you can verify that, you can know that it's been tampered with. Right, and you can know to reject that and fall back to your default variables, which presumably have some sort of default key that you have.
Yeah, we can use a TPM. We can do a bunch of stuff. The point is find the least common denominator for platforms that are out there that work, and then pick it up, right? Because we can authenticate the file in the end.
Right. Yeah, I'm trying to think of like what works for your small boards that. Like, the minimum is you have RPMB, but maybe one step above that is you have a SPI controller that's used for maybe flash and other things that you can't dedicate to the secure world, but at least you can use that.
And so as an analogy here, in the x86 world, several firmware vendors do keep the firmware configuration just in an EFI variable, and frequently not even an authenticated one, and frequently one that is not boot service only. So in that scenario, you can just set a variable over there. If you're root, then yeah, you can just smash something in there. And if that leaves you in an inconsistent, normally security-specific stuff is elsewhere, but even so, setting that to an inconsistent state will generally just result in the firmware resetting back to platform defaults. And the platform vendor, you are having to trust your platform vendor to some extent in all scenarios. So my assumption would be the platform vendor would, in terms of factory default, would get you back to whatever the original storage keys were. Now, there is an issue there in that that's a world where suddenly you're able to, if you can get DBX back to factory state, then you're suddenly able to boot insecure bootloaders again. And that is not necessarily the expected outcome. But that is a harder problem to solve. Even I don't see a way to avoid this in this case, but it's still better than I can disable secure boot entirely. And if that's coming from U-boot, then that's still a update to a newer version of U-boot that has a newer default version of DBX, and it's less of a big deal.
I'm approaching this from the perspective of like, providing third-party distributions of U-boot for existing boards, where maybe like obviously we'd like to have the most secure board possible, but the security properties are less important to some extent than just having something that follows enough of the spec that we can do board-independent OS installers. What can we follow EBBR and the secure boot is great, but
it's not mandated by BBR. It's optional.
Right. It's a secondary concern.
Yeah.
And in the majority of these sorts of, especially consumer ARM world, what we're talking about here, if U-boot's just on the file system, then unless end users are choosing to fuse their boards into imposing secure boot at the SoC level, it doesn't matter. You can just replace U-boot, and then none of this matters anyway. So unless you're getting into that level of security, then the ability to get stuff back into a default state doesn't matter, because there's easier ways of subverting the entire trust chain anyway.
Thanks.
Got it. So you in the previous example, you were basically showing how you did the whole path all the way to user space in order to essentially just execute a binary that is pre-known, right? Like you know exactly how to implement all the variable services. With EBR, we have a standardized file format, everything, yada, yada. Why don't we just implement the calls in Linux and call it a day? You have to have a pantover anyways that tells you where that file is. If I understand the sentiment in the room correctly, the security properties of this are pretty much irrelevant, because once you are in that world where you actually care about a full secure boot path, by all means, build a board that has a dedicated SPI flash and use that, right? But for the general purpose, random SPC world out there that you just want to run on, you want a viable UEFI-based boot path with variables, but without necessarily security properties, right? And for that, you just need to standardize on a file format and then a location. The kernel needs to follow the same procedures when it updates variables, and you're done.
Yeah, so the RPMB problem is scannable at boot time. So we fix that, if we fix that up on boot time if we have. What you're talking about is finding a common denominator for boards that don't have that hardware.
Yeah.
So that's, okay, I'm gonna do the variables on a file if I have 10 minutes. That's the proposal, right? We discussed about this. We have a standardized format of EFI variables in EBBR now. We're saying this is how it's supposed to be stored if you want to use them. So we have that in the standard. We merged it. We had the discussion of maybe we can reason about the security, but it gets way too complicated and way too circumstantial. So we're not going to do that. We're going to kick secure boot variables out. If you want to do secure boot, just bake them into your firmware, right? And we do the same thing, right? When we have variables on a file, we boot up, copy them in memory, preserve it on runtime, so the kernel has get next variable. Now, the question is, how do we solve the right problem on those platforms? So you can get EFI on those platforms with distros booting up, even if you have just an SD card. So there's 3 possible solutions that I came up with. So the first one was that we ignore everything. We teach EFI tools how to write that file directly.
Don't.
Yeah, I know.
Ignore that option. Not there. Next.
So that's the only one you can warn about failures, right? That's the only advantage of teaching the EFI tools. I know it's horrible. I just have it in there for completeness. So the second one is that we teach the firmware to do set variable at runtime, and it writes stuff on memory. And we have a watcher application on the EFI var file system. And when a change happens, we just sync the variables on the file. That's perfectly doable. The only problem is that if writing the file fails, we won't be able to notify the kernel.
You can just have the kernel write it to a location.
Yeah, that's the third one.
Tells you.
Yeah, that's the third one. Replace the articles like we did and write the file directly from the kernel.
Thumbs up. You got it.
I don't know if that's the best one because I don't know how we can access. I don't know how easy it's going to be to access a file from the kernel. Teach the kernel that.
You don't need to access a file. You need to get a block device and offsets.
Yeah.
You can get the block device using a device descriptor before. You get offsets in that, and then you just have a contiguous, a block contiguous piece of memory that is your backing store, and then you just use that. Art, what were you asking? No.
File has to be contiguous in the file system. Okay.
Or not even a file. It may just be a partition.
Or have user space provide a file descriptor and say, well, here's a file descriptor, have the kernel write to that file descriptor.
Yeah, something like that. But we can do the same thing, right? We can install a config table or an EFI something, a configuration table that says the kernel, okay, the variables are going to be on a file. You need to expect a file descriptor. But once you get that, just go and replace the runtime calls and do the same thing. So we don't touch EFI tools. We don't touch anything. Everything works. The EFI tools right on the var file system. The kernel says, I have a changed version of set variable. I'm just going to flush stuff into a file and I'm done.
Presumably, this is all like on the ESP or something, or the firmware.
Yeah, it's on the ESP. The file is on the ESP.
Why doesn't ARM fix this in hardware?
I'm Linaro.
But the hardware I already have.
Not supported.
If you did have a defined mechanism by which trust zone could speak to the RMBR without the operating system having to be involved, and you had defined synchronization mechanisms around this, then this could be dealt with without.
We already asked for a dual MMIO access on the RPMB. We never got anything.
11 years ago.
Sorry?
11 years ago.
You're also assuming that we have a stack where you own EL3, where you do have trust zone always available, which may also not be the case, where people that build these stacks actually have any clue on how to integrate all these Opti applications in addition. The easier we can make this, the better for the simple use case, right? I'm not talking about the secure one. For the secure one, you absolutely want to have the full stack going all the way top to bottom, but there just make your hardware actually fine, and then you're good, right? For the SBC random thing, I take something off the shelf and build random code from the internet case. Just give them something that writes random variables to a file.
So if you leave out the secure boot keys certificates case, what variables are we actually manipulating here?
What?
Which variables are we actually manipulating here? Is it
just non-authenticated?
Yeah, so it's just the installer that sets boot 0001.
And the OS indications if you need to do captures.
Yeah, but nobody does that. I mean, if you're not even implementing this, then
yeah, we do that. That's the point. We specifically have a U-boot flag that says ignore OS indications. And we do capsule update if we find the file.
Okay.
Just to open the can of worms, I think it would be amazing to have that in-kernel implementation of set variable be in a Rust.
No.
You take Art's code.
The file one?
Second?
The file access one?
No, just basically the actual set variable and get variable implementations that go and access something from that file and give you the respective output. To get variable, you can probably cache, but for set variable, you would need to
the
go.
Get variable is already okay.
Right, so you're caching anyways, usually, right? So that one is not an issue, but you could just implement a caching implementation very easily. But for set variable, I don't know. You don't have to. You can even do it in like 100 lines of C.
Okay.
It's okay.
No, that's
just do it. Just
no,
write it down, send it. I really think we've been talking to about this for way too long.
No, the whole point was to standardize the file formats, right? If we agree on the
Yes.
file format, which the spec doesn't, that's all we need.
Exactly. I mean, I can give you another file format if you like, but just use that.
No,
it's done. And then so the one piece that you are missing is the handover. So how does UEFI tell the kernel where that file resides?
Protocol, maybe, or a configuration table, or a...
It could be a variable, but the variable would need to contain a device path.
Yeah. No, just
Which you could
configuration
do.
table.
No, you're
with
right. Actually, it
device
could be a
path or
variable.
protocol. Something like the load file too.
All right.
So basically, just to inform the OS where the file
where the
actually
file
lives.
is.
Can't just have a standard name in the ESP.
I think standardizing name in the partition probably works. I think there would be a risk that since this isn't defined, then someone's potentially put something there already and find they ignore the spec if that's not a namespace place. So you can probably guess away with that. And if you but then you do have the problem of on systems that have multiple ESPs, which is annoying but legitimate. Then do you really want the kernel to be making that policy decision?
Anything. You can do a runtime call and we can respond from U-boot that this is the file path that you need to access.
But we've got at least
Config
like
table.
4 ways for the
Yeah.
firmware to pass information to the OS. It's just pick one of them. It's fine.
Those are nodes, pick one.
I'd go with config tables just because
Yeah,
they're cool.
config table to keep
But-
everything EFI instead of going and meddling again DT and just keep one way. Yeah, but the config table with the device path would work, right? And if we have an in-kernel driver, that's...
Can the kernel map device paths to whatever?
Don't know. I have to check that.
I can't be certain of this, but I believe that up until last week it probably could because someone probably relied on that in Itanium. Itanium.
Fair enough. Thanks. No, I wasn't. I was just mentioning it. We've already discussed it. I was like, I don't care. Actually, we do not have I mean, we try to, implement the set panel too.
Yeah.
To the first, I don't want to do this.
Right.
This is very scary.
Yeah, I think this is the best outcome.
That's the least bad. That's the That's how I describe it. That's the least bad solution.
I agree. If a hardware doesn't do this, as a user,
Oh, so there is a laptop there already.
Yeah, yeah.
Can we just use it?
Yeah, sure. That's a modification already.
Oh.
Thanks a lot. Thanks a lot.
That's very helpful. Hey, Carsten.
Hey, how do you hear me?
Yes, we hear you.
Can you see me also?
Can see you, yeah.
Great. I can't change the slides, but I think you then just need to give me the presenter once you're finished, isn't it? Or
You can take the presenter, I guess.
yeah, can I?
He might not be able to take it.
Yeah, that works.
Where?
Oh, he did it already. Okay.
Oh, you did it already. Yeah. Okay. Shall we just get started or we start?
Yeah, you can start anytime.
Okay, sounds good. Cool.
I think we want to continue a bit of discussion that we had in the testing micro conference, and also include a more in-depth part with all the regression tracking work that Thorsten is doing, and invite everyone to participate in these discussions on regression. So first thing is, like, we'll do maybe 10 minutes or setting context, and then get people to join and participate into the discussions. So yeah, first thing is regressions are hard. Like, so we know that, and we've been trying to work with that like for quite some time. I think we can move slides, Thorsten. And the thing that we want is to see from you what things can we do to improve beyond just like being frustrated, because I know from our experience that many of the maintainers are become like quite frustrated with dealing with regressions over like the past few decades, and we want to keep improving on the process that we've been building like across the community. Okay. Yeah.
Yeah, we switched rooms. So
Yeah, we switched. Yeah, we asked for that because of Thorsten. Yeah.
Do you notice that this one is like both listed as a PNG and MG?
Oh, okay. Yeah, we just had to do a switch because of the AV setup for Thorsten to join us. Yeah.
Yeah, it was a last minute switch. Sorry about that.
And yeah, pretty much we want to do a discussion on which things we can improve beyond just like getting ourselves frustrated with the different processes across. I'll hand over to Thorsten to go through some TagsBot updates, and then we keep moving.
Yeah, thanks, Gustavo. Sorry for not being around, but I hope this will work as well. Let me give you a quick recap of my regression tracking efforts. I'm doing this regression tracking for 2 years now. I'm doing it with RegSpot, a small regression tracking bot I wrote. And let me show you how it works by using a regression report from Jiri that he posted in that message ID. Yeah, he posted it to a Linux mailing list, and I saw that and added it to the tracking by replying to the mail and including a regspot command, this regspot introduced, which you can see near the bottom of the screen. And then regspot actually noticed this mail and starts tracking the thread. Jiri could have used that command himself to add the regression to the tracking. Yeah, but once regspot tracks the issue, it looks basically for replies, and as long as there are replies, I think I consider the discussion ongoing and nothing too much to worry about. Yeah, and what regspot also does, or what's the key thing, is actually it looks out for other messages that refer to the reported regression. It, among others, does that by looking at link and closest tags in patch submissions that link back to the regression report, like in this case where you can see the report at the bottom. Yeah, and actually, when there are replies to that patch submission, regspot notices as well. And once the patch lands in next, it considers the patch or the fix incoming. And once the patch lands in mainline is merged by Linus, then it considers the regression resolved, basically automatically. So it works somewhat similar with Bugzilla kernel.org links and arbitrary links as well up to a point. Yeah, but that's how I keep an eye on tracked regression. And like in this case, I didn't have to get involved much at all because everything stayed active, but I will show up with question if things look stalled. So how do I keep an eye on things? Yeah, regspot has a web UI or a dashboard where it lists the tracked regressions actually with some details with the recent activities it saw and messages elsewhere. I don't go much into this detail here because we want to discuss things here. And I use this data to actually compile a weekly report that gets sent to, with the regression that is sent to Linus, who actually reads this and reacts to it. And developers can interact with regspot themselves. We have regspot commands like the one I just showed. For example, when a link closes tag was forgotten. But in the end, they don't have to care about regspot at all. And they don't even have to have to care about my regression tracking work either, unless of course things look stalled or regression is not handled appropriately, then because that's when I show up. So in the EDL case, adding the report to the tracking is thus the only extra work required, because the link and closes tag are old thing that's already there, and not everybody sets that, but it's like I said, they should be there. And then Rexport can use it. Rexport itself is pretty basic, sometimes a bit rough, but it does what it's designed for. A few features I'm working on in the little bit of time I find time to work on the Rexport code itself is one of the things is support for issues submitted to GitHub and GitLab projects, like the CLang project, CLang Linux people track issues there, or the free desktop people track issues there. I'm working on that, but that will likely take another month to get ready. I also wanted to separate actionable and non-actionable reports in the UI, so to make sure that everything that's not bisected or somewhat crazy is not messing up the UI, so to make sure the regression that can be worked on are in a focus. And yeah, that are some of the features I'll plan to work on soon. Later, there are a few other things that require some cleanups first. Among them is, for example, subsystem-specific web pages for reports to make sure Rexport itself is more useful for subsystem maintainers. And in the long term, maybe even look at pull requests sent to Linux and give an update there, or check if there's anything in the pull request that is known to cause a regression. Yeah, that's of the state of things right now, basically, as I said, in a nutshell, which brings us to what do you want Rexport or me to do with regression tracking? The one thing I often heard is that some people want to add regression to the tracking that CI systems found. I'm totally open for that. I think that's useful. Definitely something that should happen. But the problem is I need to be able to stay on top of the tracked regression. Otherwise, things get messy. It just becomes another bug tracker nobody looks at. Yeah, and so this definitely needs separation between actionable and non-actionable reports. And maybe for CI reports, only those should become actionable if some human performed a sanity check, which I also do for all the reports that get added to Rexport. I basically look at them and check if they are sane. Yeah, that was actually my part. Yeah, and I think now Ricardo wants to sum up this session we did on Monday. Yeah.
Yeah, well, maybe before moving on, if anyone has any questions about Thorsten part about Rexbot, we can leave that for later. Okay.
I have one question real quick. So does Rexbot send a closes like an email with a closes tag if no one else does, or?
As I said, if things are stalled, then I will notice it, and I will briefly look into the issue, and then I'll send a message to the thread with the report, basically telling Rexport and also the world that the closes tag, which commit fixes the issue. And it could also send mails to the list if a commit with a closes tag hits mainline, for example, or next, to make sure people stay in the loop there. But right now it doesn't do that. But right now Rexport doesn't send mails on its own because I don't want to get people annoyed by Rexport and mails it sends. That's why I'm pretty careful there for now.
Okay, thanks.
Any other questions?
Maybe one point is like, what do we need for Hexbot to start like sending automated emails like from the things that you are tracking?
I mean, code to basically send mails, but when do you want to make Rexbot send mails? Do you want to report to add a reply to every report once a fix lands, or what do you have in mind?
That could be one way. Yeah, like I'm thinking more of how it walks to become like a more system that runs by itself with human interventions as needed.
That basically just needs code, like sending mails and deciding when to send mails. For example, after how many days of when a situation looks stalled, send a mail, for example. That's quite possible. But I mean, once Rexbot starts doing this, people will become annoyed by it, and that's why I'm wanting to make sure Rexbot itself works pretty well and is a bit more polished than it is now. That's why I'm
my question.
a bit
My question
reluctant
goes
there.
my question goes
Yeah.
along those lines. How to not make people annoyed by it if we start like automating more steps of that process? That's like one of the questions we are trying to answer.
Looks like Guillaume has a question.
Yeah, hello. Thanks. It's kind of related. I'd like to bring up the fact that kernel CI is acting as a central place for all test results. Like, people can submit their results, and as a side effect, that can also act as a central place for tracking regressions. So in my mind, Rexbot was more like a way for people to report regressions by hand or via emails, and then that could be one of the sources of regression information that gets stored in a central database of kernel CI. How do you see that? Yes.
The big difference is that I care about all regressions and not only about regressions reported by CI systems.
Yes.
So I also care about users reporting a regression.
Yeah,
that's actually my focus, because I knew CI systems were working on a lot of stuff already. So I kept a bit away from that.
Yeah, so that's exactly what I mean. It's a way to extend the type of regression data that could be sent to kernel CI. If all the regressions tracked by Rexbot were forwarded to kernel CI, that would add on top of the ones already reported by the CI systems. Do you see what I mean here?
Yeah, I see what you mean. The question is what's the best way? Do CI reports go to Rexbot or the other way around? That's basically, I guess, something we need to discuss.
Yeah. Okay. Well, yeah, because in my mind, some CI systems run some tests, generate some regression data, and Rexbot is a way to do this by hand. Like, people will be working on patches and reply to, or send some emails and report some regressions manually. So to me, it was like on the same level as CI systems. You have developers who do this by hand. If we wanted CI systems, like I mentioned, to send data to Rexbot, I think they should duplicate the work that kernel CI is aiming to do. So
I didn't get your last 5 seconds. There was some alarm. Sorry.
Yeah, if you get CI systems to send regressions to Rexbot, and to me it seems like this is duplicating what kernel CI is trying to do, because kernel CI is not like a random CI system. It's designed to be a central database for storing data from other CI systems. It's not specific. It's not like a Linux system or an Intel system, or it's trying to be the database for centralizing information like this. So if you have all regressions both in kernel CI and in Rexbot, sorry, this another siren. I don't know. It seems like trying to maintain two sets of data in sync, which is never going to work. So.
But how could kernel CI actually maintain reports that come from users and ensure they are?
Well, Rexbot does that already. Rexbot parses the emails, so it has the data, so Rexbot can forward this information to kernel CI like other CI systems do.
That could work, yeah. We basically would need to think about that, yeah. What direction is the better one there, yeah.
Mm-hmm. I think the other thing is going to be complicated or like causing problems. But, okay.
I think the other feature of Rexbot that's important here is the actual tracking of the lifetime of the regression. That's one of the interesting things that I see, at least on the Rexbot process, that we found regression may come from a user, may come from CI, but there is a process there to follow up through and figure out when the regression speaks it. And that's kind of becoming a bit of a standard for some of the regressions we've been finding from users.
Yeah, I think that will also be part of what kernel CI should be doing. It's part of the user stories for the user experience. So if Rexbot can already track when a regression has been fixed, it can send this type of information as well to kernel CI, even though that support is not quite available yet in kernel CI, but it would make sense for
actually, thanks to Gustavo and Calabra, Rexbot actually exports this data as JSON these days, and it can be queried everywhere from the outside. Yeah, they provided patches for that.
It sounds good. So yeah, query or directly forward it.
Yeah, obviously that's just code. Yeah.
And may I just ask a few stupid questions to understand the context better? I at least before this talk, did not have much experience with Rexbot. Do I understand it correctly that the intended operation that somebody reports an issue to the mailing list, then you send Rexbot command to tell Rexbot that this issue is happening starting from that kernel release, and when somebody sends a patch fix, then you send another command like this is a fix for that. Am I correct?
No, normally that's not needed if the main developer actually uses a link and closes tag that are supposed to be there. The main developers are supposed to use the link and closes tag to link to the report, and if Rexbot tracks the report, then it will notice this link automatically. So then I don't need to send another mail, only when it's forgotten.
And the ultimate purpose is to make sure the fixes reach stable branches, or just so that no issues remain forgotten.
The ultimate thing is to make sure the patch reach the tree where the regression happens. That can be next, mainline, or stable tree. But yeah, obviously the most important thing is to ensure that regressions get fixed. Yes, in a reasonable time, so not after months. So quicker, ideally.
So I'm from Sysbot team, and so the question is, can it be of any help if we include, I don't know, some Rexbot commands in our reports to email? Like sometimes we have, when we report an issue to the mailing list, then after some time we perform cause by section, so we roughly know when the issue started. And would it be of any help if we added some Rexbot commands to tell you also that, okay, here's the report, and it starts from that point? Or
I think at some point that makes sense to have those reports in those issues in the reports that go to Linus, like those reports from Günther that sits there in front of you, as if I don't get things right on the video. He also sometimes reports or regularly reports compile errors to mailing lists, and I add those to Rexbot's tracking and help him keeping an eye on things. And that could work like that with Sysbot as well. Yeah.
Because if it's just one line that we need to add to our email template and it will make everybody happy, then
yeah, it's just one line. But if you flood Rexbot with lots of entries and I can't stay on top of it anymore, then I will become unhappy, and then we need to change something. But yeah.
Yeah. Thank you.
That's where some of the discussions between us and Torch started. Like, oh, can we report something? Maybe no. Maybe like if it's coming from a CI, it's like just too much data. And what we've been doing as part of like a more experimental process from the Collabora side of things to play with the regressions is to go manually through a bunch of regressions. Okay, this one we are going to go through Rexbot and report there. This one too. This one too. But there is a human.
So far you prefer to only for humans to interact with Rexbot after they have understood everything and make sure that there are no false positives.
Maybe I think the limitation, that's what I understood from Torsten as well, is like maintaining the reputation of Hexbot
Mhm.
and the process of the community. If you throw
Not to
100
spoil it
issues
with Sysbot's
tomorrow, that's like
reputation.
yeah.
I think
Okay.
we all don't want another bug tracker that is filled with issues nobody's working on, because that's useless.
So maybe it's like which process on your side would you do to select like the highest priority one and the ones that might have like more likelihood to be fixed by the maintainer, and then Hexbot could track that.
Yeah, it seems like as long as you categorize it as like a, I assume there'd be a label on it. Maybe this is a Sysbot, and we know they're kind of chatty, and I think you had something about categorizing actionable versus non-actionable, and so maybe it's not that big of a deal if you have, if your interface hides, a big stream of stuff, you're not bothering the mailing list with it, but you still have it there. I mean, you could be delivering counts to Linus of the Sysbot issue.
Yeah, Tim, exactly right. The thing is that I just need to code this up and to make sure that it's handled. And I'm just only one guy, and tracking the regression already takes a lot of time, so I don't find that much time to work on the code at the moment.
Because even if not for all the issues that are reported and probably not addressed, then at least if making sure that fixes reach stable trees, then maybe it could make sense to somehow integrate, at least for the issues we know are fixed. Because in that case, we do know in most cases correctly when it started, when it ended, and if you're tracking where it's present, I think it's a useful piece of information.
That makes sense.
Work, yeah.
Because it would be a non-actionable issue, so people wouldn't like the maintainers looking to Hexbot would not see that because kind of filter out. But the Hexbot on the back end is tracking if your issue was fixed. Is that the case?
Yeah, and that says so that Rexbot at least could help track that the fixes reach other trees as well. Because at least earlier I was given a talk about Sysbot, and we actually moving in similar direction. We're trying to find issues that are fixed in LTS, that are not fixed in LTS, but for which we do have fixes in the main line that just nobody backported. So I think there's some overlap in that functionality. Yeah, of course.
Yeah.
There's actually an RT stable team that actually does the RT backports into multiple of the stable trees. And they've got some methodologies that might make sense to look at and then see because those are the sorts of things that we have to do anyhow. But if you're looking at bug fixes, maybe there's things that can be learned from that. Just a thought.
Any more comments?
Gustavo, Ricardo, make sure your stuff also is discussed.
Yeah. Well, there is not a lot left to discuss, because basically what we wanted to talk about was what we didn't have time to talk about last Monday. But yeah, tying it up with what Thorsten has been talking about Rexbot and his solutions to some of these problems and tracking regressions. Can you? I think you still have the. Can you move to next slide?
Wait a moment. Yeah, here we go.
Yeah. Essentially, the problem that, or the open issue that we still think it's there, has to do with what we were talking about the other day, getting more information and extracting more information from the data that the CI systems already have. And what we see is that the information provided by CI systems is still kind of unidirectional. It goes to the user, but there is no information back from the users to the CI systems. And I think there will be value in getting this regression tracking information back to the CI systems and close the loop, so that CI systems can then use this information to create trends, to extract maybe more useful data for other reports, to keep the reports updated, hopefully presentable in the form of a web dashboard. and keeping the status all concentrated back into the data source. I think this is pretty much it. I think there's another slide. Can you, Thorsten, can you move to the next one? Okay. So yeah, RexBot provide these features, but integrating them into the source data can lead to more useful and up-to-date reports, and maybe some other more detailed information that we are missing right now because we don't have the whole story in the same place. There is some well, on the one hand, we have the basic reports, the basic data about the tests failing. On the other hand, we have the history of each regression as it progresses. But maybe if we can put all of this together, we can figure out what we are missing now. And this is pretty much it. Any comments?
Just a comment on that. Yeah, it'd be. I think it'd be really useful if the data was aggregated enough that you could see trends in both user-reported versus CI-reported bugs, and then use that to drive like maybe test generation or something.
I think that was what we were saying before. Guillaume was saying as well that we can aggregate a lot of things in KCIDB, and having all that data enable us to do the trend generation, and then from there, driving quality of the test we should be focusing on, and so on.
Yeah, just to clarify, it's not really KCIDB, but the idea is to the idea with the new implementation of kernel CI is to do the same things that KCIDB has been doing before. But yeah, so just sometimes about the namings, people get confused with what's kernel CI, what's KCIDB. I think it's important to just call it kernel CI because that's what it's aiming to do. And yes, there's a topic we want to work on called dynamic scheduling. So instead of just having a hard-coded set of tests to run all the time, the idea would be to look at what's going on and have some dynamic input data that will tell the scheduler which tests to run. So this could be based on regression. So if one part of the code breaks often, for example, and then maybe the scheduler would be running more tests there. I mean, it's ideas are endless, but yeah, that's the kind of thing that would make sense. And with more data as an input, then the scheduler would have a clearer idea of the bigger picture, and then be able to do more advanced things like that.
Any more comments?
Sometimes we find that a bug is present from oldest LTS kernel, and it is still present, but it is very difficult to reproduce that. Maybe Sysport has found that. So sometimes people just test it on some revision. They think that it was not present earlier. They report it to RegZBot. So because it was a negligence sort of that, they just reported to RegZBot, but originally they should not have reported that to RegZBot. So I'm kind of confused in that case, that it is a bug which is present in the current kernel and all LTS. Should we report that to RegZBot?
The thing is, RexBot is mainly meant for regressions. So if something is really an old bug or an old regression at some point, it basically becomes a bug. Nobody is responsible anymore or anything can't be done anymore, because reverting that change after after a year often is not possible anymore. So maybe you could add it to RexBot, and but I don't know if it would make much sense or change much at the outcome, because if the in the really old branches that doesn't happen anymore, because the one thing that also is on top of RexBot is that I'm poking maintainers when things are not fixed, and that only works if they can do something about it, and that sometimes it's just not impossible. But if in a doubt, simply add it to RexBot, it can't hurt. It's just one line in an email to edit.
Sim, you're talking about looking at regressions and driving test data, but of course that needs like a human to do that. One thing that I do is we review CVEs on every other week, and we look at static analysis and how static analysis could identify the bugs. And there's always something we can improve. Every week we're like, oh yeah, there's three bugs we could have found. Like maybe use after free, and we're like, it's supposed to have been caught, or the NTFS was getting user data, and we're like, okay, we can add that as a taint function to say that user data comes from there. But we could do that with like Syzbot and say, how come Syzbot didn't detect this? Do we have the right definitions, the right Syzbot header stuff to exercise this path, etc.
Yeah, basically, until you start mining, well, not until you start mining stuff, but mining stuff should help you actually improve your test processes, right? It's just like you're describing. It's like there's so many things that can be improved, and like when you actually start mining real regression reports, right? You can say, oh, well, that's a big area that, like you said, we should have caught.
We don't go deep. We look, my experience is you look at the first thing you can find, right? That's the most common bug. You're always going to find the most common bug first. And so whatever you see, you just say, oh, could we fix that one? Why didn't we fix that one? You don't have to look deep, but you just have to look regularly.
I think we're done, maybe early lunch. And since Torsten, he fell over the bridge, I don't know, he's not here anymore. Yeah? Yeah, that's ended.
He's off to lunch.
Yeah, he's over, yeah. Thank you.
Like grab lunch?
Yeah, great.
Yes, I was being healthy.
I am going to eat healthy also.
That's what I figure.
That's
what I figured.
I have a session after, and of all the people in my session that can't fall asleep, one of them is me.
I've got the IoT session after as well, so. Do you know Philip?
Yeah.
Anybody say much? Well, I still have my presentation, so I'm not that free.
I still have yours.
Please show up.
Which time is it? 4:30.
It's the Rust microphone.
If anybody is still around, sorry, my laptop just crashed and took everything down.
Hello, Torsten.
I hear you.
Hello, we are kind of finished already. People are leaving for lunch.
Sorry, yeah. Enjoy your lunch, and sorry for leaving so abruptly.
No worries. Yeah, we figured out we had some issue there.
Okay, good.
All right.
Thank you. Enjoy the conference.
Thank you. Thanks for the session. Bye-bye.
Bye.
perfectly stable, know how great we are. Become a report saying this, identify as fixing a problem in 6.1, please back. Is he accepting it or not? That's great, I'm no longer that sure if he's doing that. But with the security fixes, you say, no, you have to show me that this affects the branch before I apply it. So, so, I mean, it would be great if that would go automatically, half automatically into stated branches. I don't know if you send a report to like Sasha.
Trying to understand how the best part is something that we can review it sometimes. Do my sections.
Yeah, but I mean, Sasha is putting millions of patches into stable branches based on some text defines any commit without fixes tags. I mean, we only have our report only looks to fixes tags. It's not as a design factor, so that is something that is already given. And then the robot files a commit entry to carry. And then only once we do that, so we know that it compiles and does some basic testing.
You still going to replace
Over the year.
Don't keep those needed.
Those are automatically the ones that are in now 6.6 or 6.7 is the next LTS. Well, it depends. I know that it's coming to stable. But if we don't know if it's coming to stable, right now has scripts that are checking for fixes tags. So fixes or fixes. So anything that's in LTS branches usually needs to be backport fixes. What our robot does is that the stuff that we backport to other kernels also get necessary fixes. Outside state. Now for yours, I mean, there's two things. One is it would be helpful for us if somehow homogeneous branch and then with that same kind of bisection compared to mainline and see if something applies to that. Like, oh, this is missing and it's saying it's 6.1. But it's not a problem upstream, but it's missing it from the 6.1 and there's the patch that is missing. That is on top of what you're doing for LTS because we have like older kernel branches have like tens of thousands of backports from recent upstream. I know 5.4 for example has like 25,000 patches backported from data kernels. That's a lot.
Check. Nothing LTS, then we try to find the guide before it happens. So if you log in into Sigma, you will see how much parts we have those.
Probably so reasonable because we need to make sure that those are getting applied to this. If they're getting applied to LTS, fine, but we need to get this US.
Try. Barrels.
This is funny, if you can get it there, but if it doesn't, if it's not there, it doesn't happen in all
There's some FT curve or something, and the show me basically doing similar stuff. They showed some sheets with also absolutely the same development style. The construct on Seaboard is and whether it's present in any LTS branches. You need to probably these people with testing. But I don't know if you know who looks like.
I think something, we had that discussion here. I think something that I have to do is maybe not for you, but maybe it's not for you. It's awful. But yes, Oh, yeah, that's on me. Cool. Good one. Can I throw you extra battery just in case? Okay. Set up my room. I guess I'll be back to my final last
You are currently the only person in this conference.
Yeah, I still like it there a lot. We enjoy it.
That's good.
The weather's generally good, and live in the middle of nowhere.
Well, it's not the middle of nowhere. Aren't you? Where are you?
So we're north of Cabo San Lucas by an hour and a half.
Oh, hour and a half. Okay, that is the middle of nowhere. I thought you were pretty close to, what is it? San Jose is right there.
San Jose del Cabo, and that's the airport I use, but it's 45 minutes south of us.
Oh, okay.
I mean, that's the airport you used when you went to Cabo, right?
Yeah.
Right. I mean, that's really. I mean, it's not the only way, but it's the main way to get into Cabo. So yeah, so you know, I live on the end of a dead end road. And it's pretty quiet.
That's good stuff.
Yeah.
Oops, wrong
You're
thing.
all recovered from your health scare.
I'm on my way.
Okay.
So, yeah.
Glad to hear that came out
I was.
as
It
well
was.
as it did.
It was. It could have gone a different way.
Yeah.
I was at the very top of a mountain in Utah,
That's what I heard.
and got life flighted out. Had an ATV with EMTs come up. Took them a while to get there, but the helicopter came. So it was fun stuff. And, yeah, well, it was. I mean, fun is not the right word, but interesting.
Yeah.
Super interesting. So I have a new appreciation for first responders.
You tip those guys?
Well, so a couple weeks later, you know, I got out of the hospital and stuff. I took these fancy cookies over to the search and rescue people who came up, and I said, I know you guys just saved my life, but here's some cookies.
You're probably pretty appreciative.
Yeah. So doesn't seem like a fair trade, but you know, it's something. So yeah. No,
Always remember, this game is not fair.
Yeah, this game is not fair. No, I'm not.
You run a game in every conference you go to.
I should start doing a game.
Have you ever won it?
Oh yeah, he's been so long.
Many times.
Yes.
I almost won an LWN subscription.
we still have stick review of hot sauce for no good reason. all require hot sauce. Last refreshments.
There we go. What is this doing down there?
Home sweet home.
Home sweet home. Brings back memories. This slide deck has not changed in 15 years.
Wow.
Well, I mean, the content has, but it's got a new background. I actually have this year's background. But yeah, once you get a formula, you got to stick with it.
Yeah. So there's a sort of state of the union of the embedded Linux.
No, this is not my status talk. Although with slides copiously borrowed from. If you can't steal from yourself, who can you steal from?
Yeah.
I don't even know. Sarah, we should get a. Okay, we got 10 minutes.
Is that an audio resume? Yeah.
Oh, okay. Now I got it.
Watch out on those. Nothing special about it. It's quotable, I guess, maybe. No, I'm just saying I have to watch out what I say.
Chances are
Well, I mean,
slim.
it's on video and shit. I mean, come on.
Well, I don't know. Sometimes sometimes the videos, don't catch everything.
Well, okay. I mean, but
That's right.
So I guess if you're whispering into my audio device, I can't be held responsible.
Yes.
I mean, they're gonna put out videos of this thing.
Yeah, but unless the box is here,
They're going up live to YouTube.
Right.
So I mean, it's like this is more current than a SpaceX launch.
What do your buddies at SpaceX say about that?
That SpaceX is not doing YouTube anymore. Yes, only available on X.
I
What's the X in their name?
Yeah. I don't know. I still call them Twitter.
So do I.
No,
I'm gonna
it's
start
like
calling them Space Twitter just to get back to that.
I don't have $1 billion, so what do I know?
Yeah.
But I would not have thrown that branding away
Twitter? Yeah.
or diluted the branding or whatever you want to call it.
So I'm not sure that having $1 billion is any real indication of intellect.
Well, it's at least economic.
No, there's not a lot of luck.
Well, there's luck. Yeah, there's definitely luck. But there's also,
I'll give him the benefit of the doubt of having taken just a no-name company to
oh yeah,
SpaceX.
Well, the fact he's taken at least his two largest, right? SpaceX and Tesla.
No, get lost.
This is small.
Well, we don't need to get into it.
It's only for them.
So
my personal experience is that almost everyone who's got to be a billionaire has done some unsavory things.
Yeah.
Ethically questionable.
But the thing
Why almost?
Well, I don't know.
How many do you know?
I knew one person.
Okay.
And he seemed like a really good guy. I think he was, for the most part, a really good guy. But then I heard some stories. It's like, yep. In order to get there, you got to step on a few people.
Yeah. Buying it is commenting on your own forum.
Oh.
Okay, if you're hosting a forum, host it for other people. Just don't comment on it.
No, I don't think
that's his whole life. It was before he bought.
He was the number one. He was the number one. He had more tweets than any other person on the planet when he bought Twitter. I mean, it was like
It's existential.
It's existential. Again, we should not make this. Let's.
So this is not the Twitter box.
What? This is not. Yeah.
Was it here X or X11?
What?
Is it the Xbox or the X11?
I don't know what time it is. Is there a clock on this thing? Oh, we still got plenty of time.
My only question is, would you actually
On this thing.
Hey, what brand is that?
This is Sony.
Oh, all right. That's got Linux in it.
No,
in fact, I probably worked on that. I'm not kidding.
Really?
Yeah. I was in the camera department for a while, and I don't think they've changed that.
I was taking pictures of, I think it's Richard Hipp from, embedded database, that everyone uses.
Oh, yeah.
Yeah, you had plumbers, and I'm taking pictures with this, and he goes, and that has.
The SQLite?
SQLite, yeah, and that has SQLite.
Oh, yeah.
And I have a picture of this finger like practically.
Yeah. I don't know. It might not have, because how old is the camera?
It's, probably 4 years old at this point.
Yeah, I don't know. I have to go and look at.
I didn't.
I got a recent actually, Sony.
Yeah, more recent is less likely it's got my code in it.
Oh.
And then like I don't think I did anything with the alpha, but the point and clicks I did.
Oh, okay. Is it upstream?
What?
Is it upstream?
I got a couple things upstream, not a lot, not as much as I should have.
Oh yeah, I just got one of those.
Okay, yeah, the alphas. I don't know what's in them. It's different cameras.
Oh, no alpha. I thought I could slack you next time my webcam doesn't work.
Well, my name wouldn't be in there. So yeah, so what I did, I was working on Linux Tiny. So my big claim to fame was all of the code that's not in the camera. which there's a lot of code that's not in the camera that I was responsible for.
Now you jumped right into the topic. Linux Tiny.
Yeah.
I haven't heard that term in a while.
Yeah. Yes. That's
Sort of fell by the wayside a bit.
Yeah,
Where's the pen?
I don't want to have the BoF before the BoF. There's a lot of stuff I could say about it. No, so in the early days, when I first got to Sony, the camera team came to us and said, we want to put Linux in this camera. It's got like 16 gig of RAM, and your budget for the kernel is 10 meg. It's like, you mean, like, that's not very much. And we said, oh, that's, by the way, that's not just the kernel, that's the whole Linux distribution. And we pulled it off. But with virtual memory. So we actually had, because they were so stingy with our RAM budget, we were actually running apps and swapping into the other RAM.
Okay.
Stupid.
I thought you said the SD card.
No, not swapping the SD card. We were swapping.
Camera is nice, a bit sluggish.
Yeah, no, they let us swap, and we were watching our working set like crazy.
What year roughly?
Oh, this goes back to 2005, 2006. They have much more lenient budgets nowadays. Okay, so just FYI, I have not played around a whole lot with BBB, but it turns out it has this really neat polling feature. So I'm going to do some polls, or I'm going to attempt to do some polls. If you want to participate on the online poll, you can get into the session on your laptop. Although I'll also scan the room, but it'll be kind of neater if I can like show your results on screen. So if you want to, you're welcome to get into the BBB session, but please, just to curb traffic, since you're here in person, join with the listen only mode or whatever. So apparently the audio connections take up a fair amount of bandwidth, but you don't have to. I'm just going to ask people questions and see what they say.
You're gonna price it like the
No, there's no price. Well, what is this? Mule size. Wait, no. The Osco Project stickers.
We have
There's a certain level. You gotta be careful what you leave lying around. Oh, there's all right.
Now we're getting serious.
That's great.
You don't want to take a help.
Now you got me thinking of some game.
Rock, paper, scissors, shoot.
Rock, paper, scissors. Classic. Okay, let's see here.
You didn't bring your costume.
I don't have a costume.
Still already the best both of you.
I've already. Yeah, you would not believe how much work goes into that costume. Much more than in my like regular presentation. So I already have some ideas for next April. Okay, so it's still not time yet according to this. Actually, I'll give it another.
This sounds like a Motley Crue opening.
Okay, I'll this on. Okay, I'm not seeing the. Oh, those are showing up. Okay. Welcome everybody to the Embedded Linux Birds of a Feather session. I noticed this morning that other people like run these BoFs without any slides at all, and of course. In true spirit, I've got like 45 slides, but we're not going to go through all of them. Some of them are there for just reference. Some of them I just borrowed out of my status talk. But the main thing is that most of them I just have several different areas in case those discussion topics come up. We can go to a slide and have something. So this is kind of the high level outline. There are different technology areas that you might be interested in for embedded. There's obviously we're here talking about the Linux kernel. There's some high level issues, and I think it's worth talking about the embedded Linux community, and then just open discussions on whatever topics we think are the most important. So this is the historical embedded Linux focus areas. System size, boot time, power management, real-time security. So we actually an audio video drivers, flash file systems, and then support for SoCs and boards, which is essentially infinite, right? You will have that Arch support and drivers. You'll have that with you always. So this was a list that we put together in 2003, and luckily we finished this and moved on to these. Architectures, bootloaders, boot time. And this is not comprehensive. File systems, networking, security, testing, tools, tool chains, tracing, system size, build tools, and distros. So this is just kind of off the top of my head because there's much more you can have in here. I realized I didn't have over-the-air updates or anything like that. So, but I do. Here's my first poll. Okay, so, and I'm going to poll online and in the room. And please tell me, what embedded Linux technology area are you most interested in? I'm sorry if that's hard to read. Is that architectures, bootloaders?
Jade's not on the list.
Oh, is Jade not on the list? Oh, does it?
I can't vote.
Build tools.
H is on the list.
H is there. Yeah.
Z.
We've got one remote vote for system size. Oh, it's coming in.
Did you the ones comment there?
Oh, what?
Yeah,
No.
I'm sorry, video drivers need to be added back. There are many challenges left there too.
Oh, well. Okay, yeah, you're right. Okay, let me jot notes. Oh, by the way. Oh, hey, look at that. We could, if someone would be willing to, if there's a good point made, please just put a comment into the chat, matrix chat. I don't know who has it open or if anyone has it open. I don't want to, as the speaker, be adding stuff to matrix chat, but otherwise I'll have to write stuff down, which is kind of awkward. Okay, so let's show you what the slide. I'm going to close the slide, and oh, I didn't pull the room. Okay, really quick, show of hands. Oh, that'll allow you to vote twice. Okay, architectures. Okay, well, orange, yeah. Okay,
Not surprised.
about 6. Bootloaders. Okay, 4. Boot time. Okay. Oh. File systems. Yeah, nobody cares anymore. Networking. Networking. Oh yeah, nobody cares about networking. That's good. Okay, security.
Can we add safety to that?
Okay, that's 4 in the room. Testing. Okay, my hand goes up for testing. Tracing. Oh, not that much. System size. Oh, a couple of people. Okay, I thought system size was dead as a.
Most interested. It's most interested.
Yeah, most interested. And then build tools and distros. Oh, okay. That's actually pretty high. Okay, so here's the poll results.
Our management is done already too.
Oh, power management. Oh, here's the thing though. Power management seems to be doing okay by itself, right? So there's, I mean, I don't know. There's a ton of people working on power management, aren't there? Yeah. Okay, so a lot of people too were interested in testing. Okay, so I think based on that, I think we want to talk about, I think we'll talk a little bit about boot time and system size and testing and build systems. Size, testing, and then build. And then one of the things I want to, I want to make sure I leave room at the end to talk about just kind of the ecosystem and the community. Okay, so let's move on from that. Okay, so I'm going to skip over some stuff. So bootloaders, U-boot. One of the interesting things that happened with U-boot is you can now support loading images over HTTP. Bootland did this kind of neat thing called snag boot, but I'm not going to dwell on that. The latest thing I've seen in terms of kind of upstream work is 2 things. So, and one of them I didn't put in the slides because I did these before that happened. But so you got the resurrection of You Read Ahead by Steve Rostedt, and he's now at Google working on, I think, Chromebooks. And so that's pretty interesting. But I guess my question for the audience and for everyone is, okay, so what else is going on in boot time reduction in the kernel? Anybody know everything? Oh, the other thing, before I open it up, the other thing is Kasim from TI had a presentation here at Plumbers talking about automotive, about early access to hardware, right? And everybody knows the classic example you give for a boot time, like kind of a hard requirement, is you got to get the backup camera on as soon as you turn the key, right? You can't wait 10 seconds or something. But he had a really good example of all the other stuff you got to get on, like the CAN bus has to come on within 100 milliseconds, I think it was, stuff like that. So, and his proposal, I'm going to summarize it poorly, was basically the way that this gets solved is because we can't do it in Linux. We have MCUs that are. What? Oh, see, I can't see the. Oh, C cap. Okay, I gotta get my matrix chat up. Okay, so I can see. Oh, there you go. Yeah, so basically, I think the proposal was to have Linux communicate in a more standardized fashion with the MCUs that are really bringing the hardware up, which seems like that's not really making Linux fast enough to do the chore, right? But I think it's about as well as we can do right now, unless we do some hardcore stuff. So here's my philosophy. Okay, so first, anybody else have ideas about how to improve boot time for Linux? Right. So the other thing that was in Kasim's presentation was he talked about you got to get rid of the bootloader. You got to get a custom bootloader so you're not initializing every device twice. You're initializing it for U-boot, and then you come into the kernel and you initialize it again for the kernel. And so there's a lot of overhead there. It seemed like back when I was like really focused on boot time at Sony, we were doing pretty extreme things like XIP on the kernel images. So we could cut out that, I think it was 200 milliseconds to copy the image into RAM. And so, but my understanding is, I haven't done that for years. My understanding is the XIP is dead in the upstream kernel. Does anybody know if that's true? Anybody used XIP lately? That's what I thought.
We made it easier to use on ARM recently.
What? Sorry?
We made it easier to use it.
Sorry. Yeah.
So we did some work to make it possible on ARM to have it in multi-platform kernels again, which used to not be possible. So now you can actually do it on ARMv7 kernel on any target. I don't think anybody's doing it.
Right.
The Renesas folks have one chip with very limited memory, like 10 megabytes, that needs it. I don't know anybody else.
Okay. Another interesting thing that, oh, go ahead. Oh.
It's more a question than a suggestion. That the people here in the room think that asynchronous probing is exploited as much as it could be?
No, I don't.
So I think there's still potential, but it needs a lot of careful, research or checking for regressions and all that.
Yeah.
But yeah, I see patches around where people try to do that.
Yeah, and kind of related to asynchronous probe is actually making more and more stuff actually modular, so it doesn't actually have to load right away. The important stuff can load right away.
Right. So one of the tricks we did on Sony cameras was we built the USB code as a module, and then we would come up so we could get the camera screen on, and we could actually start messing with the camera hardware because we wanted to autofocus as fast as possible. And then we actually loaded USB as a module like later on in the boot cycle. So it didn't actually come up. It wasn't statically linked in the kernel, and it came up later. So I think there is a lot of that kind of tweaking of your boot steps and the modularity like you're talking about.
And then one other comment slightly related is more like not doing cold boot, essentially coming out of a more of a low power state instead of actually a cold boot.
Yeah.
That's an approach that many have taken too.
Yeah. Well, yeah, like this never turns off, right? Never really. And when I power it down, but like in its state right now, it looks like it's off to end users. Well, except that it comes off with a splash screen.
Yeah, so actually, I'm interested in that, but from the user space angle, so Android,
it
takes forever to boot, right?
Oh,
so
yeah.
One of the things that was being asked at the suspend and resume thing is whether Hibernate's interest is still of interest. And I was like, that'd be interesting for Android, because if you can dehibernate something that's in Flash, so to speak, that would be much faster than trying to cold boot Android from scratch. Like, for example, especially in cars, as you were just saying.
Oh, yeah. So another idea that we played with a long time ago, I don't know, and async probe, yeah, why isn't async probe used more often? Is one of the questions I have, because it didn't exist when I was doing some of the stuff at Sony, but it does now. My impression when it was first added to the kernel is that people were really worried that the dependencies wouldn't come out right. You have a certain init call sequence that happens, and if you change that sequence up, you may end up with problems. Hardware doesn't come up the way you expected or something.
Well, weren't you artificially doing that with the USB thing that you were doing later on?
Well, but that was a big chunk that we knew. And USB is not like at the bottom of the dependency tree, right? These days you have, a device tree has a fairly complex dependency tree for what things have to come up first, right? You got to get your PMIC up, you got to, your power domains start coming up, then your clocks, and so there's a whole series of events that you really can't reorder, or you got to be careful if you reorder it.
Laurent also says device links also help reducing boot time by lowering the number of deferred probes.
Yeah. 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 No, that's really good.
I don't see Saravana in the room, so I guess I'll say it for him. But I was going to say the same thing. All the DevLink stuff that's been happening because of the Android GKI work for the fully modular kernels, that includes modular clocks, pin controls, regulators, all that kind of stuff.
Okay.
That's helping in this direction as well.
Okay. So another thing that Kasim had in his talk was actually, I can't remember exactly how he. I'll mess up the wording of it.
He's here.
Oh, he's here. No, so what was the thing? Yeah, give him. I'm going to ask him a direct question. There was something about you split the probe. What was the
System
device?
D
You split
in
the
the
probe
network.
and had a portion that ran early and something ran later. What device was that?
On AM62, like TI's AM62 device.
Okay.
So that is mainly on the networking side of thing. Like if you want to get your network.
Oh yeah, it was the Mac.
Up,
it was the PHY on the Mac.
Yeah, PHY on the Mac. So you move the filing portion into probe, and then instead of system D.
Okay. Yeah. So I mean, you can, if you really, really know what you're doing, right? You can get more aggressive. I think the problem was that there was some Mac setup time that was taking 1300 or 1.3 milliseconds or 1300
we got like
milliseconds.
around 2.5 milliseconds, 2.5 seconds.
2.5 seconds.
Yeah.
So sometimes, but like deferred probing is really important. One of the other tricks that we used to do at Sony was we really tried to thread some of the stuff because there are just hard-coded delays in the specs for things like one of them, this is old, but like the hard drive controller, right? You had to kick it, and then if you sat there and pulled on it, you wouldn't get. You had to wait for it like at least a second or something. But if you could kick it and then go do some other stuff and come back to it, and that's kind of more async probing type stuff. Okay, okay. Here's another poll. Let's see here. Is there? Oh, another comment.
Yeah, Tim.
I think there's still lots of room for improvement because in probing there's too many devices, power-up devices that probe time.
You need a microphone.
Way too much time when I'm supposed to.
Yeah.
So Tim, I just want to correct a misconception. It's not resurrection. Chrome OS has been using URead ahead ever since they started in 2009.
Oh, really?
In fact, my starter project on the Chrome OS team was to improve the boot time for networking.
Oh, okay.
And it included URead ahead. We also preload drivers to help faster, so we don't load them from storage when they're demanded.
Oh, okay. Oh, that's great. So, okay. Can you read that since you got the mic?
Samuel said, yes, moving more device power-up code into runtime PM. And then Laurent added, there are also devices that take a huge amount of time due to firmware loading. I recently came across a camera that takes 8 seconds to power up, and you don't want to do that in RPM every time the camera is used.
That's really interesting. Yeah, that's true. Actually, didn't you talk about this also, that firmware, if you can offload the firmware loading to something else besides the main CPU or something? So, okay, so there's a ton of techniques. And I just want to comment on why embedded Linux is so hard. So, because this seems like a good place to interject it. It's there's a lot of techniques that you can use, but boot time and system size and to some degree power management are all these areas where it's death by 1,000 cuts, right? If you go in and you try to fix something, you can't just find one area where you're going to shave, like 3 seconds off. Well, I don't know, maybe. Oh, sorry. Can you repeat that with the
No,
the
sir.
mic?
I didn't get it.
So you said power management and other things, right? Along with this, you should also add security to this. Like when you are
Oh,
booting
yeah.
the device, you have to authenticate every firmware that is coming up, and
Right.
that authentication takes a lot of time.
Right.
So that's another problem which affects boot time.
Yeah. Oh, okay. And Laurent says, oh, yeah, go ahead, Laurent.
No, I think that has been read already in the chat. Just thought I would join by webcam and microphone because I'm typing too much.
Okay. That works for me. Okay. Yeah. So embedded Linux is hard because there's a paradox when doing embedded work in open source, right? Is open source is about finding commonalities and generalizing the software to cover as many use cases as you can. And a lot of embedded work is customizing the software, right? Especially in the areas where you're trying to reduce boot up time, you're trying to reduce the system size, you're trying to cut the power management, you're trying to address security concerns. You have you actually do what I call subtractive engineering, right? Where you go through and you're ripping stuff out, or you're shortening code paths, or you're customizing it for your exact platform. And that's the opposite of open source, right? And so it makes it really hard to share. And there's an ecosystem problem. It's really hard to share a lot of our solutions. Come up with a, like you know, like how do you there is like a tiny configuration for the kernel, but like I don't think anybody uses it in products because because your product has to have the features you need, right? And they're all different. So anyway, that's just a problem statement in general. So I've got my next slide here is a poll. Okay, and this is what tool do you use to measure boot time? If you're doing boot time work, are you using a stopwatch, a logic probe, print K times, boot chart, kernel function tracing, or something else? Okay. Okay, is it all of the above? Okay, it's all of the above. Okay, I'm not even going to run the poll then. So, because we're running out of time anyway. So, okay, so the other area we want to talk about, let's talk, I have file system poll. I think we don't need this file system. Oh, okay. Joseph Holzmeyer says, gee, customer complaints, fast enough. If the customer complains, it's not fast enough. Okay, I assume that a lot of people are not using MTD devices anymore. Yeah.
Who's using MTD?
Anybody using MTD?
My customers, unfortunately.
Really? So what file systems are you running? Okay, the answer is UBFS. Okay. So none of the other ones are hanging around like LogFS or some of these other ones. I'm surprised F2FS is not used more, but maybe that's the... Okay, I'm gonna skip real time because. Okay, so system size. Okay, this just kind of chaps my hides. Did you see that slab is going to get removed? There are patches on the mailing list right now to remove the slab memory allocator. Okay, so it was sad enough when they removed slob with only like a 2 version window between deprecation and it's gone. And it's like, how are embedded people supposed to notice this? We're like 3 years behind on our kernel. And already, but so did anybody, is it, oh. Yeah. Oops. Go ahead.
So my feeling is that we are in a big trend where even 32-bit is getting less and less used. So the system size, like who has used 32-bit embedded systems in the last year? That's thank you. That was almost everybody.
Read the room.
Right. No, I'm a big. Yes.
Who of the people
is not even gone to 64 bits yet. Okay, so no Raspi users in the room because, I mean, seriously, Raspbians just sorted out their 64-bit support a couple of months ago.
The thing that I found is that out of the few platforms that do not have a 64-bit SoC, most of them just converted to Cortex-A35 just in the last year. So we are getting there. Like, obviously, you all have old products that you're still supporting. So those are still 32-bit, and that will continue for another 10 years or so, at least, or 15 or 20. Yeah. But for new stuff, there's a huge trend to move away from 32-bit and a huge trend to move away from DDR2 and DDR3 towards LPDDR4, which means system size is much less of a concern. And those people that do care about system size are moving away from Linux.
Well, they are. I mean, so there's a whole IoT track going on parallel to this. That's all Zephyr, right?
So it's just yes. So you can.
I just finished the work. I tried to work on running the 32-bit ILP32 data type on the RISC-V 64-bit ISA because our customers, they are all traditionally 32-bit ISA users, and they constantly use the ILP32. And when we introduce our processor is based on the 64-bit ISA, but they still ask me, please let me use the ILP32. So I do the job to let Linux kernel build in the ILP32. That's maybe the first time Linux kernel built in 64 ILP32 ABI. Yeah.
So what's
so
the smallest memory configuration that you support with that? How much? What's the smallest memory?
64 megabytes. Yeah,
64?
Yeah, 64 megabytes. That depends on the manufacturer because currently when you ship a chip with the DDR2 is the 64 megabytes and the DDR3 maybe is 128 megabytes. That's very popular.
Right.
That's a lot of chips. This kind of
that is actually a dynamic in the industry that drives the system size requirements, right? Is because as the cheapest memory you can gets bigger, right? Then you're not even gonna put smaller parts on your device, right? No one's gonna put a 16 meg chip on their device when the 128 meg chip is the cheaper one for consumer devices. Now there are other things, but the stuff that like is SRAM based, and you have to go all the way down to like 2 meg before it.
And I think we pretty much lost that part.
Yeah,
So-
I think we've lost it. Yeah. Oh yeah, there's some good comments here. So Philip says we use System Tap in the past to improve boot time. Okay. Oh, okay, that's good. Another tool there. And then Ira asks, how many 32-bit users are using more than 4 gig of memory? Okay, so
I know some that are doing it, and we want to eventually remove support for that from ARM32.
Oh, really?
Yes.
Oh, okay.
Yes, we want to remove high memory, but we don't want to remove support. Like we want to keep support for 4 gigabyte, not just limited to 2, which is the low memory limit.
Yeah, and that's what's the reason I want to running the ILP32 on the 64-bit ISA, because if the user start with the 64-bit ISA, he didn't worry about the memory problem because he could easily change their kernel to the 64-bit kernel. And keep their user space still stay in the 32-bit, and maybe in the future he can easily to change it to the 32-bit to the 64-bit. They can mix them together in our job. So so that's give them a chance smoothly upgrade their products from the 32-bit to the 62-bit. So I think ILP32 still is necessary. But for the 62-bit ISA, maybe it's would go away because we found the 64-bit hardware is equal to the 62-bit ISA in the in the cost in the PPA. Yeah. So we didn't find any PPA advance if we reduce the general purpose register width into the 32-bit. So that's we focus on the 64-bit ISA, but we still want to provide a 32-bit solution to us.
Yeah. Okay. Yeah. Thank you. Okay. So we're running low on time, so I'm going to have to move on from system size. I had a poll here, but anyway. Oh, one thing I thought I'm going to just throw a little plug in here. So there's been a whole bunch of work on NoLibC recently. I don't know if you know what NoLibC is, but it was made for, I think it was originally developed for testing stuff. It's, you basically replace libc with a bunch of kernel headers that map stuff directly into syscalls instead of going through a C library. So it's, and you can actually get very, very small apps. It was written for writing low footprint testing applications, but I'm really curious if anyone has actually like used this to generate a system. I think it's pretty new. But anyway, anyone used NoLibC? You used it?
My friend. My friend working on the NoLibC is called Wu Zhangning. He set a lot of patches to optimize the NoLibC.
Okay.
And he want to create, and I have we have the same concept in this. That means we have the same concept that Linux could work for the tiny memory.
Yeah.
Devices. We don't want to move to the Zephyr. We don't want to move to other RTOS. We just stay in the Linux because the Linux provide very sufficient drivers and drivers is there. So why you need to port into other RTOS? That's waste time.
As long as you got 32 meg of RAM, then you're okay. But I don't think we go below that.
Yeah, so his work on NoLibC is to make the Linux code run very tiny.
Yeah, this is
memory.
And this is user space stuff. So, okay, so let's see. I had a NoLibC poll. Builds and distros. Okay. Yocto project. What?
The release already came out.
Oh, and there's a new release. See. This is what I get for stealing slides from my instead of researching. So I don't know. What is there to say about Yocto project? Anyone get
world domination?
World domination. Okay, there's a comment back there.
So we had a lengthy discussion with Dennis yesterday. Like, why doesn't Yocto project have LTS Yocto with LTS kernel every year?
The answer was resources. Yeah, actually, that is something that I think came up at ELC. We talked about that. And in fact, it's on one of my later slides here. We may not get to it, but there is sometimes inadequate investment in infrastructure in the embedded Linux ecosystem.
It hurts many, right? Like we have to give LTS migration every year. We move kernel, but Yocto doesn't match, and we move Yocto, kernel doesn't match. So there is always customers are in a dilemma which one to pick, whether pick latest LTS kernel or latest LTS Yocto, and it's a difficult thing. I know your answer.
I know your answer.
Yeah, so we have a paid contractor, LTS maintainer. So we can only afford to do LTS every 2 years. So TI should actually step up Yocto project membership back to platinum.
So are we short
So
of
there's
one engineer then?
There was a comment up here if you want to throw the mic.
How does it take to get there? One engineer, you're asking?
I don't know the answer. One maintainer.
Probably 1/2 maintainers. It depends on how much actually maintenance you're going to do. But yeah, I mean, it does not only apply to the kernel. It applies to about everything. We hear it all the time. And as Dennis just said, it's always resources. Look at our members list and imagine how many devices alone in this room are running Yocto. And everybody go out, please throw money, because this is the only way you can get a sustainable environment. That's it.
Throw money or personnel.
The big difference is
gonna move on.
having an upstream repository of something working and having it integrated, working and testing in Yocto. That's a massive difference. Look at Chromium. Chromium is in an upstream repository and working. Having it on a Yocto-powered device is like the massive pain in the ass. I am entitled to say that because I'm not an American. Thank you.
Okay. Okay. Real quick. Well, I don't know. Just put it down there.
Okay.
I wanted to. I was going to have you throw it to me, but that makes no sense because I got a mic. Let's see where to go from here. I'm sorry, but in the interest of time, I'm skipping testing. I know testing is a huge. It's like, well, okay. So, well, we're not even gonna have time. We'll come back to testing and during discussions. Okay, two things. Two things I want to cover real quick before we get to open discussion. One, we had something that I called the Embedded Linux Leadership Summit at ELC or EOS in June. And we went around the room and talked about, well, what are some of the big concerns? And this was the list. This is a very short summary of the list of things that people came up with. You notice that not enough contributions to investment in infrastructure is on there. Heterogeneous core support. So a lot of our designs have heterogeneous cores. And actually, you could argue that the MCU issue that TI raised earlier this week is exactly that, is how to talk to stuff off the main CPUs. But some other interesting ones are upstream AI and machine learning accelerators. I don't know who's running into that, but we've got a lot of real, for lack of a better word, funky hardware coming down the pipe. AI accelerators that it would be good if there was a common way to communicate with those or drive those. I don't know. So I'm not looking for any answers here, but this is, if you see something on this list that kind of resonates with you, let me know. This is kind of what the top people think are some of the big issues.
Does Grim want to talk about AOSP? What can I say?
Okay.
Shall I pass it over?
If I may add one point to that list, a bit related to AI.
Go ahead, Laurent.
Okay, I wasn't sure if people could hear me. The AI and ML accelerators, that's something that we've been looking at also related to cameras, because people want to consume camera streams and process them with that. And we also have lots of issues on the camera side with lots of systems, not just embedded system, but going to desktop systems also, going for embedded ISPs inside the SoC with lots of hardware differences, different way to communicate with them, lack of documentation. I mean, the usual story. So this is the whole ecosystem around cameras and AI is actually problematic. There are people moving forward with that, but I do agree that it's one big issue.
Yeah. Reem, do you want to say something about Android or AOSP?
It's hard to sort of summarize everything, but essentially one of the benefits people get out of using Android is the standardized API. You get in there, Google's done the homework, they got an API, you get Joe app developer off the street, they know how to code for your system, which is something in the embedded Linux world where you're specing your own libraries and choosing what you want and sort of educating people to use your system. It's not a bad thing. It's just that's what one of the benefits that people tell me they get out of AOSP is, hey, somebody else is in my homework.
Right. Well, and Google continues to pour a lot of resources into it.
That's true.
I have a question. This embedded Linux leadership, does it mean like leading producers of embedded Linux devices, or does it mean leaders of projects
This
offering
was,
the service?
This was a group of people I could round up at ELC. but we had
Because
okay, so I can tell you who was there. So we had some representatives of some of the major consulting companies. We had Bay Libre there. We had Bootlin there. We had Lenaro there. We had ARM. We had Amazon. No, was it Amazon or Meta? AWS was. It was a cigar. Yeah, I called it the cabal meeting, but anyway. No, but I mean, we tried to get processor vendors and consultants, but I don't know.
Because it seems to me some of them could help with the lack of investment in infrastructure tools and upstreaming.
Well, yes, yes, that's true. Okay, moving right along. Unfortunately, there's one other thing I want to cover real quick, and it's under the topic of community. So I think that we don't have a strong enough community. I think we have a community, and there's a lot of us that know each other, but and there's a lot of projects. So there are some embedded Linux mailing lists, but okay, let's face the music. These go largely unused. And one of the reasons that, like, for instance, the Linux embedded list goes unused is because you'll never get that recommended from Git maintainer, because embedded Linux is not something you can put a file wildcard on in the kernel source tree. So so you have to know to use it. And anyway, so I don't know if anyone has a suggestion for how to fix that.
I know.
What?
Machine learning.
Oh, machine learning. Oh, okay. Oh, that's actually interesting. Oh, I just attended a session on RegZBot, which is this thing that just monitors the email list and then occasionally will throw something out.
We need a Discord server.
Discord server. Okay. So the other thing is, okay, so there's no end of organizations and projects. You got Lenaro, Linux Foundation, which has a ton of different projects. ROS, AOSP, Yocto project, Buildroot, OpenWRT for build systems. Here's just the Linux Foundation projects, right? So we've got CIP, ELISA, OpenChain, SPDX, automotive grade Linux, kernel CI, Yocto project, drone code. The core embedded Linux project, okay, which ostensibly should be managing this thing, is actually shutting down. So the companies that were involved with that have declared victory. And but what that means is, and then we have our events, and I think we're actually doing pretty good with events. I'm not going to dwell on that one. This is some of the ones coming up. Either just recently we had embedded recipes in Paris recently, and then we got plumbers here, FOSDEM. There are regional events. One of the things I really want to talk about real quick is eLinux Wiki. So eLinux Wiki, I know it's got a ton of old information on it, but it's still useful. If you go out and look up, there's information on boot time reduction out there, the tools you can use and some of the techniques. It's kind of uneven. It hasn't been well maintained. So, and it's about to lose its funding. So we're looking for people willing to help out. So if you have an interest in this, the best thing is to get on the eLinux wiki-dev email list, or just send me an email. I said at Embedded Linux Conference that I was going to try and put together kind of a committee to work on this, and I didn't get to it because I had some things in my personal life that interfered with my plans. But I still am really interested in this. I think this could be a great resource for us. I know wikis are not the best thing in the world, but it's it is a place to store information that we can share amongst ourselves, right? It's persistent, and we've got the funding. If you want to fund it, we can do that as well. Laurent, do you have something you want to add? Okay.
What's the funding used for
What?
What does the funding cover for eLinux Wiki?
Right now, okay, so we are paying for an administrator to keep the spam off of it. So it's not a lot of money. I have one company who said that they might be willing to cough up I mean, I'm looking for probably, I think I can keep it alive, the administrator, for like 6,000 a year, which is not a lot of money. So if I could get like 2 or 3 companies paying $2K a piece, and it also hosts a whole bunch of board data. So like if you go out there and you look at, there's all kinds of, so it's a good resource. And so if you think your company might be willing to do something like that, it's low budget. We used to pay more for it. Anyway, comment?
Something you glossed over really quickly that I don't know if everybody's aware of, but ELC, the whole rotating of ELC, it's only once a year in Europe and once a year in North America.
Yes.
And that, to me, is an opportunity to actually do some more of these smaller regional events. I mean, Embedded Recipes being one, FOSDEM, but like it's an opportunity to cultivate smaller regional events as well. So I think that should be, I just wanted to, you went over it quickly. I just wanted to repeat it.
And we don't have time to cover everything.
And yes, speaking of events, can we get CLF back, please?
Yeah, actually, someone, probably someone in this room, but someone said that the events at the Kabuki were some of the most fun. I mean, so anyway, if you go back that far. Okay, so now with the 1 minute we have left, we can talk. Let's see. We can have open discussions. So, what is the kernel lacking? What is your opinion? What is missing for embedded Linux? Well, okay. Besides getting all of the processor vendors upstream. Besides that one, which we all know.
I mean, it's what are the kernels?
What?
These plural kernels.
Oh, did I say kernel?
No.
Oh.
It needs to say kernels.
Yeah.
Why?
Because there's so many kernels.
Oh, we should be using that. Okay, Mike, right there.
I'd say more maintainers who guide the developers to go into proper directions.
Okay.
One of the topics that got discussed widely here is also the overall power management structure, where we have so many different cores in our SoCs and so many low power modes that we need to be able to take decisions from Linux, how we can enter different modes.
Yeah. Okay, so some of the other questions I got on here while you're throwing that. Yeah, well,
yeah, on the
they're
topic
kind of the same question. What do you think is missing?
maintainers, if I may add to what Wolfram said, what I've noticed is that we have an increasing number of contributors from SoC vendors, which is really good, but who are mostly focused on solving the immediate issue without looking at a big picture. And that's really drowning us as maintainers to keep things afloat. And I think that's becoming an increasingly big problem.
And I think you have the last comment because we're right at the.
I know there's documentation, but there's no documented design. So it makes testability really hard. We don't have a design to test against. So.
Okay. Wish we had. Let's have some hallway conversations while we still have a little bit of time. But there's I think there's a lot of things we could do to build a stronger embedded Linux community and ecosystem, and there's plenty of technical work left. So, thanks.
You were in the presentation and you were talking about EFI environments. So I want to throw the
Throw money.
A lot of 32-bit use still. Sucks for time. Right? It's always good chocolate from Mars. Probably most of it.
I was gonna say, you're thinking the exact same thing I was thinking.
What's that?
With the eLinux thing. Yeah. Okay.
Yeah, no, I was. If it was hosting, it's like shit. I can help with that.
Oh yeah, no, that is trivially solvable.
Face I haven't seen in a long time.
Hey, how's it going?
You still can't see his face.
I just imagine he turned whiter than he always.
I was gonna say, my son's been making fun of me. He's like, Dad, you have a lot of gray hairs.
You staying for this one?
Yeah.
What's next?
What's
the most important two sessions in this conference?
That was this one.
The most two important ones right now.
Rescue
and
one?
after this one.
The rescue one? No, the whiskey one.
No, I don't know.
bad.
I don't know. I don't know what it is.
This one is PCI device.
Yeah. I mean, it's interesting, but I'm gonna away from it.
The next one's most important. That's securized.
Oh, okay, that one's actually.
Just my work.
I'm gonna sneak off.
I'm gonna grab a copy.
Yeah. Oh.
Anyway, I was gonna take it off the back, but you need it, so I completely failed to do it. I mean, I can drive it. Oh, someone else is getting it. And then now we take it.
Oh, is he taking it? Maybe
Oh, maybe it has. Hey, Lucas, if you can hear us, just grab it again. We clicked the wrong button.
Lucas should have, if he's listed as a speaker, he should have the ability to take presenter.
Okay.
Yeah, he's got it. Cool.
Sure.
Lucas, if we wait for a minute or two, because there was a related session going on the exact opposite side of the conference.
That makes sense.
Fun and games with people getting over here.
It was quicker for me to switch rooms than for you, I guess.
Everyone loves Vertio. People are coming to grab all of the nice chocolates and the Yogto stickers. No, feel free to take the chocolates away. I don't even know why there's a table full of chocolates with the prizes being thrown out. Well, then take your chocolates. You have a lot of chocolates. Andy's stealing chocolates. That's what's going on in the room. Okie dokie. Okay, who's on mic throwing duty? Give it another 30 seconds or so. Okay, so welcome to this session on PCI device authentication and encryption. Now, Lucas is remote, and this is primarily his topic to drive. So I'm just sort of going to act as compare in the room and throw microphones at people. Given the whole point here is to have a deep discussion, if it turns out to be easier for someone to leg it up here and speak into this microphone, feel free. If not, we'll be throwing the mics around. So over to you, Lucas.
Okay, thanks a lot. So am I audible?
Hang on, Lucas. You're a bit quiet. Give it a sec.
Okay.
Again.
1, 2, 3, 4. Is that good?
That's better. Thank you very much.
Awesome. Okay, so let's start. Quick overview of the agenda. I have submitted some patches back in September. I wanted to give a quick recap on that. I wanted to talk about what's coming up after that. And we have some controversies that I would like to discuss. And hopefully we will be able to reach alignment on that. So this is about PCI device authentication and encryption. And it turns out there is a generic protocol for that, which was designed by the DMTF. It's called Security Protocol and Data Model. So that's a generic protocol for authentication, for measurement retrieval, and for setting up an encrypted channel to a device. And the PCI SIG has simply adopted that specification among several other consortiums. So the CXL consortium has also adopted it naturally. And I think SATA and SCSI are also looking into supporting that or encapsulating SPDM packets. One crucial limitation of SPDM is that there can only be one entity in the system which communicates with the device over SPDM. There can only be a single SPDM session. That's a crucial limitation which is causing a lot of headache for us, as will become apparent soon. So going to the next slide here. So we can decide who is responsible for the SPDM session, who is handling the authentication and the measurement retrieval and all that. One way to do it is to hand that over to the OS kernel. And the other option is to have a security module inside the CPU do that. Commonly, this is called a TSM, Trusted Security Module.
So the Intel implementation is called TDX Connect, and AMD is calling that SEVTIO. Everyone has something proprietary. The idea is that so either the kernel talks to the device or that security module inside the CPU, but not both. That's because that protocol limitation. What I am primarily interested is the first approach, letting the kernel handle that. One advantage is that we can have seamless integration with reset recovery. So every time we have a DPC event or we issue a secondary bus reset, we automatically perform re-authentication with a device. And likewise, when the system resumes from D3 cold or the device runtime resumes from D3 cold, we automatically re-authenticate the device and make sure that it hasn't changed or that it's not malicious, because every time it gets a reset, it could be a different device.
Lucas, we got a question.
Well,
Okay.
not a question, a comment. To add more good points to this first approach is that essentially it can be transport independent, meaning that the same code can also handle SCSI and ATA.
Right.
If we go the second one, it's going to be way harder.
So this is separating the SPDM sort of library layer and all of the stuff for that side of things from the actual transport.
Yes.
Yep, that makes sense.
But also I would say it's not a zero-sum game. Like you can also talk to the TSM in those flows, but for sharing code, you can also share code. Like so, the native implementation need not give way. Like the kernel can do both.
Yeah, absolutely. Yeah.
Yeah, I mean, the problem I see is that most of these implementations, which are designed to run on a TSM, are primarily targeted towards the confidential computing use case. So they want to perform attestation of a device which is passed through to a guest. That's, I think, the primary motivation for letting the TSM handle SPDM. And the APIs of these TSMs are geared towards that. And I think they do not allow the same degree of freedom that we have if we do this in the kernel. Okay. Another issue is measurements on that are the SPDM protocol allows measurements to change at runtime for whatever reason. I don't know what they were thinking, but the protocol allows that. And so it's necessary, if you want to make sure that you always have fresh measurements, you have to retrieve them on demand. We can do that in the kernel, but the APIs provided for confidential computing are relatively rigid. So it is probably a bit difficult to achieve the same functionality with those APIs. Another disadvantage. Go ahead.
I was gonna say real quick, like I think Linux needs to think very hard about the idea that you would measure something and then it changes behind your back. That we would support that. Like this needs to be considered in very specific circumstances. Like the security properties of taking a measurement and not being able to trust that measurement are pretty large.
You can still trust it. It just, if you do something, it might change.
That's not trust, right?
Well, it's still trusted. It's just different.
Yeah, I mean, you've got a lot of different measurements. This isn't just one measurement. This is a whole set. So it's more than plausible. Some of them reflect things like the firmware version, etc., and some of them might reflect
Like debug status and stuff.
Right. But if you place trust in a parameter, and that and then the next time you read that parameter, the parameter is changed, what happened to your trust?
But that's why I think you have protocols like TDISP, right? So if you validated an endpoint that has TDISP and it's going to enforce the TDISP verbs, right? then you know that if the firmware gets updated, it's going to revoke the SPDM session. That's the sort of protocol, right? And it's going to default back to an error state or an unlocked state, and then you have to reestablish trust in it again. So as long as you have that protocol endpoint that you validated on the first time you authenticated the device and validated the trust in it, then you can enforce an upgrade model on top of that.
TDIS has an amusing line in it that says you must have a security professional who knows what they're doing when you specify what can change and what changes the measurements.
Yeah, my only point is that if you go through the error state to get back to get the new measurements, that's not retrieving fresh measurements. That's starting over.
Yeah, actually, it is even possible that certificates might change behind our back, because the protocol allows that you can not only talk to the device over DOE, but someone, a baseband controller, might talk to the device over MCTP, and they might change, they might provision a new certificate, and we're not aware about it. And so it is, in principle, the protocol allows that certificates are provisioned behind our back. That's another snag of this protocol.
That's okay as long as we don't remove any, because that's just in the category of, well, something would work if you tried again, and we don't try again, so we don't care. So that one I don't think is too bad. If you revoked a certificate or removed it from the device, then you really want it to drop out of TDIS. I think that's definitely in the don't do it category. Jerome? Sorry.
So it's been a while since I read the spec TDX and AMD one. I thought that the API they were providing, the TSM they're providing, will allow you to send any command you want, any SPDM command you want to the device, and it's just like going to be a forward from the guest to the device through the TSM.
It's not as flexible as any command so far, but it's not particularly tightly defined, I think. So go ahead. Hang on. Close with the mic first.
A more general question. I mean, when you say two roads diverged, as in you're asking if you have to make a choice here, or it's something that we need to take for granted and just do it? I mean, because I don't think there is a choice there. I mean, for some reason we want SPDM to be handled in a security model inside a CPU, and well, if it has to be handled in the kernel, it's a separate choice. But I mean, what I don't get if we are discussing about two possibilities, but there isn't. I mean, we just need to do both, and they need to coexist. Is that correct?
They can't completely coexist, which is the bit that causes you trouble, because you can only have one session open, but you've got a policy decision to make for what do you care about right now.
Yeah, well, okay, that was the question. Then, well, I don't want to jump the gun, but I don't know if it's all the story behind DOE being PCI config space and shared. It's being sorted, if it can be sorted or not. But I think it's
that one's still open. But the nature of these TSMs, etc., talking is they are still talking through the host kernel. They're just passing stuff that the host kernel can't interpret. So it's all proxied. There are some other nasty problems with things accidentally trampling on the DOEs, because they may be doing something entirely different. And there's no way of finding out what they do without querying the discovery protocol, which can kill your SPDM session.
Yeah, well, okay, but I want just to understand if you are deciding, okay, it's not doing that in the security model is not the way to go. I mean, there is no choice there. I mean, if it's like that, it's like that. Yeah.
I mean, I think the aim here today, and Lucas, correct me if I'm wrong, but I think the aim here is to, if possible, establish if there are any problems with a policy-based type decision where all of these routes are enabled, and we make sure that everything that should look the same looks the same, and all that sort of stuff. But we can make the decision depending on what you're actually doing with it, and what your use case is.
Right. So I was going to talk about that on the next slide. I was just
sorry.
No problem.
Oh, we got one more question.
Okay.
On this slide.
What the hell is the reason for not supporting virtual functions? Because in virtualization, that's pretty much what we're going to pass up to the virtual machine. And it sounds like the protocol would operate much more easily if you supported them.
Okay, so the thing on virtual functions, do you want to do this, Lucas? You go for it.
Yeah, so the PCI spec permits that each virtual function has a DOE capability, and in that case, it is possible that you can have a separate SPDM session with each virtual function. The problem is the PCI spec permits that. It doesn't prescribe that, so it's optional.
To be honest, we've not heard of anyone doing it yet. If anyone wants to stick their arm up and say they are doing it from a VF, we got one. So we definitely need to support that, which means we definitely need an in-kernel stack because there's no other way of doing it. Superb. Hey, wait for the mic, because Lucas can't hear you.
Oh boy. We have been, I will say, looking at this spec and looking at SRIOV and interested in combining the two for future use cases.
That sounds good. So there may be some. If you have any opportunity to push people to do it, it does make life so much simpler from some of the cases, because you don't have to go through anywhere near as many calls down into your trusted module, because you could just talk to the device, which would be lovely. But yeah, it's optional.
But Jonathan, the native kernel stack was never in threat. So like when you're saying we don't need the VF case to justify the native kernel stack. Like we're doing native kernel stack no matter what.
The answer to that is yeah. I think we got to that point in last year's Birds of a Feather. We established that there were necessary use cases. Having more of them is always useful for at least motivating us moving a bit quicker. Okay. More people care, which we always like.
Okay. Any further questions, or
we're good for now? I think no hands up.
Okay. Yeah. So one drawback of the native kernel based approach is that you need help from either the host or from the TSM to set up encryption. The problem is the encryption, IDE encryption, is symmetric. So you have to program a key both into the device, in the endpoint device, and into the root port. So programming the key into the endpoint device from a confidential VM is perfectly possible, as if that guest has control of the SPDM session, because that is exchanged over SPDM. The problem is programming the key into the root port. You need help either from the host or from the TSM to do that. That's one drawback of the native approach. And of course, the TSM approach has the drawback that you have to trust a blob, which is provided by the CPU vendor. And so in the case of Intel, the source code is actually public, but it's not free software. Is there a question?
Yep, there is.
Not a question, but it's not always a blob. So it can be open source. And on RISC-V, for example, we are providing an open source implementation of the equivalent of a TSM. So it's something that you can audit, review, modify, contribute to, the same way that you can do that with a Linux kernel.
Yep, I have to say so is on. So are some others who we have a whole list now. Go on, John.
I believe even some x86 vendor actually have released some of the TDX or ICD module. I don't know.
Yeah, no, it's open source.
Yeah. I'm just throwing another quick clarification. It isn't actually strictly necessary under the spec to involve a TSM in setting up IDE. It's just that no one's actually built the version where you talk to an SPDM session in the root port itself in order to set the connection up, because it's crazy heavy. Sounds like someone might have done.
Yeah, I was just going to add that even the PSP firmware source code is.
I was going to say is that a lot of these are not open source; they're source available, and there's a very different use case for that. The Intel one, you'll be able to read the source code, but you won't be able to compile it and put your own in, fix bugs, add functionality or anything, because it's all signed by an Intel key you don't have.
And now you can say AMD does the same. Yep.
So you can audit it and be fairly sure it's what you think it is.
Yeah. So I would say we can applaud. We need to applaud the RISC-V effort, because that puts pressure on the other vendors to open up their TSM code. So. So I submitted a series in September for device authentication. My goal is to respin that this quarter. I would like to say that this is a joint effort by multiple vendors. So that involves Jonathan from Huawei, that involves me from Intel, It involves Alistair and Wilfred, who are in the back, I think, from Western Digital. Hello. And so it's a joint multi-vendor effort, and I think that's important. It's not just a single vendor trying to shoehorn their code into upstream. It's multiple vendors collaborating and having a joint interest in this. So I'm proposing a solution for this issue we have just discussed. I think my proposal is that initially the host OS kernel would be responsible for authenticating the device, and it would expose measurements in sysfs. But once a device is passed through to a guest, it would relinquish control of the SPDM session, and from that point on, the TSM would be responsible. That would be my proposal, and I would offer library calls, which are called from KVM, for example, to get control of the SPDM session. That would be my proposal for this. Are there any comments? Does anyone have any comments on that?
There's a few comments.
Point out, this does not work with PCI-TDIS because if I remember correctly, so if you set up PCI-TDIS with an SPDM session and then you stop that SPDM session and you do a new SPDM session, then the PCI-TDIS lock the device, and the device don't.
No, because you haven't, when you've done it in the initial kernel, you haven't entered lock state, so there's no error state. You're still just doing CMA. Then you redo the whole thing again. There's a bit of duplication.
Yeah, but so if you give one device to a VM, one VF to a VM, that one under lock state, that one is running.
Yes.
Then you give another VF of that same physical device to a different VM that want to do another SPDM.
No. You hand it over once. I agree. Maybe the terminology here of doing this isn't implying you do it for each one. You do it on the first one. So the first time,
Okay, so if you do it only once, that works. But if you do it multiple times, it doesn't work.
Yes. Well, you hand over control specifically of the little bit of the PF, and then the locks requirements that come with the PF driver, that you don't run into any problems. There's not much else I think we can do.
I just want to mention that this proposed solution, to get back to the previous slide, it's basically a solution that allows for the two proposals to actually coexist.
Yeah.
Right.
So this is very useful, and yes.
The question here is where do you squirt in policy on what you're actually going to do? And you could put the policy before and not bother trying to do the kernel first version, where you say, hi, who are you? Or you could say, well, we'll do that. We'll have a look at the result. Did it fail? Have we not got the cert? Well, we've now got a policy decision that says, actually, we didn't need that one to pass. Don't worry about it. Which lets us do it a bit earlier, where you then still be able to assign it. Or you might say, well, actually, I don't want to assign a device. I want to use a device at all in any way if the hypervisor is not happy that device is good. I mean, that's not a security attack. It's just a little bit more paranoia.
Yeah, it's kind of on that topic. The flow is the same on the host, and you can do that on the host. You can do that on the guest, on a confidential guest. The flow is going to be the same, where you're gonna probe the device from the host. You're gonna, if you want to test it, you're gonna test it, and if you want to accept it, you're gonna accept it. But the flow is gonna be the same, and you can say, if I see it from the host, I'm gonna authenticate it, attest it, and accept it, and it's gonna be owned by the host until someone decides that I'm gonna ask KVM to actually reclaim that device because I want to pass it to a confidential VM.
The concept of accept doesn't make quite the same sense for the host because it can't engage in the rest of TDIS. Because we can't deal with the T-bit.
What's that?
The host. Well, okay. In the implementations that exist, the host is never capable of setting the T-bit. So nothing that's actually going to the device is appropriately marked. You could do the rest of the flow. It's just a chit chat.
I mean, just implementation. Oh, yeah. Okay.
So,
the thing I'm going to say is I agree we need to have a dynamic switchover, but it may not even need to be this granular. Like you could have a policy that says if you have a TSM, try to use it, and if you don't want to use your TSM, then set a policy never use TSM. And if the TSM says I don't like this thing, you can say, do I want to fall back to native or not? And if TSM's not there, you use native all the time. So it may not even need to be like live dynamic. It could just be a boot time policy like we have for ACPI things, where you say we trust the ACPI thing or we do it ourselves, and it's just an override.
Yeah. One concern I have is around IDE. So one of the things people have said with IDE is it's not necessarily the case that you have enough encryption contexts. So, and there's also a horrible performance problem with IDE. That encryption's painful. If you have a device, you might want to go through an authentication thing and say, well, actually, I never gave it to a confidential VM. Don't do the encryption. It's going to cost me a lot of performance. Maybe in those circumstances, we need to have another layer of policy that says, well, okay, I've either run out of encryption context or whatever. But you may, the question as well is whether the TSMs have the lighter weight request, which is, please just do the IDE setup for me.
I mean, just SPDM.
It's a bit more than SPDM. It's the IDE bit that's on top of that. So you got to do key exchange, etc. Whereas, yeah, you got to send the relevant messages to actually bring the keys up to get the encryption started. Yes, you got to do that first. There's a bit more.
Yeah,
on top.
you mean a lightweight as in do only SPDM, but not
the rest of TDISP. Yeah.
Yeah. Okay.
So you don't care about lockdown states. You don't care about any of that
Sure.
because you're not doing confidential compute. You just want to encrypt your link.
Yeah. So you want to do ID over SPDM and stop there.
Yeah.
But you can. Yeah. That.
Well, that
then-
has to actually. I mean, the interfaces that have been discussed so far for the TSMs, have, as far as I've noticed, have never considered that simpler case.
It does. Yeah. The interfaces that Alexa has been proposing, there's one verb that is connect, which is exactly this. Connect basically establish the SPDM session, creates the IDE key exchange, establish IDE, and stops there.
Okay, I thought that left you in a state where DMA was disabled from his description, but that may just be because he was talking about the confidential version. It may be that it's fine. You can turn it on.
If you do confidential, then you want DMA to be disabled.
Okay, cool.
I mean, from the TDISP perspective, and from TIO's perspective, once you connect to a device, the device still behaves as if it's a legacy device. You have to go through the binding operation before DMA and MMIO gets blocked and such. So you could conceivably consider a case where the connect verb has a connect light kind of command where you say, do the SPDM IDE exchange and set everything up then.
Okay, yeah, and that basically solves that problem. So cool.
Okay. So it's also important to know that not every device supports attestation. So there is a TEIO supported bit in the device capabilities register in config space. And if that bit is not set, the device does not support attestation. So in that case, you cannot use TDISP and all that. And in that case, it might be that the OS kernel driven SPDM session is the only option. Of course, it might be possible to somehow use the API of the TSM to also achieve the same functionality, but it's not a given. They were designed for a different purpose.
Wait, so when you say attestation, do you mean attestation is built into to SPDM? It's without TDISP, attestation is there. That's the get measurements command. So if it supports, I believe, CMA, you support attestation.
No, I think that's a misunderstanding. So when I say attestation, it means that the TSM attests or provides a report and attests, for example, that it has configured the IOMMU in a specific way and all that. That's what I refer to.
Yeah, that's more of the host side TDISP stuff.
Right.
But for attestation, if you're trying to look for attestation reports, that's part of just plain vanilla SPDM.
Okay. Yeah. Sure. Okay.
I'm saying technically it's optional to do measurement. In practice, what did you do it for if you don't?
I mean, yeah, that's right. You could ignore the attestation report and just turn everything on.
Yeah, I mean, you could just rely on the certificate and say, well, this thing has no configuration. It's a very, very dumb device, so there's no point in measuring anything.
Yeah.
And then you're okay.
Okay. So this patch set that I've submitted and that I'm going to respin, this just provides authentication. So you have a keyring in the kernel, and you can add certificates to that keyring using the keyctl command. And then there is a file in sysfs called authenticated, and if you if you cat that attribute, it says 1 for authenticated or 0 for not authenticated, and there are some diagnostics in dmask. And you can also echo 1 to that authenticated file to initiate re-authentication. So for example, if you have added a certificate to the keyring, you can just echo 1 to that file and it will re-authenticate the device, or it will attempt to do that. That's the sole functionality of that patch set. And going forward, I wanted to talk about what I think I will be working on next. That will be measurement retrieval. So I had a lot of I've exchanged a lot of emails with Alistair from Western Digital because he has a real life use case for this. I don't know how much I can say about that. Maybe Alistair wants to talk about it himself. I don't know. Basically, the idea is to expose, for example, a firmware version, and a cloud service provider might allow only certain firmware versions. And if a CVE is found in an older version, a cloud service provider might want to check which firmware versions are currently deployed in a data center. And if it turns out, okay, there are devices which have an older version, maybe we want to tolerate that. And if it has this vulnerability, then we need to update it. So there would be a rolling update of all the devices, and the devices can be found through these measurements, which are exposed in sysfs. Any comments on that? No? Okay, yeah.
Yeah, hang on. Microphone being passed.
Not a comment, but a question. What do you mean by measurement indices?
Okay,
what are the indices for?
Yeah, so that's just a term which is used in the SPDM specification. They are saying you have multiple measurements. You can have up to 254 measurements, and they are calling that index. They are indexed. So you retrieve a number. That's the number of that measurement. And they have reserved some of these numbers. So one of these numbers, I don't know which one, is for a manifest. So you might want to retrieve that manifest, and that manifest might contain information which other measurements might be available. That's just a term from the SPDM spec.
But I mean, it's completely. I mean, it's not related to your proposal, but it basically means that SPDM is proposing yet another attestation format. It's basically an attestation report from SPDM, and it's yet another format.
With a few corners, it's basically undefined. It's just magic measurement.
Yeah. Yes.
Which you could put in any format that made sense.
Sure, but it's yeah. But I think SPDM leaves some space for using other vendor-specific or not vendor-specific, more standardized attestation report format.
Oh, absolutely. Yeah. But that's a hardware definition problem.
It's a device manufacturer decision, yeah, unfortunately.
So it is possible, in principle, to support that because you have this when you start the SPDM session, there is an exchange called negotiate algorithms, and as part of that, the requester provides options of the supported measurement formats, and there is currently only one measurement format defined. That's the DMTF one. So we can only offer that single format, and the responder will then select that. So in principle, it's possible that the DMTF defines additional measurement formats. They just haven't so far.
And just so I understand the point of these three files, the bitstream is actually the binary data. The digest is the hash the device reports. The type tells you how to hash it. And if you just pass that bitstream into a SHA-256 sum of whatever, it should match the digest. Is that about right?
Exactly. And the type is something which is that's part of their DMTF defined measurement format. So when you retrieve a measurement, you also get a type with it. And this could some of these types are like firmware measurement or whatever. They have multiple types, and it just gives you an information what kind of measurement this is.
Good to go. Just a comment, not really a question, and I'll talk with Alistair about that. But for the SysFS structure, I just would like to make sure that we have everything grouped together in a single attribute group, so that we can move, or actually reuse the same group with the same structure, with the same everything for different transport, again, SCSI device, ATA device, etc. So
Yeah.
measurements, if it's not the top one, we'll probably want to have a top directory that says SPDM or whatever, so that whatever the name.
That's going to get ugly really quickly. I mean, it's not really a subsystem if it's just providing a few numbers. So
no,
you could do so. I mean, it's not going to be hard.
I mean,
to find.
everything related to the SPDM session measurement, etc.
I see.
Yeah, under a single attribute directory, so that we can attach that one to any type of device that supports SPDM, not just PCI.
That's fair enough. Yeah.
In other words, once we support SPDM for SCSI or SATA, you want the same exposure in SysFS. I understand.
Yes, that would be way easier for the users. Yes.
Okay. So I have thought about embedding the SysFS exposure in the SPDM library. The problem is, I think I'm not going to do that. I think I will put that in the CMA code, because when SPDM is controlled, that's the last bullet point on the slide, when SPDM is controlled by the TSM, I want these measurements to still work. I want users to still be able to access them. And the way to access them is just to look at the report, the device interface report, which was retrieved from the device, or which is presented by the TSM. So that's the only option that we have, because if we're not in control of SPDM, we can only use that. So I will have basically an if clause, and if the device is under control of the TSM, I will have to ask, look into the device interface report to get to those measurements. That's the only way. So I think it will not be possible to embed the SysFS exposure in the SPDM library. I will have to put that in CMA, but I don't know. I am aware of the problem. I will try to find a solution that maybe we can share a code once we need that for other device types. But I'm aware of the problem. Yeah.
Lucas, I'd shortcut this. What matters at this point is documentation. What the implementation is, what refactoring happens, what sharing, that's later, once there are multiple implementations.
One question, Lucas, how do you authenticate the measurements? Because they're SPDM.
The kernel does that. So when you perform the authentication, there are 8 certificate slots, and I iterate over all these 8 slots and I retrieve the certificate chain, and I try to validate those certificates. I test whether they are assigned by one of the keys on that keyring. And once I have found a certificate chain that validates, then I use that for the challenge authenticate, for the challenge response, which authenticates the device. And that same certificate chain is then used for verifying the signature on those measurements. So the kernel is responsible for verifying the signature, and you will only, all the measurements in SysFS have been verified by the kernel. Does that answer your question?
It does, but it also means you don't let user space verify the measurements that it's gonna.
Yeah.
Okay.
So just on looking at the format of these measurements, this is not a criticism of patches. It looks like a criticism of SPDM. We've been through exactly the same thing with the TPM and its 24 PCRs. You begin life by thinking that PCR values explicitly specify everything in the system. And what you find when stuff starts changing and you start adding pieces is there's this massive combinatoric explosion, and you can't tell how the measurement was constructed. Has the SPDM SIG actually thought about this and thought they might need something more like a log that then, you know, hashes to the measurements rather than having a set of single register
I
measurements?
think they think it's out of scope. Now, that's not to say they won't take proposals. Other specs are allowed to define the format. So there are bits and pieces in, get this right, there are bits and pieces in the PCI stuff that are sort of hinted at, but I think their intent is that it's other people's problem to define it for a particular type of situation. But I mean, they may well take stuff. I mean, they're friendly.
So I just wanted to point out the kernel verifying the cert doesn't work for me and won't work for.
Okay, so so you don't want the kernel to verify the cert.
Only user space.
Why?
Because I can only get the necessary information in user space and all the policy and so on.
So on the next slide, I'm talking about exposing the certificate chains. So you do get access to the certificate chains, but you do not get access to the signed. So user space doesn't get access to the challenge response that happens between the kernel and the device.
Right, but that's not good enough if what we're trying to do is prove to a third party that everything was set up correctly, because then we actually need the signature, the challenge, and the response as part of the evidence we present. Let's say we're trying to prove to it, let's say there's a third party attesting to confidential setup of this device on this platform, either physical or virtual and confidential environment. The remote system that's doing the attestation has to prove to itself that all setup was correct. It can't, and the proof can't just sit in the kernel. It has to be exposed to the attestation system so it can process it and say, yep, everything was set up correctly.
Does that attestation system need to inject the nonce?
It would, ideally, yes.
Okay, so I mean, exposing it's easy, and it's just a big blob of data. The sequence, because it's all used for the final hash anyway. So that bit's easy. It's just you're going to need an extra path to squirt a nonce in at the beginning and say, use this nonce, off you go, give me the answer of the whole chain.
We're working on a system whereby these attestations can be stored offline and remeasured after the fact, so that there should somewhere exist proof that at a particular time on a particular day, this setup occurred and was correct, and people should be able to go, you know, after a passage of time, go back and actually assess that proof.
So to me, Lucas, that doesn't sound a particularly heavy lift. I mean, it may not be the thing we do in the first patch set. It might be a follow-up, but all of the data's there. Just to keep the scope reasonable for getting something in, and then come back around for that. Does that sound okay to you, Lucas?
Yeah, I mean, I'm taken aback, but
no one trusts us kernel folk. That's what we've established in confidential computing.
It's not a point about trusting something. It's a point about getting something that satisfies an external verifier. And I mean, all of these problems, this is slightly annoying because all of these problems have been thought about before by people over decades, and it looks like nobody read the specs of what we do.
Yeah, it's fine.
This stuff is, they're TPMs on devices. They're TPMs on the other side of PCI links. They're TPMs going through insane SPDM, DOE nonsense. It's all been done before, and we know how all of this works, and you have to take the challenge from the relaying party. You have to run it through all your crypto, because that's the proof that you were actually alive when you did the attestation.
No, that's fair enough. I mean, it's definitely a flow. The other flow is local machine checking against certs it already has. It's a different use case, but it's one people still care about.
I guess.
It's the bog standard IMA type case where you're just bringing it up and you've got a cert and you go, oh, is that my hard disk? And then later on you may go out and get external stuff. So it's is it the same as last time question?
I guess.
But,
I mean,
so,
sure, but
it's not hard to.
But don't you want to ultimately tie this to the TPM? Like, shouldn't that really be the point, that if I'm building like a system, a local system only, and it has an encrypted hard drive with the TPM protecting the symmetric key, shouldn't I check all the PCI devices that I'm going to turn on before I unlock the TPM? And shouldn't I feed that measurement into the TPM?
Undoubtedly, but several steps down the line.
But the interfaces should expose enough data that can be done correctly and securely.
No, agreed. But there's the classic here of if we splat this too wide on the very first getting something in, because there's a bunch of bits and pieces to do in the crypto code, etc., to get this enabled. We just want start, and then absolutely, to my mind, add in exactly what we need is a conversation. And then we need a proof of concept of actually getting into, as you say, to unlock the secrets in the TPM and make sure we didn't forget anything. But it's not. It shouldn't be too hard. I mean, as I say, the data's all there.
I mean, I hear what you're saying, but like, how long has it been, James? Like TPM stuff has been forever, and we still don't have basic functionality for it in Linux. Like, it's like maybe next year Ubuntu will release an operating system that can do drive unlock with TPM. Like, are you ever going to get there if you don't start or make it start at the beginning?
Absolutely fair enough. But I mean, there is the point until we have a stack that's clearly using the thing, the chances of getting it wrong is quite high because we're not as good at this. Maybe we make it your problem to tell us whether we missed something, which, yeah, that works. Works for me anyway. He's trying to get rid of the microphone.
I'm trying to get rid of the microphone. I've said my piece.
So again, because I want to take notes here. So you want, James, you want to input a nonce, and you want to expose both the challenge and the response. Is that correct?
That's correct. So we can transport all of those pieces of information off the system, verify in some remote place that everything was done correctly. So this is the essence of remote verification.
Okay.
I mean, that boils down to the hash chain that you build during the SPDM session to do the no replay protection, because that is absolutely the entire exchange. Plus the nonce to score it in at the right point. So it's the stuff the kernel's building in order to get the final hash. Anyway, to check that the things are right. So
yeah, and I mean, there are people who use just a secure random number for the nonce, but it's always helpful in these systems to actually say the nonce encodes something else to prove a binding. And so that's why you have an input field for the nonce somewhere in the system.
Okay. There is a snag here because independently of that, the SPDM protocol allows devices that are not able to sign measurements. The protocol allows that. I was wondering, what am I supposed to do in that case? Should I expose the measurements at all, or should I force user space to opt into unsigned measurements? There could be a sysctl option that user space has to explicitly set, either a global option or a per device option to opt into unsigned measurements, or should I just expose these an attribute which kind of says, okay, these measurements are not necessarily trustworthy because they are.
Just don't put the digest file. So no digest file inside the directories, and it's not signed.
So the digest is just a hash of the bit stream as.
Oh, is that just
it's not a signature? I mean,
there's no signature.
There's two options here. I mean, the simplest one is Linux takes the view that's crazy and just refuses to expose them, and we hope no device defender builds them. If they, no one likes that.
Device, just don't know how to use it.
Oh, okay.
Because at least you know it's there, but it's bad.
Oh, you always know it's there in PCI. You just don't know. Okay, so print big rude error messages to try and put people off. Taint the kernel while we're there.
You already have, like, if you're building these devices to get this kind of security, the signing keys to do all this signing and measuring are only on production devices that only run production software. All of the development team does not have access to those keys. And
do they not use a test key?
They do something else, right? But it may not be in these key rings. It may become very difficult to use a test device in Linux if you put too many blockades in the way.
There's always policy. You can just ignore this completely. We're not saying the driver won't bind, etc. We're just exposing it, and you have to say, I don't care that it's untrusted.
That's probably okay.
And that's why showing it is important. But then you can have a CSFS and say, I don't care. Echo 1, I don't care. And then it works.
Yeah, okay. So it sounds like the conclusion here, Lucas, was expose the fact that it's not signed. Just have another file that says whether it's signed or not.
I think opt-in,
Okay.
so you can echo one to opt-in.
Oh, okay.
Per device.
So don't expose the measurements at all unless you've echoed one in before you attempted to authenticate and get the measurements in the first place.
I was going to say, like, why opt in? Just show us unsigned, and you can read that or not. What's the opt in for?
Bad software.
Bad software. Yeah. We'll make a mistake and read it.
This is Linux. We give people the rope to hang themselves.
This is Linux user space. Anything could happen.
Okay. So another feature that I will be working on is exposure of these certificates. Again, there are 8 slots here. So I think what would my expectation is that the slot 0 will be provisioned by the manufacturer of the device, and the upper 7 slots are available. As I have, okay, there is a question in the back.
Lucas, we were just making the point as well. We've got about 7 minutes, although technically there's a break.
No,
but people will run off for coffee. There's a question.
No, we're already way beyond. I think we only had 45 minutes, right? There is a break.
Yeah. Okay,
so
sorry, I got the time wrong. It's the breaks now. Sorry.
Yeah, I just wanted to mention that assuming the manufacturer would put a certificate in slot 0 is a bad assumption.
Okay. Well, no, it was just an example. So I don't really.
I agree.
Alistair is disagreeing, right?
It's stupid, but
Just Lucas, a question. So SPDM allows for not using certificates, but using this pre-shared PSK key. So do you support that?
No, unless someone comes along and says, I need that. No one has shouted yet. So
I think that's heavily used in some of the later TDIS bits, but that's stacked way up on top of this bit. I think there's something that required them.
It might not be called, I think it's called PSK. I don't remember what it stands for, but it's like you can, I think it's pre-shared key, but so instead of using certificate chains, you can directly provision the keys.
Yeah,
so
yeah.
This is for some controlled infrastructures.
Sure, yeah.
Mm-hmm. Okay, so
People
what
have a
I've
need,
learned.
maybe later.
Yep. Go ahead.
So I was just saying, Lucas, maybe that's one for later.
Okay.
Along with many other things.
I think so. So what I have learned from the discussions with Alistair is that in real life, for example, a cloud service provider might not be interested in using the manufacturer's certificate for validating the authenticating the device. A cloud service provider might set up their own CA, and they might want to distribute certificates to each device when they install it in their data center. And so the certificate in the kernel's keyring would actually be a root certificate of that CA, of that cloud service provider's own CA. And basically the idea, I think, is that the cloud service provider can prevent someone from attaching an arbitrary device in the data center because they are able to verify, okay, this device was provisioned by us. It has a valid certificate which is signed by our CA. And I think that would be a use case for these unused slots. And Alistair tells me that it's an important use case and that we need to support that. So what I think, or my proposal is that we will have this certificates subdirectory in sysfs, which exposes these slots. So you can read these slots and retrieve the certificate chain, and you can just feed that to OpenSSL to parse it. And you can also write something to these files, to these attributes, and that will automatically provision that certificate chain into that slot by triggering a set certificate exchange. Basically, there would be, is there a question?
Yeah, I was just going to say, Here's a question. The slots, what you read and what you write will be different because the certificate chain you write is not the same chain that you read because you can only write some of it if you're using alias certs.
Right.
So that's a question for Linux. Is that confusing? Was that allowed, or does it not matter?
So I'm not sure if everyone understood that. It's because that's a wrinkle. That's a wrinkle of the SPDM specification.
Yeah, that's the SPDM in a nutshell. So basically, if you have an alias cert device, when you read the certificates, you get the whole chain. So root CA all the way down to the device. When you set certificate, you only set the first kind of few of them. You don't set the whole chain. The device will generate some on the device. So I think it's kind of confusing to users that you read, 7 certificates, but you can only set 3. But maybe Linux doesn't care because
you
have to figure it out.
Yeah. It's a bit of an ugly interface, maybe.
Give user space to be able to hang itself. I mean, we put that in the ABI documentation.
Right. So this is a feature which was added in SPDM 1.2. This is called alias certificates, and basically it means that the device there is a little CA on the device itself, and the device can create sub-certificates. And when you retrieve the certificate chain, it contains all those sub-certificates. So personally, I think it's fine that there is this incongruence between reading and writing that attribute.
Could you just have an alias list and the normal list and just have 2 attributes?
I think set alias is optional in SPDM.
It is, yeah.
Yeah,
it is.
So you just wouldn't expose.
So it might not work in some devices. It's just
Well, you might not be able to write. It's perfectly valid to have no write support at all because the certs are burnt in via fuses or whatever. I don't know.
Okay.
So, I mean, all of these interfaces, if we don't support it, then it will be the usual sysfs tweaking to make it clear that that file doesn't do anything. It's not writable or isn't there at all.
And if a reset is required to set certificate, what do? Do we just reset the device, or do we return an error?
Yeah. So
you get the response. You get the response. This device will send response: is error reset required?
Okay.
We have this in
That's
some interfaces
possible.
already for like updating firmware. Like you staged it and you got to trigger it with a reset.
Yeah.
It'd be nice if SPDM told us that we were going to get the error code ahead of time.
It does.
Okay.
It does. Well, it tells you it might be.
Okay.
It
So we
tells
need to
you
expose that too.
It tells you it might be possible, might be required.
Might be means always. That was easy. Simpler
Okay.
interface. Stupid hardware.
So that's an error which is returned from the device in response to the set certificate request. So it returns a reset required error, but I think that's not a problem. We have an internal API in the PCI core, and it is easy for us to trigger a conventional reset of the PCI device and then re-authenticate the device when it comes back. So it's possible to handle that. It's not a problem.
It's also in the capabilities, right? The capabilities should say reset required.
Right.
Memory.
So can we push
Right.
it to user space? Just expose it as reset will be required on this device, and when user space programs this, the tooling needs to know that it needs to trigger a reset.
We can handle that in the
Yes.
kernel.
Yeah. Well, we can, but do we want to? Just because you've programmed the thing doesn't mean you instantly want to reset. You might be programming it for next reset.
Yeah, and again, please think transport independent. There's not just PCI in the picture. There's more.
I hear a reviewer volunteering.
Well, and we might want to stage the firmware update, stage the certificate right, do a whole bunch of things, and then hit the reset button.
Yep. Yeah.
Okay.
It's not always easy on PCI either. Bit random. Lucas, I think we should wrap up to give people 15 minutes to grab a coffee before the next one.
Okay. Yeah. So
okay,
I mean,
14 minutes.
I'm nearly
James drinks
through
quickly.
here. What? Okay.
Don't worry.
I mean, I'm nearly through here. Basically, the only remaining bullet points is that there will be a CSR attribute, and you just read from that to get a certificate signing request, which you hand to your CA, and then you get the certificate back from the CA, and then you write that to one of these slots. So that's all. And another feature that is a bit distant is, so I am looking into establishing this encrypted channel with a device, and that would be beneficial because for devices which do not support signed measurements, once we transport them over an encrypted channel, they will be signed implicitly. So I think that would be a mitigation for these devices which do not support that. Yeah.
Thank you. You say Diffie-Hellman key exchange. You mean DHE key exchange, right? It's Diffie-Hellman ephemeral, not Diffie-Hellman.
Yeah. That's a bit sloppy, I guess.
Yeah.
Yeah, so I think that's already the last slide. These are the features that I'm going to work on. I appreciate all your feedback. Thanks so much. There is a
Lucas, I guess we'll do the usual thing and try and send an email out summarizing what the feedback was to make sure we've captured everything and just send it to
Well, if you captured it in the shared notes, we can attach it to the session and everything. And you'll have a
that works
record.
even better, although I suspect we haven't.
Well, if you just render the notes to text, you can upload it into the Indico system and it'll appear with your session.
We'll try. We'll email it out as well for those who'll never find it. Thanks, Lucas.
Thank you so much, everyone.
Yeah.
Okay, 11 minutes left.
And there'll be some more fun stuff in 10 minutes.
Yeah.
I have to choose Secure or go down with Christoph Brück. Oh, that's very touching. Yes. And if you do this, you're going to have to go drink after anyway. The secure stuff is the no, this is trying to get in, so this one to figure out all the encryption and TS, all this stuff. A lot of you do. I go drinking. Listen to that.
This next one just started. If you think the previous one was confusing. Oh, that was getting much.
I'm just here to go, wow, I'm not doing this. That's easy.
Always comes back to job security. The worst expects are longer than required. As long as no one gives up, that's the only rule.
Oh, people give up and then they just come along with a different spin of the same idea. It just
At least bloody SPDM is eating the world. Because that, you know where the SPDM stuff came from? It's the thing used for comms, so the BMK aspect of the
it's like
Because people, SPDM is authenticated key exchange, so it's not just like different measurements in there, like testing measurements. But people keep like misinterpreting what SPDM is.
It's just a channel. You get to the point where you send anything out. And people hack various things on top of it. Extra messages. But the reason it existed in the first place was USB charger growth. It's this charger won't plug my laptop conversation. Is that's what it's for. So, which is a good use case. I mean, you kids don't understand how many copies of this thing are out there. Every USB device like every white balance does. But the others are done by resistors between the ones. But the high balance stuff. So, hello, who are you? Yeah, thankfully, no one's invented another choice for that. Oh, okay, no one's used another choice. Probably. It's actively evolving, which is another good thing. I haven't come across anyone who's told me what's wrong with the first version. I tried asking our security guys why the first version wasn't good. Well, it didn't look very nice. Did you just wanted to find some more spec than export versions? Exactly. I wanted one of those nice glass sculptures you get in the spec version. What do people do with those? Sort of stockpile random bits of glass. Oh, spec releases. So they're hilarious, but you get a significant contribution. They like to post something to commemorate this. And you get posted in the glass sculpture. Not on this one, but on the 6L ones. Which was really funny actually, because FedEx refused to ship a BoF. So it bounced around the US 3 times, or they gave up. You've got the postal addresses. That one was okay. Some of them are, yeah. They've got a few of the sharp ones around as well. You get this collection of random glass fun ones. We should do this in the code. We should just distribute random pieces of glass every year. Because then you've got to take it home from the conference.
Yeah.
Something that's impossible to carry.
Instead of giving useful things like buttons and stuff, here's a paperweight. Okay, what can we give people that is not technically illegal to go through security? So that's the most frustrating.
Too complicated. I'm stopping on stuff without all of the stuff.
This was meant to come.
It's a great relief. You don't have to go. This is all the stuff. This is the end of the game. Although the team spec does wonderfully allow for the possibility of the other difference in the time they like this.
Because they're all the people like you.
What about you?
Who wants to do all of that?
I must admit, I can think about anything like out of curiosity. They don't work for me.
Just because we can't do it doesn't mean
The other versions where the stuff we did for testing, I don't. We ended up with the two I'm not quite happy to do it. Since
What's right?
I was saying, I feel like all this confidential code teach that it's not as done by a talk that didn't want.
Oh, I'm tired of security people who believe. I mean, it is typical of fucking security people. They never look at what somebody else did. They always believe that what they're doing is best, and they never look at any solutions that other people had because they ran into some pile of shit and decided, oh, it doesn't quite work well like this.
You're talking about SPDM?
Well, I'm talking in general about security people. The reason we have so many overlapping or interoperable security solutions is because everybody who does security thinks they know best. And whatever weird and wonderful scheme they come up with must be the best.
You have to start from scratch every time.
Yeah.
You can't build it anymore.
But to defend to SPDM people, I have looked into my systems. A lot of this SPDM design is based on TLS1.
Which is such a wonderful protocol to begin with.
TLS1.3, they're building TPM. There needs to be TPM, it's not TLS.
Yeah, no, SPDM is unduplicated key exchange.
It's TPM because it attests to things for remote using measurements and all the other things.
No, it's a transfer of the file. It's just a transfer. This is how we envision it. Unduplicated key exchange. All the security analysis which has been done on it for battery is only component.
I know, but that's not how it's used.
Which is what especially all that transports.
What was the 6L one last time? Was there
If we want to close the break,
It's just an annoyingly pervasive attitude in the industry, the space of people who like to do security solutions. Yeah.
Okay, I've been convinced to stay for one more.
Really? What time's your flight?
Well, 7:45. So
Oh, for God's sake. It takes about 20 minutes to get to the airport.
I know, I'm
from
used to
here.
flying out of JFK, so.
And you can arrive about, if you feel unsafe, arrive an hour before your flight leaves. If you feel like you're really confident, you can do it about, 40 minutes.
Is there any chance of like traffic on the airport?
Well, from here, not really, because the fastest route would probably be on 64, but there are plenty of other intermediate routes.
We're going to start in a few minutes once Dan is back. He remembered something at the last minute.
I'm used to flying out.
So he's going to wait for him. But it's not as if we have to be anywhere after this BoF, right?
What if all of a sudden doesn't make you that confident?
About what?
You just said nobody has anywhere to be after the stock either.
I do. Yeah, if your flight's at 7, you leave here around 6. Or 5:30 if you're feeling squeamish.
All the answers. So we just realized that this room's empty after this one. So if you want to make it to the social event, you may want to solve all the problems soon.
So Dan says that he just needs to get something, but he just left.
That's the way to get to me first.
So Dan, we just realized that there's nothing here after this. So if you want to go to the social event, you need to answer all the questions.
You answer all the questions?
Yeah, no. Just no. So,
hang on. May I refer you to the timetable? There is a session after this.
Yeah.
Yes.
In this room.
I believe so. I can check. Are you sure?
well, first I need to figure out, maybe I need to take presenter up here so I can move the slide forward to the diagram. Okay. So where we left off yesterday of me not understanding why I'm up here, was start to talk about what does this start to look like in the kernel, and how we have common implementations and especially common user space ABIs, even if some of those ABIs need to convey some vendor specific things. I want to preface this by saying that yesterday we had S390 present first, and they're not TDIS, but they have a full firmware interface, a full firmware interface in front of all of this. Greg came up to me after the session or today and said, that S390 thing looks really nice. And the blood drained out of my face because what I was talking about yesterday was, so to put it plainly, Intel started with exposing like this much complexity to Linux. AMD started here, and my proposal was like, hey, let's try to bring the Intel complexity down to match AMD. And if we find any other vendors that's above that kind of line, let's bring them down to that. And if we actually find somebody even lower, we'd move everybody, try to move everybody down. But so far, I haven't found that. What Greg was saying is like, if you guys, to me, my interpretation was if you guys don't get your act together and don't work together, I'm going to force you to go all the way down and put it like beneath an EFI level thing. So I think it behooves us to say like, no, we know how to handle this vendor differentiation. We don't need to do the nuclear option of taking all of it away from Linux. So that's these are the stakes here. If we start to bother other parts of the kernel with too much change, like they may just be like, hey, blow it all up and come back when you can push it all the way down into firmware. I don't know if people online can see the pointer. They can. Okay. So there's so much to talk about. For some reason, I get the mic, so I think I'm going to pick what I want to talk about. But feel free to interject at any point. To me, we have in this box inside the guest, I have this thing called the GHCX layer. The idea here is that this is the common Linux wrapper entry point into all the different vendor guest to host interfaces. And so Intel calls it, AMD and Intel call it GHCI and GCB. That's where GHCX came from. And then RISC-V went in, threw all the letters and called it the Cove ABI. But anyway, Cove and all the GHCs would be in this box. This other thing was probably the first discussion point, is a Linux native guest to host interface. And so what is this for? One of the use cases that people bring up is like, hey, I might want to bind late, or I might, and when I hear the bind late thing, I think of error recovery. In all three of the, so let's limit our discussion today to RISC-V, AMD, and Intel, if that's okay, because they're the only ones I kind of can kind of point to the objects. That all three of those put the binding operation as a host operation. If the endpoint device arrives in the guest either not already bound, or if it falls out of run state into the error state, it seems like Linux is going to need a way. So those two scenarios, either it's not bound or it's an error state, we need a way to get it to convert it back in. And to me, that seems like a interface for the guest to ask the host to please rebind. And if we generically need that for all the implementations, my proposal is that we don't have Intel go do an extension, RISC go do an extension, and AMD go do an extension. What do we think of that? Do we need a common ghost host interface for those kind of across vendor common operations? Or did I lose everybody already?
Actually, I think you're asking the wrong question if you want to persuade them. The right question is, what would be the reason we would need them to be different across all of the vendors? And if the answer comes back, we can't think of anything, then do it this way.
Okay, yeah. Yeah, I can't, so if the interface to the TSM is the bind verb, I can't think of any reason why the Linux tunnel to that thing couldn't be common, because we're going to have this over here, the second bullet here, this common set of verbs across, like this would be the driver interface. There's lots of details behind those APIs. Like I'm not like, I think Intel requires a different number of resources to do a connection than maybe AMD does. Like we might need to, hey TSM, here's your pool of pages to do this operation. Go ahead.
So one thing to also think about is in the SevTIO architecture, there are some things that cannot actually be done by the Linux kernel. They can only be done by the SVSM in VMPL 0. So there are going to be some operations that actually need an SVSM call, which there's a protocol for that we publish, but it's not actually going to go to the hypervisor immediately. It has to first go through the SVSM. That includes some things around the configuration of the device, like assigning what DMA it can do, things like that.
So yeah, I hadn't been assuming that SVSM was a required part of these verbs.
It's not a required part, but it's a possibility that it exists. In which case, I'm just saying that call is going to have to go to the SVSM before it goes to the hypervisor.
But I would expect that would be invisible to Linux, right? Like the SPSM is basically the L2 or the most nested one is just calling up, and whether SPSM intercepts it or not.
It's not fully invisible, right? It's like a hypercall.
Okay.
Yeah, you're going to have to ask the hypervisor to run the VMPL0 portion of the guest in order to accomplish that.
Is that something that can be hidden in your driver that basically is doing that translation? Sean has a question.
Harebrained idea. Can you guys switch directly from VMPL3 to VMPL0? By the time this lands, could you land in hardware? Darn.
Yeah. So I guess what I'm trying to get to today is what do we want our in-kernel abstraction layer to look like, and who's sitting behind that, and what are the parameters? And I kind of want to be inspired by IOMMUFD, which I need to look more into, but in terms of having generic IOMMUFD objects and operations with hardware vendor specific attributes and things that can come along for the ride.
Yeah, I mean, we do that kind of today with like page state change, right? When you do a set memory, there's where we populate the x86 platform guest, blah, 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 right? So if you were to kind of create a couple of callbacks there, right, then each vendor, as the system's coming up, if it's a SEV, they populate theirs. You have one common call that gets into there.
Okay. Yeah, I mean, so I'm not hearing any disqualifying things that would make SVM being in the path a problem or not.
Right.
But I reserve the right to change my mind. Okay, so if we're supposing that we need some kind of common Linux guest to host interface thing, one of the topics that came up in Jason's talk was, for me, I'm missing the piece about how we do a common enumeration of device abilities in the guest, and we have this kind of common problem of, we could define our own config space and do our own thing, but we can't be guaranteed to have free config space in the virtual function to use it to define our special thing. So I had initially thought about it like mimicking how ACPI has companion devices. We would have a companion secure IO, almost looks like firmware in the guest that's doing that extra enumeration for you. But if we can get it into config space, that's probably easier, because Sean was saying it's not great to go down the Parabird path. So if we can get things in the standards, it's easier. So if we have a standard way to communicate to a guest, like this device has these capabilities for SPDM IDE, TDISP, and Elena's had a request also to, if we had the interface, we could also add, is this device supposed to be here in the first place? Which is just a manifest that can be passed in, that's consulted over this interface. Like before you even try to do the complicated TSM association thing, should this device be filtered in the first place? But so barring somebody saying no, we shouldn't do that, I'm thinking that we need this. But go ahead.
For discovering SPDM, for discovering SPDM, TDISP, and IDE, this is, I mean, if that's what we need to discover, it's basically, that's specified already.
That's specified only on the physical function. Like there's no standard for like how you tell a guest, like when this device shows up in the guest, how does the guest know that?
But the guest shouldn't know that it has to do a SPDM or IDE. This is TSM specific. The guest doesn't care if it's SPDM or the guest actually will talk to the TSM to make sure that IDE is established.
Right. That's what I'm saying. Like it's not that the guest is going to set up IDE. The guest is asking, is it already set up?
Yeah, but it's like the info verb that you have there. It's not a verb, but so it's basically the guest getting information about the device that is trying to verify or test, and asking the TSM, have you established an IDE link?
Mhm.
And you trust the TSM for establishing this link.
Well, but like we would be asking info on, like, we run, taking an example, we run info on every single virtual PCI device we see in the guest, and
Yeah.
to see if the TSM says, yeah, I know about this. Yeah, no, I don't know about this.
I think that's the idea. Yeah, you want to get information, trusted information.
Okay.
Because if you get information from your PCI config space, this is all emulated by the VMM, so it's not trusted.
Right. No, it's not trusted. Right.
So the only trusted piece of information that you can get is from the TSM.
Right.
Oh.
I mean, for trusted devices, that's true. So what about if you want to add some VirtIO devices or something else, or something which doesn't support the stuff? So this was more my angle. So, but we want to also be able to say, but okay, we might decide, we might decide to support some other devices which are not trusted IO devices, but not all the devices.
Like the think of the case of you don't need to go as far as a compromise CA, but like, let's say somebody plugs in a fully functional device that's just not supposed to be there. Like, you don't want the guest to even try to. You may not want the guest to even try to enumerate it if somebody can, if the host can tell you that wasn't something I put there. But
You can't trust that host.
Yeah.
The host tells you, I don't want to put it there. I mean, the host puts it.
The host puts it there. Right.
I think it's fine if you have the host filtering, because basically if the host is filtering, it's just removing devices. It's like a denial of service attack,
Yeah,
which
so
is
that-
out of scope from my point of view.
The host filtering is, I think, the host can be ready.
Okay.
So the threat here is not about the, we're afraid of the host, and when we're afraid of the drivers which will start to run and the guests which are not prepared to handle it.
That's what TDS is for.
Right, but for that, if you only can say that you only support in your configuration trusted IO devices, then you're good. But like,
You only
so if you only say that for my VMs, I only support trusted IO devices, then you're good. But
I think adding support for VirtIO devices, in my opinion, this is on scope for what we talked. This is a completely different.
No, I'm saying this is for not for trusted devices. So.
Yeah.
Yeah. No.
Yeah. We'll focus on trusted devices, but I think the question for me though is so it's either guest asks the host via the TSM verb info about everything it sees, and the guest and if you get no response, then the TSM like, I didn't put that there. Okay.
Or I couldn't establish an IDE session. I couldn't set IDE keys, or I couldn't establish an SPD session. So yeah, do whatever you want, but it's not trusted.
Okay. So, but then how do we invoke info in PCI discovery? So like with ACPI companion devices, you do the PCI enumeration. You look and see, hey, firmware, did you publish any secondary information? I go call the other thing. So
Where's the ACPI device coming from?
where's the what?
The ACPI device coming from.
Well, no. So I'm saying that's how ACPI device is a look aside lookup in something else. An enlightened guest that's trying to do secure devices would call something to run info.
You would have a set of ACPI tables saying those are the devices that I'm supposed to know
Either
about.
ACPI, or it could be a VirtIO thing, or well, and when I say VirtIO, like this generic Linux guest to host thing is I'm worried it's also going to be something that each VMM is going to want to implement different. Like you're going to get a VirtIO thing on KVM and a Hyper-V thing.
It doesn't hit the VMM. The info stays between the guest and the TSM. It never reaches the VMM.
Right. No, but like I'm like something more basic. Like what from the PCI enumeration code, what is it calling to get into this regime of sending a guest to host communication request?
So I mean, I think it's, from a security standpoint, I think it's reasonable for the host to explain what devices are available,
right?
Whether they are trusted devices or not trusted devices, whether they're already bound, that kind of information.
Right.
The guest does have to verify that when it talks with info and the other similar kinds of verbs that it's going to be doing from its side to get the attestation report from the TSM. But I think it's reasonable for the host to provide some manifest that's easy to get and it's early, in the enumeration process.
Okay. Yeah.
So yeah.
Okay. So I guess what I'm hearing is the guest is going to load. Guest is going to detect somehow I'm a TDS guest, I'm a SEB guest, or I'm a COPE guest, and it's going to call an info entry point that's routed to that guest to host interface backend, and you're saying that this should be something that each vendor implements, not something that Linux does generically. Ask the question.
I think the verb should be generic and it should be a generic ABI provided by the Linux kernel.
Okay.
Or implemented in the Linux kernel internally and have specific hooks for it's basically an hypercall between the guest and the TSM.
Yeah. Okay. So
for each and every vendor would translate that into its own hypercall, but the internal implementation, I mean, you would have a common implementation within the kernel or as a kernel.
Yeah. Right.
And then have specific hooks per vendor because you're going to have different IP calls anyway.
Right.
Different TSM implementation.
Yeah.
So, but you're saying it goes vendor specific inside the guest. It doesn't go vendor specific after it crosses over into the host.
Exactly. Inside the guest, inside the kernel, there's a part that's going to be non-vendor specific and the part that actually translates your info request into a vendor specific IP call.
Yeah.
Exactly as you're showing it, right? In the picture, you have the GHCX and the Linux CVM.
Yeah, but when I hear Samuel saying, I think he's saying that there's a vendor. We're only going over all of this is going. This path is always.
It's an IP. I mean, even. Yes. You would have like a.
So it would be horrible. So basically, this box doesn't exist. It's only this thing and this thing.
Correct.
Okay.
Yes. So info should be something that each and every vendor is free to implement the way it wants.
Okay. What about this? That makes sense. I can't live think of a way. That's not bad. Yeah.
Where in the probe call?
Sorry.
You talked about exactly where you should hook this call in the PCI probing infrastructure.
Right.
Why should the info call be even that late? It could be very early in the boot sequence. I want to know.
PCI probe is really early.
Okay. I mean the info call.
So, but the info is like the host put a virtual PCI device in my topology. The first time I see it, I'm going to ask info about it.
Okay.
Okay. So numeration. No. What I'm thinking. No, throw that away. What about this question of how do we trigger operations that are only run by the host? Like, so if we want to trigger, if guest wants to trigger bind, that
host triggers bind.
The guest is asking, like, imagine we bound the device and it fell out and we have an error state. Would we just, the one option is kill the TVM?
Guest is not going to trigger bind.
It's going to ask the host to bind.
Oh, to rebind, yeah. Okay.
Rebind. Yeah, think about rebind.
Okay.
Rebind or post bind.
But the guest is not going to trigger bind if it doesn't even know about the devices. I mean.
Correct.
Yeah.
Correct.
So rebind or post bind.
Right. So we got our info. We know this device. Our TSM knows about it, and then info says this device doesn't have an SPDM session, doesn't have IDE set up. What do we do? Do we ask AMD, Intel, and RISC-V to give us a rebind verb through their path, or do we have Linux go through its own hypercall into whatever is? You were saying that we don't need KVM to terminate calls, that the guest has its own way to do IOM operations without needing a KVM operation. Am I crossing the streams?
There are endless ways to basically exit from the guest into the VMM. There's some that end in KVM. There's some that end up in QMU. Okay. There's some that end up here, there, and everywhere. Pick your poison. You can pick what you pick.
Good poison.
So don't get so fixated on honestly, KVM should not be touching anything to do with PCI. That's outside its remit. That belongs either in VFIO or IOMMU. Period.
Okay.
Right. So when you're talking about all these things, you need a hypercall at some point to get the TDIF locked. That has to be done by the VMM, as far as I know, right?
The VMM has to do that, yeah. And so triggering that, we'd pick our poison in a non KVM way to trigger that.
And on the rebind, you need to get info first again. So if you unbind for some error state, basically, you want to get again the new measurement, whether like, is it a fatal error? Is it like something you can recover from?
Right.
And before I rebind, I want to make sure that, the device is still in an okay state for me to rebind.
Yeah. I mean, the error recovery is going to be a very negotiated thing with device drivers and things. One of the things that made me cry was like, there's no way to inject AER errors into. Well, there's an AER injection thing, and QEMU just says to do inject errors into guess. Good catch.
So we had a long talk about that in a certain working group about how AER relates to like the world, and the feeling. There's certainly a strong feeling that AER is really only about should really only be about the physical layer. Like, oh, I had a CFC error in my PCI link, or my PCI link went sideways or something, and then more functional levels things should be maybe a different thing.
The problem for me though is that IDE is a link state, and so and if that link state changes, how do we notify the guest? I mean, it actually. Are TDISP errors signaled via just MS? Like, how are TDISP errors signaled? They're not signaled. Yeah, we just.
Can the guest do anything? Like, if the guest can't do anything reasonable to recover from any of these errors, don't tell the guest. Seriously, just shoot it.
Well, yeah. So yeah. I mean, like V1, I think we should shoot it.
Like, unless you have a concrete use case where you can recover from it, just shoot the guest, shed a tear, and move on. Because no customer is going to be like, oh, I'm going to keep going without my NIC.
We did this for unexpected memory, right? Like if you run in there and the guest gets a VE for it, right? But it can't do anything. All I can do is say, host, please help. And the host already screwed it over. So there's no effort.
Okay, let's shoot it until somebody tells otherwise.
I agree with doing that for V1, but I think going forward, we may have to look at recovering from it.
We'll circle back to V2.
Reality is on a host, we lose the NIC, we do recover. So there's no actual reason you can't do it. It's more complicated, so don't do it first.
Well, so my understanding of error handling is we're going to have some vendor driver who's going to be like, oh, we detected the error state and we want to come back somehow, and we'll tell them to send us patches.
Even if you can come back though, do you need to tell? Does the guest need to do anything?
The guest needs to rebind the device.
That's the.
I don't want.
But but this is the real world. Like, I was going to say, like, we all have RAS things in our enterprise drivers. Like in our NIC driver, if something goes wonky in the firmware, we do a complicated sequence where we FLR the device and we start it back up again and blah, 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 right? So you would want to keep that ability.
Yeah, and so I think for the core kernel side, we're going to have a way for drivers to say, please try to rebind. Because that'll be part of somebody's complicated error flow.
Right. I mean, all I was going to say is that from my understanding of the error handling, the only way you can get the TDI out of TDISP error is unbinded. You have to do the teardown flow, which then necessarily requires you to do a rebind. You may not want to rebind for every case, but there may be cases where you do. But you have to unbind. That's the only way you can. The only entity that unbind is.
It's the host's responsibility to unbind. So the guest will basically tell the host, move this thing out of error state.
Yes, right.
That's it.
Yes, that's it. That's it.
Yes.
Guest initiated.
Not initiating, asking the host, telling the host, please unbind this thing.
Okay, yeah. Throw it back, but the guest wouldn't say unbind, right? It would just go to TDISP error state. It wouldn't. The guest would never.
That's
have to do
where
anything.
I'm still lost. If it's just a request to the host, why would the host not just unbind?
Because it doesn't know if the guest accepted it or not. The host can basically.
No. I may have spent way too much time talking with folks about this one, but there are some errors that are only going to be detected by the host. There are some that the guest may detect. More often than not, if you see it in the TDISP error state, you want to unbind it as the host. You do not want to wait for the guest to make that request.
Oh, I see. Okay. Well, so I think we all agreed that this is going to be a V2 thing. Another another tasting while we have people in the room is circling back to these TSMs are restricted execution environments. So it's either tiny PSPs or TDX modules that are trying to reduce the amount of code that runs in them and non-interruptible and blah, 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 blah. One of the ways they survive that world is by asking for help from the VMM. One thing that's common across, and I think Samuel said risk of the same thing, is they need the VMM to do the config cycles, to do the SPDM stuff. So the actual SPDM protocol is running in the TSM, but then the TSM requests service from the VMM, say, please send this opaque blob of stuff to this SPDM endpoint and take that blob you get back and give it back to me. But the kernel has no idea what's going on because it's all encrypted with the key that only TSM sees. So that's the first kind of concession that every vendor needs the VMM to make, is please let us put a dispatcher somewhere in the VMM that's doing this service.
In theory, in TDISP, it could be out of band. Does anyone care? So you could be talking directly from your TSM to the devices to set all of this up by MGTP or whatever.
Yeah. Like I don't think you have to use the SPDM dispatcher. Like I think if you have a capable TSM that can do it behind the scenes, then great.
Yeah, I was going to say the canonical model is to go through the host, because you don't, I mean, as much as possible, the TSMs really just enforce the security invariants. They don't try to do any resource management.
Okay.
So anything you do in sideband is a bad idea.
Okay,
from a host management perspective.
Okay, so our common language is that SPDM is a resource that we don't want TSM to be in control of.
Which is that it is possible that you could talk to the TSM and it has no SPDM work for you to do, and that is totally legal, right?
Right.
So it may need those SPDM resources, but not always.
Okay, that's okay. Okay, this is where I get to have because I got the mic, I can have a Intel specific request, but the patch is going to come out anyway, so it's like I can't hide this forever. So inside the TSM on Intel, there's a TDX module that's tiny and small, and they're like, yay, it's tiny and small. And then TS Connect came around. It's like, oh, we got to do much more stuff, and we don't want to blow up the TDX module. Where can we put this code that still needs to run in a trusted context, but not inside this TDX module? This is where we get a helper, a special helper TVM TD that TX module knows about, and they have a communication path to say, hey, hey TPA, it's called the TPA. Hey TPA, I need help. So similar to how TSM module says, VMM, I need you to do the SPDM resources. This is, hey TPA, I need some service here. So the request here is that we'd also have a command. This is a command dispatcher, but this is really just dispatching commands that the TPA needs to do. So this is like the TPA is going to control resources that are not SPDM, that are talking to the. I do not know. I do not know. The T is probably trust something, but the person writing the TPA-TD is the same person that is GWen, who's helping on the RISC-V side. That TPA is written in Rust, so if that helps people tolerate this thing a bit more. It's secure. So barring anybody saying, I'm probably not going to get much pushback in this room, we would also have a command dispatcher, but this might be just shuffling TPA requests and calling TDX module, but nobody else really has to worry about that. Okay, what else do we have in here? So the other. I think this is kind of relevant for the authentication discussion we had before, and this is where it's good to have people with different viewpoints, so we can bash it out. I really like and respect all the stuff that Lucas did, and but we also want to talk about what are we doing with where IDE is managed. One of the details I've noticed that sets Intel platforms apart that I think maybe gives false hope about the ability of native Linux to handle IDE is that Intel lets you opt the root port key programming out of TSM control and into a native protocol described by a really hairy ACPI table. Talking to AMD and RISC-V, they don't allow that. The only way to program root port IDE keys is to go through the TSM interface. And for me, when you think about it, if it's at the platform level, that's effectively a TSM. That's a firmware interface. Yes, ACPI describing it lets you write native code, but it's still a platform specific solution. But so where I'm going with this is the idea that at least in the near term, to get stuff upstream, that we're not going to try to have parallel discussions about where to put IDE key management in the native case versus just saying for V1, maybe V2 we could have a native IDE key management stack, but for V1, IDE key management is always behind the TSM interface on all platforms. I'm not seeing any head shake. Oh wait, we got one.
I think the key thing here is the IDE is relevant to embedded use cases. No one's surfaced yet, but there may be systems that don't have a TSM that do care about IDE programming, and they will expose it via something vaguely normal.
Okay.
So some register writing, or they'll run a whole SPDM session down to the root port and do it that way.
Yeah. I'm not saying that we would never the Linux would never support it. It's more like for people like Bjorn, who are watching this wave of patches that are upcoming. Do we want him to have to review the IDE key management protocol versus because we still need to touch PCI in this for resource management. Ask a stupid question. Go ahead.
This is for the SPDM people.
Okay.
Why do we have to care about the keys? I thought you said this was modeled on TLS. When I do TLS, all I care about are the certificates that do the keys. The keys are all managed at the lower level. Why do we need to bother? You want to do it? Take this?
So,
do we have? Go ahead online.
Yeah.
Lucas. Lucas.
Right. So, I'm not sure if I understood the question correctly, but for IDE, because it's symmetric encryption, you have to program the same set of keys both into the root port and into the endpoint.
That's not the point. I mean, TLS at base is a symmetric encrypted protocol. It's usually AES. But what happens is you have certificates on either end that are authentication, and once you've authenticated, the two ends of the link just do Diffie-Hellman ephemeral and establish the session key for themselves for the encryption.
That happens in SPDM, but when you don't run that traffic, you don't run your data through SPDM later, and that's the difference here. So we're establishing the PCI encryption keys, the ID encryption keys for running the data. With SPDM stays as a control channel.
Yeah.
And that's why you do essentially Diffie-Hellman exchange, where you generate a session key, you have protected session on SPDM from there on, but it's not used for actual data transfer.
So I understand why you're doing it. I just don't understand why you can't do it automatically.
I don't know why.
Oh, yeah, you'll make Okay. Okay.
It boils down to the fact that there's no standard for how to get it into the various pieces of hardware. IMDEF hosts.
Which is pretty much why we're here today. Is like every host came up with their own different ways to do it. Okay, but so I saw a lot of head nodding there. Moving through these things. Go ahead.
Can you just close off on the IDE but no TDIS case?
IDE but no TDIS. Yeah, go ahead.
I don't think we're saying we don't want to do it. We just once we have hardware that yes, give us hardware.
Well,
but also, no, he wasn't saying IDE with no TDIS. He's saying IDE with no TSM.
We've also got the mess here of, I can't remember what they're called, selective IDE, which you typically be using for this stuff, and link IDE, which is where you potentially are programming between a switch and a device, and it goes nowhere near the host. That's all well defined in PCI. So you sit there. If you're going from say you've got a switch and the downstream ports are exposed on a socket on the side of your server, and getting wired out to somewhere else. That the encryption of that link is purely fully defined CMA, set up the keys, exchange them, everything clear of the stuff that's in BoF.
It would be very nice if the embedded people that decided they wanted to do IDE did some kind of proprietary thing to have it like James said, just have it already set up for the root ports and only have to do the link IDE at the end. That'd be great.
For this stuff, you only care about selective IDE, which means that the root port is always the relevant one anyway, because you're going all the way through the switches. But there's a perfectly good use case for whatever the other one's called. Is it link IDE?
Yeah, link IDE is the point-to-point one, right?
Yeah, so the point-to-point one has lots of use cases too, but they're very, very different. But that stuff is absolutely standards defined,
Okay.
And we can add it trivially.
Okay. Not sure how I'm doing at time.
Nothing in this room.
That's what James. Okay.
Well, they'll come in a sec if they're ours.
So let's try to have a conversation about this complicated box, the IOMMU box. I like up until Jason was like, please do not put stuff in KVM. Please put stuff, directly into the IOMMU drivers. I want to have a conversation about what does that look like? So, like in terms of what you would want to see, Jason, in IOMMU drivers that these verbs be routed through something in each vendor's IOMMU driver would have their TSM call in there.
So my understanding is still pretty basic of all this stuff. So
Okay.
I'll just
preface with that. Okay.
I'll preface with that and maybe elucidate a bit about my feelings. So my understanding is that when you take effectively a RID, a PCI RID, a routing ID, and you give it to the TCM and you say maybe connect, or I forget what word we were using, and then eventually you say locked,
or bind, yeah.
No, I mean locked. Locked means it's
bind is the verb that translates to TDIS locked.
Lovely.
Okay.
So it becomes, but as part of this, all the models that I've heard of have the TSM take control of at least some of the IOMMU hardware associated with that RID, right? And that's where I come from. Like, so if the IOMMU hardware is behaving differently, then the IOMMU driver should be aware that the hardware is behaving differently. Otherwise, you're opening yourself up to a huge mess, right? So when you enable the possibility for it to behave differently, that should go through the IOMMU driver. It should take note of it. And the IOMMU driver should have a way to undo it and regain full control of the hardware later when it's appropriate. Does anybody, am I wrong?
Yeah.
The way I remind it is like the IOMMU has a shadow page table that is under the control of the TSM. And so as long as
or shared APT or RMP, something or other.
Yeah.
Device, yeah. Okay.
Yeah.
RID.
So as long as what you do inside the IOMMU match what that table is telling you, you're good. So if somebody you screw up, or like, you know, have bug somewhere, you go to the error state, and then you have to redo the whole dance.
I mean, it's a broader sense. Like, let's say your VMM crashes. Like, forget about error states and things. Your VMM crashed. I'm starting, you know, the kernel's randomly closing file descriptors. How do I sequence that explosive deconstruction in a way that I get back to a consistent state? Right. The IOMMU driver is the one that knows exactly when it regains control of the device, and it should regain full control of the RID, not partial control and wait for KVM to finish whatever it was doing in its explosive deconstruction. Right. That I think is really important, because if you don't do that, you're going to have a locking nightmare that's going to never be correct.
So in the TIO solution, the way we've planned it is that if something like that happened, you would back out of that bound state by unbinding, and that unbinding command would go clear like the RID tables that contain that kind of stuff. So if the IMMU driver can be either aware of it or trigger it, you know, whatever, that would be I think what you're looking for us.
Are we kind of resolving around like unbind should be a verb that IMU drivers call? And probably bind as well?
If you want to have any chance of this, you can't go through the TSM. If you're in a crash state and something's wonky, all of these things route through KVM to get into the TSM. KVM is controlling that transfer point. What? Yes. Yeah. TDX, you want to talk to the TSM, you're going through KVM. SMP, you want to talk to anything guest related, not PSP so much, you're going through KVM. I don't know about Cove. Same for Cove. Android, ARM, probably similar. Actually, okay, yes, ARM is the similar thing because it's not a world switch, but it's a realm change. So to get into the secure state, you have to transition the CPU physically into a secure state, which because KVM is the one. So like with TDX, the way it works is it is it's going through virtualization transitions to get from root untrusted mode to root SIEM mode, which is the trusted mode. And you could probably actually teach IOMMU how to do that, but the complication there is you have to be post VMX on because it's a VM exit technically to get from root untrusted to root SIEM mode. Intel does that. It's wonderful.
Doesn't this blow up some of the stuff that Dan, you were talking about earlier, where you're saying, hey, let's make the TSM do everything? Like, or doing early boot and stuff.
Yeah, no, there's wild complications around that. Like, I mean, the way this works outside of IO is that you can completely recover if your TSM goes down outside of IO, you can completely recover all of your memory, which is, except for a few things that you gifted to the TSM, knowing that you would never get them back, but those are small chunks. But any memory that you would assign to the guest, you can get back. At least on TDX. SMP is a little bit different, and they all have different flavors. Recovery on this stuff is sketchy. Yes.
But the hardware goes into a special mode. I mean, that's the other thing here is that like loading the TSM module takes the hardware into a special mode that doesn't act like it did before. And the VMX on thing doesn't happen until we've taken it into the special mode. Like the TX module has to be loaded. And at that point, the hardware isn't the hardware anymore. It's behaving goofy. Like there's things that you've lost control of, like MSRs get locked down.
No. I mean, you've changed fundamentally some aspects, but like the difference is memory that you've given to the guest for TDX model, you've encrypted with some goofy keys. You can't access those. If the guest goes down or the TSM goes down, the host can recover all that memory by sanitizing the keys that are used and the encryption crap, and it's gone. The TSM dies, but you can do all the other things you were doing in a slightly different state. You can turn off VMX. You can completely unload KVM if you wanted to. Like, you can't run any new TSM guests, but you can run normal guests. My understanding with the secure IO stuff, you've got an even smaller chance of being able to recover. And I think other platforms might even be worse, depending on worse or better. Like SMP, you can talk to the PSP more directly without some of the restrictions of KVM. But if your PSP goes down, you are really hosed.
Oh yeah, like yeah.
So things like that.
If the TSM goes down, yeah, you're super hosed. But I was missing the detail, like why, like say we invent this Linux native communication path. Why would that go through? Why would they need to go through KVM?
Because for everything except SNP, the trusted part runs on the core. It does not run on a coprocessor that you talk to over whatever interface the PSP communicates with the core from. So you are running your trusted, your TSM, your TDX code is running on the same physical CPU that your host code is running on, that your guest code is running on.
Right.
That goes through KVM because KVM has the calls into that. You could teach VFIO how to get in there, but then we have a different conundrum we are dealing with. ARM is going to be the same way. I'm assuming Cove is the same way. I'm 100% sure on TDX. To do a SIEM call, it is literally a VM exit.
Well, I mean, about ARM, like
ARM is a realm switch. You have to go down to EL3 and EL2.
Right.
Yeah.
Already has realms. They already have like trust zone and the other areas in the processor. And my understanding was that the realm manager was like that, and that it didn't rely on KVM to be in existence, right? And I guess all I'm asking for, I don't actually care. Like, can you give the IOMU driver a function call to do bind and unbind? Yes or no? That doesn't require a KVM file descriptor. Oh my God. So you've reinvented S390.
We can't do generic. We lose the ability to do VM exit hypercalls.
You could. You can make the seam call blindly to some extent. The thing you would need to know is have some tracking of the state of, can I do the seam call?
We're not doing it. Like
But you can do it.
managing, getting the CPU in and out of VMX mode is okay.
Actually, that part, if for TDX specifically, it's really just post VMX on that we can shove down into core kernel and get it out of KVM. That solves that particular problem. Like, these are all solvable.
Okay.
I mean, like, we could have a policy of, if you want to use secure IO, you turn VMX on and you leave it on. The only reason we muck around with turning VMX on and off is some, misguided security stuff from 15 years ago. I mean, like,
we want to replace that with new misguided security stuff.
People had like these crazy ideas. Oh, if you turn on virtualization, your platform becomes less secure. Like, who in their right mind thinks that that's a problem in a cloud provider that's doing secure IO?
Yeah.
Just turn VMX on, and then you can do seam calls somewhat blindly from VFIO, and we're happy.
Okay.
You may have some issues with. You're going to probably run into issues if you need to have something that is tied to the VM, because that is a physical address pointer that serves as your handle to communicate, I want to do something with this VM. So
yeah. I mean, eventually, when you do the binding to KVM, the Linux model binding to KVM.
Eventually, when you do the bind, you need a KVM FD, because in the Linux model, you're binding to a KVM FD that represents some kind of platform object. Like in ARM, it's a VM ID, and I have no idea what Intel's done. But, that's the shared platform object. And we have a couple of touch points in the IOMU where it needs to know the VM ID in ARM sense, or whatever it is in Intel sense, especially if we're going to do shared EPT tables or any of that other stuff. So that, there will be a KVM available, I suppose, in hindsight. And I guess it could remain available during the unbind. It's a little bit more sketch, but yeah.
Okay.
Your main concern was like, host should be
My mic.
Your main concern was host should be able to unilaterally take the IOMMU back, right? That was sort of like the root concern you had, and so that you might have to route that through KVM, but you probably know that because when you look at that IOMMU that you want to reclaim, you would have at some point a priori assigned it to the TVM, right, to a confidential VM container to manage through the TSM. So you would have interface with KVM probably there anyway. So as long as you have that context, you can.
I think it's a solvable problem. We may not like all aspects of the problem that in the ways that we solve it, but I think for most cases it is solvable. It's just what you're going to have to pass around some information. But I'm pretty confident, at least I don't know about SMP, but for the other ones, I'm pretty confident you could pass around opaque handles and you could do the teardowns mostly safely without calling. Like, your teardown might have to be wrapped with some fault log. Actually, it's not going to fault. It'll have to play nice with errors. Like, it might be best effort sort of thing. And then if something goes wrong, then you go down to like, okay, I can't reclaim that part of the IOMMU. Just like just the standard thing. Like if you
can't,
if it's gotten so bad that
fail
you're trying to acquire a spin lock and you deadlock because something crashed while I was holding a spin lock, it's kind of on the same level of fatality. But I think it's a solvable problem of not having to route things through KVM, because I agree that gets messy because you're hoping that KVM is not holding some lock that it held when things went sideways.
Okay. So. James told me that we have exhausted the time here. I do want to thank everybody for the participation, and the summary I've taken away is that I think as a community, we can definitely try to meet at a course granularity that happens to look very much like TIO, and start there, and that if we argue too much in the kernel community and make other subsystems upset, Greg's going to come in and push us all the way down into EFI, and we don't want. And we'll be writing EFI IOMU drivers, and I don't think we want to do that. So let's all work together and keep us at a copacetic level. Yep.
Define what we want is.
Well, that's so. But yeah, maybe before everybody packs up and leaves. Like for me, like V1 is, I think, being able to do the info thing, and if the device is already in the bind state, great. That we do the accept, and that's V1. And then V2 is we can start to think about what happens if it's not already in the bound state. On the guest side, yeah. On the host side, what I don't know is this block here, the whatever we're doing on the VMM kind of TSM interface. Like ideally this would not be like /dev/sev/dev/tdx/dev, that we would have a common ABI for whatever user space needs to do to tell KVM or tell, but similar to RMFUFD, we would have TSMFD or something like this. That's common. Everybody uses TSMFD, and we find a place to stash everybody's specialness. I don't know in the Lexi patches if there's already this not common device. Like that's the piece I haven't looked at. Is I would love to have that ABI defined for V1 too. Is TSMFD.
I think one thing to add to Jason's point is it's not a hard requirement, but if the hardware vendors or the people defining the TSM parts can allow the IOMMU to cleanly tear down with as few assets required as possible, the better.
Typically, if you kill the IOMMU, it's fine.
The device goes to error mode. The device is not supposed to send any more traffic to the host.
No, but how do we clean up the IOMMU?
Well, you tear down everything. You're just like
no, we're gonna tear down everything. But I think Sean's point is like in that teardown process, like please don't require like new resources to tear down or make maybe
option instead of a scalpel.
Yes, yeah.
So that you can just pave over.
Keep it coarse grained, pave it over, and then when people say, "Hey, that's too coarse," like, oh, good, instead of patches. Yeah.
Yeah.
Put down. Okay. Yeah. So we'll. So I think the next level. I don't know. I'll find a place to post it. But if you're not already, we have a Discord channel where we chat. It's not very chatty. Like, yeah. Well, okay. We can switch to Matrix, but like I want. The point is, if you're not on that, let me know, and we'll get you on there. It's invite only to keep it sane. But if anybody's in there, you can freely share the Discord link. We'll get more people on there. Yeah. Oh, and so yeah, so this LPC was in lieu of our monthly call, and we'll do a December. We will continue our monthly calls, and yeah, also send me a note if you want to be added to the. Well, actually, join the Discord because that's where we do the doodle poll to decide the time for the next call, and we can continue the conversation. Thank you so much for letting me run over, and have a good rest of your day.
I'm not sure
I I see just more this week. Yeah.
Well,
I see some more here.
Yeah.